Hey everyone, I'm Morgan Willis, Principal Cloud Technologist at AWS, and I want to welcome you to this course. In this course, you will learn the key concepts behind cloud computing and explore AWS services using real-life examples covering compute, networking, storage, databases, security, and more. This course is intended for people working in IT or IT-related fields who have a general knowledge of IT topics but have yet to learn much about the AWS cloud. To kick off the course, we will cover the basics of what the cloud is, the benefits of the cloud, the AWS global infrastructure, and identity and access management. This will give you a solid foundation for learning the rest of the more technical topics contained in the course. Then we will focus on computing, and for this topic, we will dig into the services Amazon Elastic Compute Cloud, AWS container services like Amazon Elastic Container Service, and serverless compute options like AWS Lambda. Then we will discuss networking in AWS using services like Amazon Virtual Private Cloud and other networking technologies used for creating, securing, and connecting to your own private network in AWS. For storage, we'll explore how and when to use Amazon S3, Amazon Elastic Block Store, and others. For databases, we will cover many use cases around the different database services AWS has to offer, but with a special focus on Amazon Relational Database Service and Amazon DynamoDB. Then finally, we will discuss monitoring and scaling your application. For that, we'll use Amazon CloudWatch and Amazon EC2 auto-scaling alongside Elastic Load Balancing. We aren't going to focus on theory alone in this course. Instead, we will use a hands-on example through a cloud-based application that will build over the duration of the course piece by piece. The app we will build is an employee directory application that stores images and information about fictional employees in a company. There's no coding required for this course. You will have access to the source code if you want to explore it further. This course includes written segments we refer to as readings or notes to reinforce ideas, dive deeper into topics, as well as provide background information on concepts we did not cover in the videos. Because of this, I highly suggest that you take the time to complete all of the readings to get the full benefit of the course. So, again, welcome, and as we say at Amazon, work hard, have fun, and make history. Hey everyone, my name is Morgan Willis. I'm a Principal Cloud Technologist with AWS. What that means is I essentially build things, learn AWS, and then I get to share my knowledge with you all. I had a career in software development before I started working in training and certification here at AWS. I really love technology and have been in the field for over 10 years in roles from technical support to database administration to web application development. And while it's true that I do love technology, I also have a regular life outside of work where I like to hike in the beautiful sun, rain, sleet, or snow. I also like to ski and really enjoy just about any outdoor activity all seasons of the year. I'm looking forward to helping you navigate the world of AWS over the coming lessons. And this here is Meowsy. He's my trusted sidekick. He spends time with me while I type away on my computer, and I think he's picked up a thing or two over the years. His knowledge of AWS at this point is pretty great for a cat. I think I can even hear him sneaking on my computer in the middle of the night to build his own solutions on AWS. I have a feeling his knowledge will come in handy for this course. More on that later.
Hey y'all, I'm Seth. I'm a cloud technologist with AWS, and I've been working with the AWS cloud for close to 15 years. Like Morgan, I have spent most of that time learning, building, and sharing my knowledge with customers like yourself. In addition to my experience with AWS, I have worked in a variety of industries, and I've been on both the data center and the cloud side of infrastructures. Outside of my life in tech, I mostly enjoy spending time with friends, which primarily includes my 4-year-old wonder dog named Fluffy. Speaking of Fluffy, sometimes I think she knows more about AWS than she lets on. Every once in a while, I notice her drawing AWS architectures in a journal, and I wonder where she learned all of this. She can't bring me the ball back when we play fetch, but she always wags her tail when I mention cloud computing. I think Fluffy has something to say about cloud computing, so stay tuned for some of her helpful tips and tricks.
Hi there, my name is Morgan Willis, and I'm a Principal Cloud Technologist here at AWS. As you're working your way through the course, you may want to get in touch with the AWS community or reach out to the team who created this course. This video is to help you understand where to direct your questions. You may have questions about the AWS services you are learning about, or you might find that you have a specific question about something you are working on related to AWS. For these types of questions, I highly recommend you check out Repost. Repost can be found at the URL repost.aws, and this website gives you access to a vibrant community where you can ask AWS-related questions and get answers. Something to keep in mind about our courses is that AWS innovates at an extremely fast rate. This means that some of our content can get slightly out of date when new features are released or if the AWS console changes. If you see any out-of-date, incorrect, or broken content, you can contact us course creators directly by reporting the issue using the form that is included in the course materials following this video. An example of something you would use this form for is a hands-on tutorial or exercise that has instructions that are out of date or are no longer correct. If you have something go wrong within your AWS console while working through an exercise or lab, this is not something that you would enter a ticket for, as we will not have access to your specific AWS account. The ticket system is meant as a place to report issues with our courses. Finally, if you have a question about a course completion certificate or anything related to the learning platform you are taking this course on, please reach out to the learning platform to support and resolve these issues. I hope this helps you find the help you need. See you later. Hey there. I hope you're excited to learn about cloud computing on AWS. I'm excited to get started too, so let's hop in. To kick things off, we are going to cover some of the foundational concepts you'll need to know about when working with AWS. Working with AWS is part theory, part technical knowledge, part vocabulary, and lots of practice and experimentation. These first few lessons are going to help you establish a little bit from each of those categories. You will learn the theory behind cloud computing and the benefits of the cloud. This will help you make informed decisions about the cloud from a high level and give you some of the reasoning around why and when to use the cloud. Then we will dive into the AWS global infrastructure, covering regions and availability zones, followed by lessons on how to interact with AWS services. This lesson is going to give you the technical knowledge and vocabulary you need to create and discuss AWS architectures and properly understand AWS documentation and examples. A lot of what AWS offers can relate back to concepts used in traditional on-premises computing, and getting started with AWS means comparing these concepts to AWS concepts. After that, we will begin to discuss security and identity and access management. This is important to understand when you're getting started because as soon as you create an AWS account, you'll have some actionable knowledge on how to secure that account right from the start. Starting off secure is a good place to be. Throughout all the topics in these next few sections and over the duration of the entire course, we'll be using a sample employee directory web application to demonstrate how AWS services are used. Let's go ahead and take a look at the employee directory app. You can see I'm in the browser, and I want to show you the functionality. This is a basic CRUD app, or Create, Read, Update, Delete. This app keeps track of employees within a company, so the first thing I'm going to do is create a new employee. To create an employee, we'll give the employee a name, and I'm going to add myself, so I'll add my name, my location is USA, and then my job title, I'll enter in Cloud Technologist. And then we can add some badges for each employee. This is like an employee's flair. So I'm going to select Mac user for myself and photographer, and then I will click Save. Now I'm back on the homepage, and I actually forgot to add a photo for this employee. So let's go ahead and edit it and add the employee photo. You can also see this app gives me the ability to delete employees from the directory. So those are the features of the app from a user's perspective. Time to review how we will build this app using AWS services. This application will be built in a private network using Amazon Virtual Private Cloud, or VPC. We will host the application's backend code on Amazon Elastic Compute Cloud, or EC2, which is a service that essentially offers virtual machines on AWS. So let's go ahead and add those servers to our diagram. The employee data will be stored in a database, which will also live inside this network, and will be hosted using a service called Amazon Relational Database Service, or RDS. So I'll go ahead and add that to the diagram as well. The images for the employees will be stored using the Object Storage Service Amazon Simple Storage Service, or S3, which allows the unlimited storage of any type of file like images in our example. These are the basic building blocks of our application. We will use Amazon CloudWatch for monitoring the solution, and we will also want to ensure that our application is scalable and fault tolerant. So I'm going to go ahead and add Amazon Elastic Load Balancing and Amazon EC2 Auto Scaling to this diagram. For security and identity, we will be using Amazon Identity and Access Management, or IAM, so let's add that. There's a lot of pieces on this diagram, but don't worry, we will build this app step by step using the AWS Management Console. We will add to this diagram, reference it, and change it throughout the course to meet our needs and let it evolve as new ideas and techniques enter our world. One more thing to note about this course before I let you go. If you hear this noise, it means that you are going to be seeing one of our informational pop-ups on the screen, which convey extra information like word definitions, AWS best practices, tips, tricks, or general commentary written for you by our lively furry sidekicks, Meowsy and Fluffy. They know all the tips and are very helpful little friends to have around during this course. That's it for now. See you soon.
For our employee directory application, we'll be using photos of each of our employees. If we have only one copy of those photos and don't want to lose them, we have to store them somewhere safe. Currently, the only copy of these photos are saved on my laptop, but if my laptop breaks, what happens? No more photos. I want to make sure this doesn't happen, so I'm going to upload the photos to AWS to ensure that the copies exist even if my laptop is destroyed. This also allows me to access my photos from anywhere: my home, my phone, a plane, on a train, everywhere. When I store these photos in an AWS service, I'm storing it in a data center somewhere, on servers inside that data center. But if a natural disaster happens, such as an alien coming down from space and destroying a data center, then what do we do? Luckily, AWS has planned for this event, and many others, including natural disasters and other unavoidable alien accidents. The way they plan for it is through redundancy. AWS has clusters of data centers around the world. So here, AWS would have a second data center connected to the first through redundant high-speed and low-latency links. That way, if the first data center goes down, the second data center is still up and running. This cluster of data centers is called an availability zone, or AZ. An AZ consists of one or more data centers with redundant power, networking, and connectivity. Unfortunately, sometimes natural disasters like hurricanes or other disasters might also extend to impacting an entire AZ, but AWS has planned for that too, again using redundancy. Like data centers, AWS also clusters AZs together and also connects them with redundant high-speed and low-latency links. A cluster of AZs is simply called a region. In AWS, you get to choose the location of your resources by not only picking an AZ, but also choosing a region. Regions are generally named by location, so you can easily tell where they are. For example, I could put our employee photos in a region in Northern Virginia called the Northern Virginia region. So knowing there are many AWS regions around the world, how do you choose an AWS region? As a basic rule, there are 4 aspects you need to consider when deciding which AWS region to use: compliance, latency, price, and service availability. Let's start with compliance. Before any other factors, you must first look at your compliance requirements. You might find that your application, company, or country that you live in requires you to handle your data and IT resources in a certain way. Do you have a requirement that your data must live in the UK boundaries? Then you should choose the London region, full stop. None of the rest of the factors matter. Or if you operate in Canada, then you may be required to run inside the Canada Central region. But if you don't have a compliance or regulatory control dictating your region, then you can look at other factors. For example, our employee photos are not restricted by regulations, so I can continue looking at the next factor, which is latency. Latency is all about how close your IT resources are to your user base. If I want every employee around the world to be able to view the employee photos quickly, then I should place the infrastructure that hosts those photos close to my employees. We are all bound by the speed of light. Applied to your business, that means that if your users live in Oregon, then it makes sense to run your application in the Oregon region. You could run it in the Brazil region, but the latency from Oregon to Brazil might impact your users and create a slower load time. But maybe I really want to run my application or store my employee photos in Brazil. One problem I might run into is the pricing, which is the next factor we'll talk about. The pricing can vary from region to region, so it may be that some regions, like the Sao Paulo region, are more expensive than others due to different tax structures. So even if I wanted to store my employee photos in Brazil, it might not make sense from the latency perspective or the pricing perspective. And then finally, the fourth factor you'll want to consider is the services you want to use. Often, when we create new services or features in AWS, we don't roll those services to every region we have right away. Meaning, if you want to begin using a new service on day one after it launches, then you'll want to make sure it operates in the region that you're looking at running your infrastructure in. To recap, regions, availability zones, and data centers exist in a redundant, nested sort of way. There are data centers inside of availability zones and availability zones inside of regions. And how do you choose a region? By looking at compliance, latency, pricing, and service availability. Those are the basics, but it isn't the end of the story when it comes to AWS Global Infrastructure. We also have the Global Edge Network, which consists of edge locations and regional edge caches. Edge locations and regional edge caches are used to cache content closer to end users, thus reducing latency. Consider this scenario. You are a company hosting a website to your users all over the world. Even though your website is being downloaded from all over, it's hosted out of an AWS region in North America, say Ohio. Without caching, every user would need to send a request to the Ohio region where the data is downloaded, and then the data would be returned to the user and rendered in their browser. If the user is located in the USA or a nearby country, there may not be much latency in this process. However, if a user is coming from a place that is located far from the Ohio region, then latency will be greater. Latency is a big hurdle for many use cases, including web applications. So, to reduce this latency, you could use the edge locations to cache frequently accessed content. When you cache content at an edge location, a copy is hosted across the edge locations around the world. That way, when a user goes to retrieve that information, it will come from the closest edge location, which will greatly reduce the latency for that user. You can use services like Amazon CloudFront to cache content using the edge locations. When you own the infrastructure, it's easy to understand how you interact with it, because you can see it, touch it, and work with it on every level. If I have a server that I've stood up in my closet, interacting with that server is easy because it's mine. I can touch it. When I remove the ability for me to touch and see something, like when the infrastructure becomes virtual, the way that I work with that infrastructure has to change a bit. Instead of physically managing my infrastructure, now I logically manage it through the AWS Application Program Interface, or API. So now, when I create, delete, or change any AWS resource, whether it's a virtual server or a storage system for employee photos, I use API calls to AWS to do that. You can make these API calls in several ways, but the three main ways we're going to talk about in AWS are the AWS Management Console, the AWS Command Line Interface, and the AWS Software Development Kits, or SDKs. When people are first getting started with AWS, they typically use the AWS Management Console. This is a web-based method that you log into from your browser. The great thing about the console is that you can point and click. By simply clicking and following prompts, you can get started with some of these services without any previous knowledge of the service. With the console, there's no need to worry about scripting or finding the proper syntax. When you log into the console, the landing page will show you services you've recently worked with, But you can also choose to view all of the possible services organized into relevant categories such as compute, database, storage, and more. If I change the region to Paris, you're making requests to eus3.console.aws.amazon.com, or the Paris region's web console. After you work with the console for a while, you may want to move away from the manual creation of resources. For example, in the console, you have to go through multiple screens to set configurations to create a virtual machine. And if I wanted to create a second virtual machine, I would need to go through that process all over again. While this is helpful, it also leaves room for human error. I could easily miss a checkbox or misspell something, or even skip important settings by accident. So, when you get more familiar with AWS, or if you're working in a production environment that requires a degree of risk management, you should move to a tool that enables you to script or program these API calls. One of these tools is called the AWS Command Line Interface, or CLI. You can use this tool in a couple of ways. One is to download the tool and then use the terminal on your machine to create and configure AWS services. Another is to access the CLI through the use of AWS Cloud Shell, which can be done through the console. With both of these options, instead of having a GUI like the console to interact with, you run create commands using a defined AWS syntax. For example, if I wanted to launch a virtual machine with the CLI through Cloud Shell, I first use this quick shortcut to open a session. Once my session is started, I type in AWS, which is how we know we interact with the API. Then type in the service. In this case, it's EC2, the service that allows us to create and manage virtual machines, which we'll learn about later. And then the command that we want to perform in that service, and any other configurations we want to set. One command versus multiple screens you have to click through in the console can help reduce accidental human errors. But that also means you have to work with defined syntax and get that syntax correct in order for your command to run successfully. So there is some upfront cost in just understanding how to form commands, but after a while you can begin to script these commands out, making them repeatable, which can greatly improve efficiency in the long run. The other tool that allows you to interact with the AWS API programmatically is the AWS Software Development Kits, or SDKs. SDKs are created and maintained by AWS for the most popular programming languages such as Python, Java, Node.js, .NET, Ruby, and more. This comes in handy when you want to integrate your application source code with AWS services. For example, our employee directory application runs using Python and Flask. If I wanted to store all of the employee photos, including pictures of employees, in an AWS storage service, I could use the Python SDK to write code to interact with that AWS storage service. The ability of managing AWS services from a place where you can run source code with conditions, loops, arrays, lists, and other programming elements provides a lot of power and creativity. All right, that wraps this video up. To recap, you have three main options to connect with AWS: the console, the CLI, and the SDKs. In this course, we'll mainly be using the console to interact with the services, but feel free to challenge yourself by using the CLI if you're a bit more advanced.
It's time for your first hands-on exercise with AWS. Before you can begin building on AWS, you'll have to have an AWS account. For your first exercise, we ask that you create an account with AWS, verify that account, and then you'll set up some billing alerts. When you create an AWS account, you can then begin using the services, and a lot of different services offer a free tier. The free tier varies from service to service. All of the services we chose for this course do have a free tier where you can use resources for free for a limited amount of time. If you have an existing account that you are trying to use, there's a chance you won't qualify for the free tier and would incur costs for the exercises you complete in this course. So, for this first exercise, it's pretty straightforward and we are building up to the more complex tasks involved with hosting our employee directory application. You'll create and confirm your new AWS account, log into that account, and then you'll explore how to do basic management tasks like where to find your account information and how to change regions using the AWS Management Console. You also will set up a billing alert. Just in case you create a resource and forget to turn it off or delete it, you'll be notified that you have hit a certain threshold in the account for cost. That's it for now. In order to begin using AWS effectively, it's important to understand how security works in the cloud. You already know that by using AWS, you won't be managing every single aspect of hosting your solutions. You'll rely on AWS to manage portions of your workloads for you, taking care of that undifferentiated heavy lifting, like running the day-to-day operations of the data centers, and managing the various virtualization techniques employed to keep your AWS account isolated from, say, my AWS account. So the question is, who is ultimately responsible for security in AWS? Is it A, you, the customer, or B, AWS? The answer? Well, the correct answer is yes. Both you and AWS are responsible for securing your AWS environment. Let's explore this concept. AWS follows something called the shared responsibility model. We don't view solutions built on AWS as one singular thing to be secured. We see it as a collection of parts that build on each other. AWS is responsible for the security of some aspects. The others, you are responsible for their security. Together with both you and AWS following best practices, you have an environment that you can trust. Let's take a look at the shared responsibility model diagram. You can see we have the responsibility of security broken into two groupings, you and AWS each being responsible for different components. We describe AWS as being responsible for security of the cloud. For example, one piece of the puzzle for AWS is the AWS global infrastructure. And when I say global infrastructure, I mean the physical infrastructure that the cloud is running on. This is iron and concrete, buildings with fences protected by security guards and various other security measures. It also includes the AWS global backbone, or the private fiber cables that connect each AWS region to each other. Managing the security of these pieces is all on AWS. You don't need to worry about that as far as security goes. Then there is the infrastructure and various software components that run AWS services. This includes compute, databases, storage, and networking. AWS is responsible for securing these services from the host operating system up through the virtualization layer. For example, let's say you want to host some virtual machines or VMs on the cloud. We primarily use the service Amazon EC2 for this use case. When you create a VM using EC2, AWS manages the physical host the VM is placed on, as well as everything through the hypervisor level. If the host operating system or the hypervisor needs to be patched or updated, that is the responsibility of AWS. This is good news for you as the customer, as it greatly reduces the operational overhead in running a scalable and elastic solution leveraging virtualization. We will talk more about EC2 and elastic solutions in upcoming lessons. For now, let's get back to the security aspect. So, if AWS manages the underlying hardware up through the virtualization layer, then what are you responsible for? Well, you are responsible for security in the cloud. Similar to how a construction company builds a building, and it's on them to make sure that the building itself is stable and secure. Then you can rent out an apartment in that building. It's up to you to lock the door to your apartment. Security of the building and security in the building are two different elements. For security in the cloud, the base layer is secured by AWS. It's up to you to lock the door. So, for our EC2 example, you are responsible for tasks like patching the operating systems of your VMs, encrypting data in transit and at rest, configuring firewalls, and controlling who has access to these resources and how much access they have. The main thing to understand is that you own your data in AWS. You are ultimately responsible for ensuring that your data is encrypted, secure, and has proper access controls in place. In many cases, AWS services offer native features you can enable to achieve a secure solution. It's up to you to actually use them. In other cases, you may devise your own solutions to meet compliance and security standards for your specific industry or use case. So that's the shared responsibility model at a high level. I do want you to keep something in mind though. There is some amount of nuance you should understand as we move through the course regarding the shared responsibility model. Each AWS service is different and serves a different purpose and a different use case. Therefore, the shared responsibility model can vary from service to service as well. This is a good thing, as you get to decide how to build your solutions on AWS. When you create an AWS account, you sign up with an email address and you create a password. The email address you sign up with becomes the root user of the AWS account. This root user has unrestricted access to everything in your account in most cases. We will discuss in a later lesson what types of users can be restricted and how to do that, but for now, I want you to understand that when you log into your AWS account using an email address and password, it means you are logging in as the root user. This root user can do whatever they want in the account. It has all of the powers that can be had. And with great power comes great responsibility, or something like that. So, knowing that the root user is all-powerful, you should do everything you can do to make sure that no one can gain access to this root user. Let's say there's a nefarious actor of sorts, and they have an evil plan to log into your AWS account with your root user, gaining access to all of the powers and permissions, and they go and delete all of your valuable data and AWS resources, and in their place, they spin up a lovely and expensive cryptocurrency mining operation, leaving you with the bill and none of your data as they walk away with a full crypto wallet. Sounds less than ideal. Well, how can you prevent that from happening? You could, of course, create a hard-to-crack password, and that will give you some level of security. This, however, is an example of single-factor authentication, where all someone needs to do is match the password with the email address, and boom, they're in. We recommend as a best practice that right after you create your AWS account, you enable multi-factor authentication, or MFA, on the root user. MFA introduces an additional unique piece of information that you need to enter to gain access to the account. There are a variety of devices, virtual or physical, that generate one-time passwords that can be integrated with your AWS account for MFA. For example, I personally use a virtual MFA device that is an app on my phone. This app produces a string of numbers for one-time use that I type into the console after I log in using my email address and password. Even if someone guessed the password, they cannot gain access to the account without the numbers generated by the virtual MFA device. No matter what type of MFA device that you choose to use, and I will include a link to the supported devices in the readings for you to look into, the most important thing is that you are using MFA on the root user. That way, even if someone, the nefarious actor, cracks your password, they still cannot gain access to your account, all thanks to MFA. On top of enabling MFA for the root user, we strongly recommend that you do not use the root user for your everyday tasks, even the administrative ones. There are really only a few actions that require root user access. Coming up, you'll learn how to create an IAM user and use that to log into your AWS account instead of using the root user. Let's take a look at the application we are going to be building out throughout the course. We've already gone over the design of this application, and what I want to focus on now is access control. There are multiple places on this diagram where we can identify the need for access control and credential management. The first being that we need to manage how users log in and use the employee directory application. We could require that people have a valid credential, like a username and password, to log into the app. That is access management on the application level. Then there is the fact that we know the code running the employee directory application on a virtual machine being hosted by the service Amazon EC2, and that code will need to make API calls to the object storage service Amazon S3 in order to read and write data like images for the employees. Well, here's the thing. Just because both Amazon EC2 and Amazon S3 have existing resources in this account, it doesn't mean that the API calls made from the code running on the EC2 instance to S3 are automatically allowed to be made. In fact, all API calls in AWS must be both signed and authenticated in order to be allowed, no matter if the resources live in the same account or not. The application code running on the Amazon EC2 instance needs access to credentials to make the signed API call to Amazon S3. So that's another place with the need for a credential and access management. Now let's take this a step further. How are you going to build out this architecture? Well, you'll need access to an AWS account through the use of a login. Your identity within this AWS account will need permissions to be able to do things like create this network, launch the EC2 instances, and create the resources that will host and run the solution in AWS. Yet another place you need credentials. The root user, which you have already learned about in a previous lesson, has these permissions, but you don't want to be using the root user to administer your AWS resources. And let's assume you won't be the only one working on or building out this application. It's more likely that within one AWS account, there would be many people who need access to build and support your solutions. You'll have different groups of people responsible for different parts of the architecture. The people who would write and deploy the code might be software developers, whereas the people who would be responsible for making changes to, say, the network would be a different group of people. You wouldn't and shouldn't give everyone who needs access to the AWS account the root user credentials to log in. You instead would have unique credentials for each person logging in. This is where the service AWS Identity and Access Management comes in. We identified 3 places where we will need access and credential management. AWS Identity and Access Management, or IAM, can help take care of these 2 spots on the diagram. AWS IAM manages the login credentials and permissions to the AWS account, and it also can manage the credentials used to sign API calls made to AWS services. IAM would not, however, be responsible for application-level access management. The code running on this instance would use separate appropriate mechanisms for authenticating users into the application itself, not IAM. All right, so let's start with the AWS account level. IAM allows you to create users, and each individual person who needs access to your AWS account would have their own unique IAM user. Creating users for everyone who needs access to the account takes care of authentication. Authentication being verifying if someone is who they say they are because they had the proper credentials to log in. Now it's time to introduce authorization. Authorization is this. Let's say you've logged in and you are who you say you are. You've been authenticated. Now you want to create resources and manage AWS resources, like create an Amazon EC2 instance, for example. Sure, you've logged in, but do you have the correct permissions to be able to complete that action? The idea that your permissions control what you can or cannot do is authorization. Are you authorized to launch an EC2 instance? IAM users take care of authentication, and you can take care of authorization by attaching IAM policies to users in order to grant or deny permission to specific actions within an AWS account. Keep in mind, when I say action here, I'm referring to an AWS API call. Everything in AWS is an API call. IAM policies are JSON-based documents. Let's take a look at an example. This IAM policy document contains permissions that allow the identity to which it's attached to perform any EC2-related action. The structure of an IAM policy has an effect, which is either allow or deny. An action, which is the AWS API call. In this case, we have EC2:*, which includes all EC2-related actions. You can restrict this to be specific API calls. For example, I can restrict this action to be just run instances, and then any user with this policy attached would only be allowed to run EC2 instances, but perform no other EC2-related tasks. IAM lets you get very granular with your permissions in that way. Continuing with this example, we see the resource, which allows you to restrict which AWS resources the actions are allowed to be performed against. You can also include conditions in your policies that can further restrict actions. IAM policies can also be attached to groups. IAM groups are very simply just groupings of IAM users. You can attach a policy to a specific user or a group. When you attach a policy to a group, any users that are a part of that group would inherit the permissions. We recommend that as a best practice, you organize users into groups and assign permissions to groups instead of individual users where possible. This makes it easier to manage when people change job roles or multiple users need permissions applied or revoked. Another best practice to follow is that we recommend when you create your AWS account, you set up MFA for the root user, then create an IAM user with admin permissions. Log out of the root user, and then log in with the IAM user that you just created. From there, you can use this user to create the rest of the IAM groups, users, and policies. The reason we suggest you do this is because you cannot apply a policy to the root user, but you can to an IAM user. Now that I've told you about IAM users, groups, and policies, we've addressed this part of access management that we needed for our application. But what about this part? The EC2 instance needs credentials to be able to make the signed API call to S3 for reading and writing employee images. Am I suggesting that you make an IAM user with a username and password for the application running on EC2 to use? No, I am not. This is where role-based access comes into the picture. Coming up, we will learn about the temporary access that IAM roles provide and how it can apply to this use case here. All right, so you've learned about IAM users, groups, and policies. Policies can be applied to AWS identities like users and groups to assign permissions. They also, however, can be applied to another AWS identity, IAM roles. An IAM role is an identity that can be assumed by someone or something who needs temporary access to AWS credentials. Let's dive into what I mean when I say AWS credentials. Most AWS API calls that are made must be signed and authenticated, but how does that process work? When you send HTTP requests to AWS, you must sign the request. This signing process happens programmatically and allows AWS to verify your identity when a request is made and run through various security processes to ensure a request is legit. IAM users have associated credentials like an access key ID and secret access key that are used to sign requests. However, with regards to our architecture, the code running on the EC2 instance needs to sign the request sent to S3. I already told you that I don't intend for you to create an IAM user with credentials to be used by this app. So how will the application gain access to the needed AWS access key ID and AWS secret access key to sign the API call? The answer is IAM roles. IAM roles are identities in AWS that, like an IAM user, also have associated AWS credentials used to sign requests. However, IAM users have usernames and passwords as well as static credentials, whereas IAM roles do not have any login credentials like a username and password, and the credentials used to sign requests are programmatically acquired, temporary in nature, and automatically rotated. In our example, the EC2 instance will be assigned an IAM role. This role can then be assumed by the application running on the virtual machine to gain access to its temporary credentials to sign the AWS API calls being made. A role can be assumed by many different identities, and they have many use cases. The important thing to know about roles is that the credentials they provide expire, and roles are assumed programmatically. To get an idea of this, let's create a role using the AWS console. I'm already logged in and will navigate to the IAM service. Now I want to create the role the EC2 instance is going to use for the employee directory application. Now we will click Roles in the left-hand side and select Create Role. We will then select the trusted entity this role is intended to be used for, and in our case, this will be EC2. Then we will click Next. Now we get to select the permissions assigned to this role. Again, permissions being what actions does this identity have the authority to take. We want this identity to be able to read and write to Amazon S3, so I will search for S3, and you can see there are multiple options here for pre-written policies that I can choose from. I also can write my own custom policy, which would also show up here if I created it ahead of time. I'm going to select S3 full access for the policy. In the real world, you would choose a more restrictive IAM policy for this, but for a proof of concept like this course is intended to provide, we will leave the permissions a bit looser for now. You would come back and change the permissions attached to this role to be more granular if this were ever to make it to a production type environment. Now we also need to add another permission here, and that's for DynamoDB. So I will exit out of the S3 filter and then type in DynamoDB and hit enter. And then we will select the Amazon DynamoDB full access permission. Then we will click Next. Then we can give this role a name, which is Employee Web App Role. Then we can scroll down and we can click Create Role. We can see that this role has now been created successfully. And if we click on the role and scroll down, we can then see that this role has 2 permissions attached. It's very common for roles to be used for access between AWS services. Just because two resources exist in the same AWS account, it doesn't mean that they can send any API calls to each other. If one AWS service needs to send an API call to another AWS service, it would most likely use role-based access, where the AWS service assumes a role, gains access to temporary credentials, and then sends the API call to the other AWS services who then verifies the request. Another identity that can assume an IAM role to gain access to AWS is external identity providers. For example, let's say you have a business that employs 5,000 technical employees that all need access to AWS accounts. You already have an identity provider system in place that allows these employees to log into their laptops and gain access to various corporate resources. Should you also now go create 5,000 IAM users for these employees to access AWS? Well, that doesn't sound very efficient. You instead can leverage IAM roles to grant access to existing identities from your enterprise user directory. These are known as federated users. AWS assigns a role to a federated user when access is requested through an identity provider. We also have AWS services that can make this process easier, such as AWS IAM Identity Center. These are a couple of examples of role-based access in AWS, and this is just the introduction. Check out the class readings for more information, and don't worry if you don't quite grasp this concept yet, as we will continue using roles in our demos and examples throughout this course. Let's keep the momentum going, shall we? Time for another hands-on exercise. This time, since you already have your AWS account and you've learned about some of the best practices for securing AWS accounts, let's put those best practices into practice. You'll log into your AWS account with the root user and you'll enable multi-factor authentication. Next, you'll find the root access keys, which provide unlimited access to your AWS resources. As stated in a previous lesson, it's not recommended to use these unrestricted keys in normal situations, so you'll go ahead and delete yours from the account. Then, once that's taken care of, you'll create an IAM user with administrative privileges. Then you'll log out of the root user and log in with the new IAM user. This user will be used to manage your AWS account from this point forward unless the root user is specifically needed. The first task you'll complete with this new IAM user is you'll create an IAM role with more limited privileges that will come in handy in future exercises. Have fun. Hello everyone. In this video, we are going to create the IAM role for our employee directory application, and we will also look at how to create users and look at the different AWS access keys, which are used for programmatic access to AWS APIs. So to start off, let's create the role for our application by selecting Roles in the left-hand navigation of the IAM dashboard, and then we will click Create Role. On this page, we need to select what the trusted entity type is to assume this role. We know that roles allow you to get access to temporary credentials that are used to make calls to AWS API calls. You want to make sure that you're restricting who can assume this role. Not anyone can assume this role, right? So under the trusted entity type, we have the AWS service. An AWS service, that would be something like an EC2 instance, a Lambda function, other services that are assuming a role to make AWS API calls. You could have an AWS account. This would allow you to allow cross-account access to permissions for resources in your account. You also could select a web identity, which would allow for federated users to assume a role. You have a SAML 2.0 federation. So if you have a corporate directory that is on premises that would be using SAML, you could use this as your trusted entity type, or you could create a custom trust policy. We're going to select AWS service for this, and then we're going to select EC2 since our employee directory application will be running on EC2. Next, we can select the next button, and then we're brought to the page to add permissions. This lists out the different permissions policies that are in IAM, and right now it's pulling back the AWS managed policies that exist in this account by default. And what a managed policy is it is a policy that is created and managed by AWS. And so what I mean by that is let's go ahead and look at a policy for S3. So if I type in S3 in the search bar and then hit enter, I'm going to expand this Amazon S3 full access policy. And we can see the JSON, which is the permissions for this policy. We can see we have the effect is allow. That's either going to be allow or deny. There's no other option besides allow or deny. And then there's the action, which is going to define what AWS API calls are allowed to be made. So we can see that we have S3 : and S3 object lambda : That's a wildcard to determine all API calls are allowed against this service. And then we also have the resource here, which is also set to star. So this would be all S3 resources. This is a very permissive policy. In the real world, you would likely want to change this to allow just the API calls that your application needs, nothing more, and just the resources that you intend to have this policy be related to. So to do that, you would have to create a custom policy. So if I scroll up, you could click on this custom policy button, which would take you to a new page where you could then create your custom policy. For now, we're going to use the AWS managed policies, and I'm going to select the checkbox for Amazon S3 full access. And then I'm also going to type in DynamoDB and exit out of the S3 filter, and then select the Amazon DynamoDB full access policy here as well, because later in the course, we are going to be using DynamoDB as the database for this application. So to prepare the role, I've selected both the S3 full access and DynamoDB full access. Now we'll click next. Then we can give this a name. I'm going to name this employee web app. And then I'm going to scroll down. We can view the trusted entities here. So this is our trust policy. We're allowing the API call STS assume role. And who's allowed to assume this role? ec2.amazonaws.com. So an EC2 instance is going to be allowed to assume this role only. All right, so now I can scroll down and then click create role. Once your role is created, you can then click on the role, which will bring you to the page where you can see the information about this role, such as the ARN, the Amazon resource name, and you can also scroll down. You can view the permissions attached. You could add new permissions if you want to. You can simulate the permissions. You can view the trust relationships. You can also view any tags associated with this, which are key value pairs. So this is where you can get all of the information about your role and where you can manage your role. So next, what I want to do is create a user. So I'm going to click on users in the left-hand navigation. Then I'm going to click add users, and let's give this user a name. Let's say it's EC2 admin. And then I want to click the checkbox for enabling console access. So what that means is I want to allow this user to be able to sign in to the AWS Management Console. So note, by default, this was unchecked, meaning that just because you create a user doesn't mean they have access to the console. I'm going to go ahead and check this. And then I'm going to allow an auto-generated password to be created. And then I want to leave the checkbox checked for users to create a password at the next sign-in. So this will allow them to change their password once they log in for the first time. Now we'll click next. And next, what I want to do is I'm going to add the users to a group. We currently don't have any groups, so I'm going to go ahead and click create group. And then what I want to do is add a group name. Let's say this is EC2 admins. And then I want to attach a policy to this group because we know that it's a best practice to attach policies to groups, not to users directly. So I'm going to select the Amazon EC2 full access policy, and then I'm going to scroll down and click create user group. And now I can select this user group to add this user into, and then I can click next. And then we can scroll down. We can see the permissions that this one user currently has. It will be inheriting the permissions from the EC2 admins group. And then it also has directly attached to it the IAM user change password permission, which will allow this user to change their password. So now we can click create user. And now we can go ahead and click return to users list. We didn't download the password for this. That's fine. I don't intend to actually use this user. It's just for demonstration purposes. So we'll click continue. And now if I click on this user, what I want to do next is click on the security credentials tab. And if we scroll down, you can see that we have this panel here called access keys. Access keys are going to allow your users to make programmatic calls to AWS using things like the AWS command line, the AWS software development kits, where maybe they're developing locally on their laptop and they need their code to be able to reach out to AWS. So I'm going to go ahead and create an access key here. And then I want to use this for the command line. And then I'm going to go ahead and click the checkbox for I understand the above recommendation. What this is saying is it's saying, hey, there's another service in the browser that you could use to use the AWS CLI called AWS Cloud Shell. We're going to go ahead and create the access keys anyways. I'm going to select this checkbox and then click next. And then I'm going to click next again and click the create access key. All right, so here you can see we have our access key here, and then we have our secret access key, which is not being shown currently on this page, but you could click show and then copy it, and you would use this access key and secret access key to be able to configure your command line locally. Now I'll click done and then click continue. So now for a little bit of cleanup, I'm going to select actions, and then I'm going to click deactivate and then deactivate, and then I will click actions and then delete. And then we can copy and paste the access key ID here and then click delete. All right, that's it for this video. Hopefully you know a little bit more about roles and users. All right, you've learned some AWS vocabulary, some of the concepts behind cloud computing, as well as some of the specifics around cloud identity and access management. As a refresher, let's take a look at the architecture diagram we'll be building out. You'll remember that it's fairly complicated at a glance. There are many different services working together to host this solution, and to get this entire thing built out this way will take some time and understanding. You'll get the opportunity to see how each piece is built throughout the upcoming lessons. What I want to do now is show you how we are going to host our employee directory application using a service called Amazon EC2, which has been mentioned in previous videos. I find that the best way for me to explain to you how these services work is to show you how they work. So what we are going to do is we are going to call Ceph in here to launch an Amazon EC2 instance and host the employee directory application using the defaults provided by AWS. AWS provides you with something called a default VPC, which is a private network for your AWS resources. Every EC2 instance you launch using AWS must live inside of a network. So in order to complete this demo with the limited amount of information that we have shown you about AWS services, we will be using the default network provided by AWS, and we will accept most of the default values for launching an EC2 instance. Let's bring Ceph in for some help with this one. Hey, Ceph.
Hey, Morgan. Is it time to launch our first EC2 instance?
It is. We'll be using the default VPC to launch this first instance, and we will configure the bare minimum to get our application up and running. Sound good?
Yep, I got it. Let's get started. I'm already in the EC2 management console, and I will navigate to the service Amazon EC2. As Morgan already mentioned, Amazon EC2 is a compute service that allows you to host virtual machines. You'll learn a lot about this topic coming up soon, but for now, we are going to simply create an EC2 instance to try and help you wrap your mind around using AWS services on demand. From here, we'll launch a new EC2 instance. An instance is just what we call one single virtual machine. Now we have to select the configurations for this EC2 instance. You will go over these configurations in detail later. We can give this instance a name. I'll call it Employee Web App, and then we will select the free tier eligible options using a Linux AMI or Amazon machine image. And then scrolling down to the next section, we will select the free tier eligible T2 Micro for the instance type. Next, we normally need to select a key pair. This would be used to SSH into the instance. But we won't need to do this, so I'm going to select Proceed without a key pair and continue scrolling to the network settings. Here, we will select the network, so looking at network settings, we will click Edit. Then we can select the VPC and subnet for this instance, and as we discussed earlier, we will use the default VPC and leave the subnet at No Preference. The default VPC has configurations in place that make this experimentation process a lot easier when you're first getting started with AWS. Again, we will define all of these things later. Continuing on with network settings, we will create a new security group, which is an instance-level firewall that will allow HTTP and HTTPS traffic in to reach the instance. So we will add inbound rules for both of those. Now we will scroll down and expand advanced details. We will accept most of the defaults here except the IAM instance profile and user data, which we will provide a value for. For the IAM instance profile, we will use the IAM role that will be used by the application, though this won't come into play until later when we have our S3 bucket created. But for now, let's click the dropdown and select that IAM role. Now, scrolling down to the user data, this is a script that is going to run when the instance boots up. Let's go ahead and paste in our user data script. This script will download the source code for the app, start the web server, and kick off the application code so it's ready to start handling requests. While you could have launched the instance, then connected to it via SSH, configured and started your application manually, we have decided to use a script to automate this process on launch. All right, now we can click Launch Instance. It can take a few minutes for the instance to boot up, so let's wait for that. And now it's up and running. To access the instance, copy the IP address from the details listed below. Paste it into a new browser tab, and there you go. It's up and ready to go. Morgan, what do you think?
That looked great. It's exactly what I would expect at this point because there is no data being served from a database. So I expect to see just a home page with no info. So that's great. Thank you, Seth, for walking us through that. In upcoming lessons, we will discuss the specifics of not only EC2, but also networking on AWS, and you'll understand how everything we just kind of glossed over actually works. So stay tuned. Hey everyone, and welcome back. So far, you've been learning all about some higher level concepts regarding AWS, making sure you understand AWS in general, the global infrastructure, as well as setting up an account and providing yourself the right level of permissions. But you may also remember that we ended the last lesson by launching an EC2 instance to host our application. An EC2 instance is simply just a form of compute, meaning it gives our application power in the form of CPU, memory, and networking capacity so that we can process our users' requests. This concept of compute leads us into the next lesson, where we discuss your compute options on AWS. Of course, you've already seen one of these options, EC2, but we'll also discuss other common solutions such as container services like Amazon Elastic Container Service, or ECS, and Amazon Elastic Kubernetes Service, or EKS, as well as serverless options like AWS Lambda. After the upcoming lessons, you'll not only understand each of these compute services, but you'll also be able to compare them to one another. That way, you'll know how and when to apply each service to different use cases. You'll get an opportunity to see more demos with Amazon EC2, and we will go further into the details throughout this week. But as you imagine, we can't just launch this EC2 instance into space, right? We have to put it somewhere. And where do we put it? Well, we put it in a network that we'll need to customize for our application. Every EC2 instance needs to exist inside of a network, and on AWS, those networks are called VPCs. We'll learn all about networking on AWS using VPCs, but rest assured, this won't be too hard. We'll give you all the information you need to launch an EC2 instance into a VPC. All right, so that's what is on deck. Also, make sure you are checking out the readings that follow the videos. There's additional information in those readings that you won't see in the videos, like use cases, features we didn't have time to cover, and more. All right, I think that it's time for us to get started. Enjoy the lessons, and I will see you soon. Let's talk about compute. Every business needs raw compute capacity to run applications. These applications could be web servers, batch jobs, databases, HR software, machine learning, or just about whatever you can think of. The time, money, and effort it takes to get up and running with on-premises computing resources are fairly high. When you own your own fleet of physical servers, you first have to do a bunch of research to see what type of servers you want to buy and how many you need to buy. Then you need to purchase that hardware up front. You'll wait multiple weeks or months for servers to be delivered. You then take them to a data center space that you own or rent to install them, rack and stack them, and wire them all up. Then you make sure the servers are secured, powered up, and ready to be used. Only then can you begin to host your applications on top of these servers. The worst part is, once you buy these servers, you are stuck with them, whether you use them or not. It's not easy to just suddenly provision more physical compute capacity when you need it, and it's even harder to get your money back on servers you no longer need. It's impossible to get the time back. Following a compute as a service model is much easier to get started and support operations over time. AWS took care of the hard part for you already as far as getting started goes. AWS already built and secured the data centers. AWS has already bought the servers, racked them and stacked them, and they are already online, ready to be used. In a previous lesson, we showed you how to launch the employee directory application with Amazon EC2. We didn't really talk about the details, how EC2 works, what configurations exist for it, and we definitely didn't discuss any other compute options that exist on AWS. AWS has different services for different use cases, and Amazon EC2 is one of the basic AWS services that are important to understand. We'll be spending most of our time in these upcoming lessons exploring EC2. That being said, though virtual machines like EC2 are great, there are other compute services out there too, like container services and serverless compute. You'll learn about these other compute options and their use cases. Don't always assume that VMs are the default answer. Sometimes it makes sense to architect applications for serverless compute or containers from the start, depending on what you are building and what you are optimizing for. EC2 instances give you a lot of flexibility and control in the cloud, and you configure them to meet your needs. You can provision one or many instances easily, and at the end of the billing cycle, you only pay for what you use, either per second or per hour, depending on the type of the instance. When you no longer need an instance, you can terminate or stop the instance, and you will stop incurring charges. Not all servers are the same, and you are probably looking to run a specific type of operating system on your EC2 instance. AWS supports a range of operating systems, including Linux, macOS, Ubuntu, Windows, and more. To select the operating system for your server, you must choose an Amazon Machine Image or an AMI. The AMI contains information about how you want your instance to be configured, including the operating system, possible applications to be pre-installed on that instance upon launch, and other configurations. You can launch one or many instances from a single AMI, which would create multiple instances that all have the same configurations. Some AMIs are provided by AWS, whereas others are provided by the community and can be found using the AWS Marketplace, or you can build your own custom AMIs as needed. For example, Amazon Linux 2 is the AMI we selected when we launched our employee directory application. This AMI is provided by AWS, and it's essentially a pre-built EC2 optimized Linux image that has long-term support provided by AWS. Beyond the properties determined by the AMI, you can also configure the instance type and size, which correspond to the amount of compute, memory, and network capabilities available per instance. Different applications have different hardware requirements, and choosing the instance type for your application gives you the ability to pick the hardware that it runs on. It's also really nice that you have a wide variety of choices, as it's hard to achieve that same level of variety with on-premises resources. The instance types you can choose from are grouped for use cases like compute optimized, memory optimized, storage optimized instances, and more. There is a list of instance types you can find in the AWS documentation, and you can expect this page to be updated regularly as new instance types are released. For example, the G instance family are optimized for graphics-intensive applications, which would work best for use cases such as 3D visualizations or video encoding, whereas the M5 general-purpose EC2 instance family provides a balance of resources and are great for applications that use these resources in equal proportions, like web servers, our employee directory application example, or code repositories. When you are launching an EC2 instance, you will see something like this when selecting an instance type and size. The T3 or A1 is the instance type that determines the blend of hardware capabilities, then the dot, then the size, like small, medium, large. It goes down to nano and up to many, many extra large sizes. The great thing about this type of selection existing right at your fingertips is that you are no longer locked into hardware decisions up front. You can choose an initial EC2 instance type, evaluate its performance for your specific use case, and then later change it to a different type that is better suited for the application. EC2 is also resizable with a few clicks in the console, or can be done programmatically through an API call. All of these configurations being available to you via API enables you to embrace change over time easily as your workloads mature and change. So, okay, virtual machines are cool and totally not new, so how exactly does this impact your business? Well, the important thing is this. The flexible and low-cost nature of EC2 instances, as well as the ease of provisioning servers, allows for programmers and businesses to innovate more quickly by spinning up servers for a short amount of time to run experiments and find optimal configurations for your applications. EC2 offers a wide variety of hardware options to choose from, so you can optimize your solutions by selecting the right EC2 instance type for your application. And then you can optimize even further by right-sizing the resource, or selecting an instance size that is appropriate for your application and not over-provisioning like is often done on premises. This type of optimization is hard to achieve on your own because with traditional on-premises deployments, you are working with hardware constraints that simply don't exist in the same way with the cloud. The ability to adapt to changes and choose really specific configurations for your virtual machines all through a couple of API calls is very powerful. And EC2 is really just the beginning of the story. One of the main reasons why EC2 provides so much value is the fact that you can provision new EC2 instances on demand, and just as easily you can get rid of instances that you no longer need. In most cases, you only get charged for instances that are currently running. EC2 allows you to stop and start instances at will, which enables you to treat your fleet of EC2 instances as elastic, scaling them in or out. Then at the end of the billing cycle, you only pay for what you use. We are building up to the idea of scaling your fleet of EC2 instances in and out to serve demand. But before we get there, it's important to understand some of the more basic things about EC2. Let's talk about the EC2 instance lifecycle. An Amazon EC2 instance transitions through different states from the moment you launch it through to its termination. You launch an EC2 instance from an AMI. And as you learned in a previous lesson, once the EC2 instance is launched, it enters a pending state. This state is essentially your VM booting up. Once the instance is ready for use, it enters the running state. In the running state, you will be charged for the EC2 instance. From running, you have a couple of different options. You can reboot the instance, which is similar to rebooting, say, your laptop. It turns off, then it turns back on again. Pretty straightforward. You can also choose to stop your instance. It will enter a stopping phase, then enter the stopped phase. Stopping an instance is like powering down your laptop. You can always turn it back on, and it will go through its usual boot sequence, moving through the pending state and back to the running state. The other option, which is similar to stop, is to stop hibernate your instance. This also enters the stopping phase and then the stopped phase. You can compare this to how you lock your laptop and shut the lid, but when you open it back up, everything is still in place where you left it. No boot sequence required. You are back up and running after a couple of seconds of the computer waking up. Since the state of the machine was written to memory when you stopped it, the state of the machine can be drawn from memory and put back into place. Then you're back up and running. Now, the last option depicted here is the terminate option. When you terminate an instance, it enters the shutting down phase, then the terminated phase. Terminating an EC2 instance is like taking your laptop out for a long boat ride off the coast and throwing it into the ocean, getting rid of it forever. It's now lost in the great blue sea. There is no hope of finding your laptop on an island shipwrecked one day, having been saved after spelling SOS in the sand. Anyways, I hope you had any data or state stored on that instance backed up, because once you terminate an instance, it's gone. That being said, there is a feature called termination protection that you can enable if you're worried about instances being terminated accidentally. You also will learn about persistent storage and EC2 in future lessons, so don't fret. We will show you ways you can make sure your data sticks around, even if the EC2 instance doesn't. So that is the EC2 instance lifecycle. It's definitely a good idea to remember how all of this works if you plan on using EC2 to host your applications. And don't think of terminating instances as a bad thing. If your EC2 instance is having technical trouble for one reason or another, maybe it needs an update or a patch, instead of logging into the instance to fix it or install software, you can launch a new one with the new changes in its place, and then you could terminate the old instance, having the new instance take that place. You, of course, can do in-place updates as well, but just know that you have the option to decide how to handle these sorts of tasks. You can launch or terminate EC2 instances to meet demand. So as demand for your application increases, you can launch more instances, and as it decreases, you can terminate instances. This keeps your EC2 instance fleet in line with demand. So again, terminating an instance isn't a bad thing and shouldn't be feared. Now, let's discuss the cost aspect of this. You only get charged for an EC2 instance if you're in the running state, or if you are in the stopping state when preparing to hibernate. This means that you can stop instances when they aren't in use. Say if you have applications that are only used during the work week. Run them when your employees are clocked in, and then stop them when they aren't. Remember, you can always start from a stop state, allowing them to resume working when necessary.
In this next exercise, you're going to put all this new EC2 knowledge to good use. You're going to launch a new Amazon EC2 instance into your default VPC, just as we did for our demo in a previous lesson. You'll select an AMI, an instance type and size, configure the instance, and launch it. Part of the configuration will be to paste a user data script into the advanced configurations. This user data script is a script that runs when an EC2 instance is booted up for the first time. This is most commonly used to download and configure any software packages or dependencies that are needed for the application running on the instance. It's good for you to pay close attention to these sorts of details as you move through the exercise, especially if you plan on using EC2 outside of a classroom environment. Once your EC2 instance is booted up, you'll be able to send a request to the employee directory application and view its response in the browser. This EC2 instance will not yet be connected to any backend database to store employee information, so the expected result is simply the home page loading with no data displayed. If you are having trouble, try going back a few steps and making sure you have followed all of the directions carefully. Also, please note that it can take a few minutes for the employee directory application to be available after launch, so give it ample time to boot up. Once you are done verifying your EC2 instance is up and running and configured correctly, you will then stop the instance to view the state change. Then finally, you'll terminate the instance as some cleanup. In a future exercise, you will relaunch the application but using your own VPC. The default network settings we are using for this lab are not secure, and I do not recommend you continue to use these settings throughout the course. This is simply a proof of concept, so you can have experience going into the next lesson, making it easier to wrap your mind around.
Hello everyone. In this video, we are going to launch the employee directory application on an Amazon EC2 instance using the default VPC. So you can see I'm already in the AWS console, and I'm going to navigate to the EC2 dashboard. From here, I want to launch a new instance. So I'm going to select Launch Instance and then select Launch Instance again. And now this brings us to a page where we can provide the configurations for our EC2 instance. I'm going to give this a name, Employee Directory App, and then we can scroll down and we can view what AMI we want to choose. The AMI is the Amazon Machine Image, and this is a template that contains the software configuration for your instance on boot, like the operating system, any sort of application server, or any applications that you want to have pre-installed when you launch your instance. We're going to be using the Amazon Linux 2023 AMI for this, though you could browse the AWS Marketplace to get access to the different types of AMIs that vendors offer. So if you're using some sort of third-party software that you want to launch on an EC2 instance, they might have an AMI out there that you could use to make your life a little bit simpler. You also can create and manage your own AMIs and share them internally within your organization to say you can only launch an EC2 instance using one of our approved AMIs that might have some specific security or compliance sort of packages pre-installed. That's another option. So leaving the Amazon Linux 2023 AMI selected, I'm going to scroll down, and then we can select our instance type. The instance type will determine how much CPU, how much memory, what types of hardware is available to you on this instance. Some instances come with a GPU, for example. In this case, we're going to use the free tier eligible EC2 instance type, T2 Micro, which is the default that's selected. So we'll leave that the way it is. Then we can scroll down and select whether we want to use a key pair. The key pair is going to allow you to have access to this instance doing something like SSH. I'm going to select proceed without a key pair because if I need to connect to this instance, I'm going to use the connect button in the AWS console where I don't need to have a key pair to connect to this instance to view things like logs. Then scrolling down some more, we then can configure our network settings. This is using a default VPC and a default subnet. This default VPC is going to have subnets that have internet access, so meaning that there is an internet gateway attached to this VPC that allows internet traffic to flow into this default VPC. You'll learn more about VPCs coming up, but just understand that this default VPC does allow public internet access, which is good for our use case, but might not be great for other use cases where you would more than likely put your instance behind something like a load balancer, and then you would use private subnets. But we want to be able to access this instance directly. So with that in mind, we're going to use the default VPC, and we're also going to leave this auto-assign public IP to enable. And this will allow our EC2 instance to have a publicly reachable IP address once it's been launched. Then scrolling down a little bit more, we have to configure our firewall. This is going to be our security group. Security groups are instance level firewalls. We want to disable traffic from SSH because we're not going to need that. Then we're going to allow HTTPS and allow HTTP. In our application, we're going to be using HTTP directly. Then scrolling down, we can configure some storage. We're going to leave our root volume here, but we're not going to add any more EBS volumes. Then we can expand the advanced details section, and then we need to select an IAM instance profile. In this case, I'll be selecting the employee web app role, and this role has permissions attached to it to allow whoever's using the role to make calls to S3 or to DynamoDB. We know that our application has some code that's running that's going to be making API calls to S3 and DynamoDB. We need to allow our AWS SDK to actually get access to these credentials. And the way that we do that is through this IAM instance profile. So we're associating this role with this instance profile that will allow our code to get access to these temporary credentials. Then scrolling down some more, we will come to the user data section. And this is where you can provide a bash script that will run on launch. So this script here is what's going to be used to download and install our application. Our application was written in Python using Flask as the web server, and this is going to be for our employee directory application. So on the first line, we are just declaring that this is a bash script. Then we are using wget to download a zip file from S3. So we hosted this zip file in an S3 bucket for this to be downloaded. Then we're unzipping that, and then we're changing directories into that new directory. Then we're using yum to install Python 3 and pip. Then we're using pip to install any dependencies for our Flask application, which will all be listed in a file called requirements.txt, which got downloaded from this zip file. Then we're installing a package called stress. This stress package is going to be used to simulate a CPU spike on this instance, which is going to allow us to simulate auto-scaling whenever we use Amazon EC2 auto-scaling in a future lesson. Then we have 3 different environment variables, one for our photos bucket. We're going to be using S3 to store our photos. We don't have that value yet, so we'll just leave this placeholder there. Then we have the default region. We're operating out of Oregon. And then we have our Dynamo mode on, and this means that we want our application to use DynamoDB. And then we're running this application and hosting it on port 80. Now we can select launch instance, and this will begin to go build out the different things that we need, like our security group. And we can see that our instance has launched. Now, if I select this instance ID, that brings us to a page where we can then select our instance and view some information about it. We can see things like our public IP address, our private IP address, and our public DNS name, but we can't access this directly yet. We can see that our instance state is running, but if I refresh this, you can see that we have some status checks that are still initializing. I want to wait until both of these status checks have passed. So we'll give this a few minutes and then we'll come back once it's ready. Okay, we're back and we can see that our instance state is running and the status checks have passed. Now, if I select this instance again, we can then open up our IP address in a new tab. All right, and we can see that our employee directory application has been opened in a new tab and we have an empty employee directory. This is exactly what we would expect at this point, as we don't have a place to store our photos or the employee information with our S3 bucket or DynamoDB table. We're going to look at how to build out a custom network for this, the S3 bucket, and the DynamoDB table, and make all of this highly available in an upcoming lesson, so stay tuned. EC2 is great for all sorts of different use cases, from running basic web servers to running high-performance computing clusters. That being said, though EC2 is incredibly flexible, reliable, and scalable, depending on your use case, you might be looking at alternatives for your compute capacity. For example, let's say you are looking for a way to run containers at scale on AWS. Containers can provide you with efficiency and portability. In this context, I'm specifically referring to containers like Docker containers or containers that use the containered runtime. If you aren't sure what containers are, please review the readings on containers. Containers are portable because everything an application needs to run, including the application code, dependencies, and configuration, are all packaged up together as one executable, which is the container itself. Since everything is self-contained, it means that you can expect your containers to behave the same way across different environments like development, QA, and production. AWS offers container services like Amazon Elastic Container Service, otherwise known as ECS, or Amazon Elastic Kubernetes Service, otherwise known as EKS. Both of these services are container orchestration tools. When you use containers on AWS, you need processes to start, stop, restart, and monitor containers running across not just one EC2 instance, but a number of them together called a cluster. The process of doing these tasks is called container orchestration, and turns out it's really hard to do on your own. If you have a few containers, it's not so bad, but once you get to hundreds or thousands of containers you are managing, it can be quite complex. Orchestration tools were created to help you run and manage containers. ECS is designed to help you run your containerized applications at scale without the hassle of managing your own container orchestration software. EKS does essentially the same thing but uses different tooling with different features. We aren't going to go too much into this now. However, I did include a link to more learning resources around containerized applications on AWS in the readings following this video. The way you can interact with these container services is you manage the containers running on a cluster through the Orchestration Tools API, and then the orchestration tool carries out the management tasks. You can automate scaling of your cluster hosting your containers, as well as automate scaling of the containers themselves. Containers have a shorter boot up time when compared to virtual machines. So if you need super fast response to increasing demand, then containers might be the service for you. Personally, I think the portability aspect that containers give are my favorite benefit of containerized applications. So you can choose to host containers on top of a cluster of EC2 instances as your hosting options, either for ECS or EKS. However, what if you were looking for an alternative to hosting your containers? Because you either don't need access to the underlying OS or you don't want to manage those EC2 instances. Well, you can use a compute platform called AWS Fargate, which handles most of the underlying details for you. Fargate is a serverless compute platform for ECS and EKS, and we'll talk more about what serverless is coming up next. When using Amazon EC2 or container services running on top of EC2 as a compute platform, you are required to set up and manage your fleet of instances. This means that you are responsible for patching your instances when new software packages or security updates come out, setting up the scaling of those instances, as well as ensuring that you've architected your solutions to be hosted in a highly available manner, which means deploying instances across 2 AZs at a minimum, as we discussed earlier. This is less management and operational overhead than you would have if you hosted the same solutions on premises, but management processes will still need to be in place, and it's your responsibility to create those processes to fit your use case. This is actually really great, and in many use cases is exactly what you want because it gives you a great deal of control over your solutions. Whatever happens on your instances and with your instances is in your hands. You can create simple or complicated setups that run and scale on AWS exactly to your specification. That being said, not every single solution requires this level of control over the underlying environment. Oftentimes, you might be looking to focus on your own business solutions and let someone else take care of the undifferentiated heavy lifting for you. Or perhaps you just simply don't want to fiddle around with scaling controls and fault-tolerant designs, but you still want all of the benefits of doing so. This is where the term serverless comes in. A lot of AWS services are serverless in nature. Serverless means that you cannot see or access the underlying infrastructure or instances that are hosting your solution. Instead, all of the management of the underlying environment from a provisioning, scaling, fault tolerance, and maintenance perspective are taken care of for you. All you need to do is focus on your application. The rest is taken care of, or more accurately, the rest is abstracted from you. This means that serverless offerings are very convenient to use. You get to focus on the value that the service delivers and not the underlying implementation details, thus reducing the number of operational support processes that you need to have in place. Remember the shared responsibility model that we covered in a previous lesson? This idea of serverless impacts that as well. For example, with Amazon EC2 instances, you are required to patch the OS when new security updates are released. With serverless offerings, the line between what you are responsible for versus what AWS is responsible for moves up. You do not have access to the underlying operating system that is running the service. Therefore, you cannot be responsible for carrying out tasks like patching. You are, however, still responsible for things like data encryption and access management. Let's wrap this up. I like to think of AWS services as existing on a spectrum. On one side of the spectrum, you have convenience, and on the other side, you have control. Many services exist to give you control, like Amazon EC2, whereas other services exist to give you convenience, like the serverless compute AWS Lambda. We'll dive deeper into some of these serverless compute technologies coming up. Now that you have learned about what container services AWS offers and what serverless means, let's continue our conversation about containers. To recap, ECS or EKS is the container orchestrator. This is the tool that is managing the container's lifecycle. Then you need the compute platform. This is where the containers actually run. Previously, you learned that ECS and EKS run containers on clusters of EC2 instances. And in that case, you are using EC2 as the compute platform for your containers. And you also have tight control over those instances. Now, EC2 is certainly not serverless, so thinking about serverless compute for containers, I want to introduce to you a service named AWS Fargate. AWS Fargate is a serverless compute platform for containers that you can use with either ECS or EKS. With AWS Fargate as the compute platform, you run your containers on a managed serverless platform. The scaling and fault tolerance is built in, and you don't need to worry about the underlying operating system or environment. Instead, you define your application content, networking, storage, and scaling requirements. There is no provisioning, patching, cluster capacity management, or infrastructure management required. To break that down a bit, the way you work with Fargate is you first build your container images and push them into a repository, like Amazon Elastic Container Registry, for example, which is a place where you can store container images for them to be pulled and deployed from. So you have your container images in your repo, and then you define memory and compute resources for your task if you're using ECS, or your pod if you're using EKS. Then you run your containers, and at the end, you only pay for the amount of vCPU, memory, and storage resources consumed by your containerized applications. Fargate does support spot and compute savings plan pricing options, just like with Amazon EC2 instances. So there is some flexibility on how you plan to run containers on Fargate. So you can still get a good amount of control for your containers deployment, but without needing to worry about the provisioning, patching, and managing the underlying operating systems or instances, and no need to scale the infrastructure in and out to meet demand like you do with EC2. As far as use cases go, AWS Fargate can be used for all of the common container use cases, including microservice architecture applications, batch processing, machine learning applications, and migrating on-premises applications to the cloud. All right, hopefully you now have a 10,000-foot view of AWS Fargate. You can see how Fargate is an example of how serverless simplifies your operations and management for running scaled container solutions. AWS Lambda is one of the serverless compute options you have available to you on AWS. Lambda allows you to package and upload your code to the Lambda service, creating what is called a Lambda function. Once you create a Lambda function, it isn't always running all of the time. Instead, Lambda functions run in response to triggers. You can configure a trigger for when you want your function to run, and from there, the Lambda service waits for the trigger or polls for an event to trigger the function, depending on what the trigger is that you choose. There's a long list of available triggers for AWS Lambda, and new ones are being supported all of the time, so I won't run through them all now. However, a couple of common examples of triggers for Lambda functions are an HTTP request, an upload of a file to the storage service Amazon S3, events originating from other AWS services, or even in-app activity from mobile devices. When the trigger is detected, the code is automatically run in a managed environment, an environment that you do not need to worry too much about because it is automatically scalable, highly available, and all of the maintenance of the environment itself is done by AWS. You do, however, get to choose the language your Lambda function is coded in, the amount of memory and CPU your function is allocated in the environment, permissions, dependencies, and many other aspects of how the function runs. If you have 1 or 1,000 incoming triggers, AWS Lambda will scale your function to meet demand, each in its own isolated environment. Lambda is currently designed to run code that has a runtime of under 15 minutes. So this isn't for long-running processes like deep learning or batch jobs. You wouldn't host something like a WordPress site on AWS Lambda. It's more suited for quick processing like a web backend handling requests or a backend report processing service or microservice hosting. One of the best things about Lambda is that you aren't billed for code that isn't running. You only get billed for the resources that you use, rounded up to the nearest 1 millisecond interval. To understand Lambda more thoroughly, let's run through a quick demo. In this demo, I will create a Lambda function that resizes images uploaded into the employee directory to be uniform thumbnail size. It makes sense to create this sort of logic with the Lambda function. You don't need an application to be running 24/7 on EC2 to resize photos uploaded to the application. You really only need to run the resize logic when a new photo is uploaded. So here's our diagram for the app. What I want to do here is when a new photo is uploaded to S3, it triggers a Lambda function that then resizes the image and uploads it into that same S3 bucket, but to a different location than where the original image is stored. All right, let's go ahead and build this out. You can see that I'm already in the AWS Lambda console, and I'm going to first click Create Function. Next, we get to select what type of function we want to build. Do we want to author a function from scratch? Do we want to use a blueprint, which will give you some sample code and configuration presets? Or you can use a container image with AWS Lambda, as Lambda does support running containers. We're going to author a function from scratch. For the function name, we will call this resize image, and then we get to select the runtime. The runtime is the language that your Lambda function is written in. Because with Lambda, it runs in the Lambda environment, but it's still your code. So I'm going to go ahead and select Python 3.9 for this, as we wrote this function in Python. And then we have to select the permissions. And the permissions are going to be delegated to the function through IAM roles. So I'm going to click Use an existing role. And then if I expand this dropdown, we can select Lambda S3 Full Access, which is an IAM role that I've already created in this account that will give this function permissions to read and write from S3. Now we can scroll down and select Create Function. Now we can add a trigger for this Lambda function, and I'll select Add Trigger. And here we get to configure the trigger source. And if we expand this dropdown, you can see a list of AWS services that can act as triggers, like API Gateway, an application load balancer, DynamoDB. We're going to scroll down and select S3 for our trigger. And then we need to select which S3 bucket will be the event source. I already have an S3 bucket created in this account called Photo Upload Bucket MW. We'll select that one. And then if we scroll down, I'm going to select the event type. I want to select only a put, so I want put operations to trigger this AWS Lambda function. Then we can provide a prefix. With this prefix, what we're essentially doing is we're going to say, I only want to trigger this Lambda function if a put occurs in a specific location inside of this bucket. We're going to upload photos to an input prefix, and that will then trigger the Lambda function. We then need to acknowledge that if we're using the same S3 bucket for both input and output, that it could cause recursive invocations. So the way that we're getting around that is by supplying this input prefix. The event will be triggered when an image is uploaded to this prefix, but then the output will actually be uploaded to a different location. We'll have an output prefix where the image will be uploaded to. So we're going to go ahead and acknowledge by checking this checkbox and then click Add. Now back on our function overview page, what we need to do next is actually upload the code for this. So if we scroll down, we can select the Code tab. And then you can see that there's a stubbed out Lambda function here that essentially just says, hello world, hello from Lambda. And what we need to do is upload our code. So I'm going to click Upload From, and then select Zip File. Click Upload, and then I will select this resize image.zip. Click Open, and then click Save. All right, our function has been successfully created. We have our trigger defined and we have our code uploaded. What I want to do now is test this out by actually uploading an image to S3 and then viewing the output. So in the search bar, I'll type in S3 and then select S3. Then from here, we'll select the bucket, and then we'll go into the input folder and then select Upload. Click Add Files, and then I'll upload Ceph's image and select Open, and then Upload. We can see that that upload was successful. So now if we go check, we should see the output with the thumbnail version of that image. So now going back into our bucket, if we go up one level, we can now see that the output prefix has been created, so I'll select that. And we can see that the thumbnail image was created. And that's it. That's how you create an AWS Lambda function. You could host the entire employee directory application's backend on Lambda with some refactoring, but I'm going to go ahead and save that for a later conversation. At this point, you've covered a few different AWS compute services. The services covered so far can handle a wide variety of use cases. So how do you know when to use each one? To figure that out, I think it's time to play a game. Welcome to the Which AWS Compute Service Should I Choose for My Use Case game show. We're your hosts, and you're the contestant.
We will present 3 different use cases that require compute on AWS, and it's up to you to choose the right service for the use case. You'll have 5 seconds to answer each question. Ready?
I'm ready, and I hope you are too. Let's do it. First question is up. Consider a scenario where you are a developer who is tasked with creating a new feature for a web application being hosted on EC2. The web application is an online store, and right now all the items being sold in the store are loaded into a database manually behind the scenes. By manually, I mean there is a person who adds a new row to a database for each new item to be sold in the store. This process takes a long time, isn't very scalable, and is prone to error. You are tasked with automating the process of getting the new item information loaded into the inventory database. The goal is to have a person upload an inventory spreadsheet into Amazon S3, the object storage service, then have a process automatically load the data into the inventory database. What compute would you use to host the processing logic to load the items from the file into the database? 5 seconds on the clock.
All right, let's discuss how you could have answered this question. You could have decided to use Amazon EC2 here. You could spin up a new instance specifically for this process and write some code that pulls the location of the spreadsheet for a new upload every so often, updating the database when it finds a new file. That would work, but before I make my final answer here, I have a question. How often does new inventory get added to the database?
New inventory gets updated once a quarter.
Good to know. So it's not very often, which means this process would only run once a quarter, and that does change my answer. Here's why. Amazon EC2 charges per second or per hour, so if I have an instance running all the time to serve requests that happens once per quarter, that seems like a lost opportunity to optimize for cost. I would be spending money on a resource I rarely use. It certainly would work, but it may not be the best fit for this use case. I could automate the process of starting and stopping the instance when needed, but instead, what about using AWS Lambda?
Bingo! AWS Lambda is the correct answer for this one. There are a few reasons. First of all, to address your concern on cost, AWS Lambda only charges you for the compute you consume when the code is actually running, and code is only run in response to triggers or a direct invocation. So here's my suggestion. You know that the goal is to have someone upload an inventory document to S3, which should kick off the process of updating the database. You also learned that AWS Lambda has triggers that run your Lambda functions code. AWS Lambda integrates with many AWS services to act as triggers, and Amazon S3 is one of them. So, my suggestion would be to create an AWS Lambda function, configure a put event as the trigger from Amazon S3, then when the inventory is uploaded, Amazon S3 will trigger the Lambda function to run, and the code in the function will parse the inventory document and add each item to the database.
Okay, great. Time for the next question. Let's say you have an application currently hosted in your on-premises data center, which needs to be migrated to AWS. It's currently running on Linux servers in the data center, and you want to minimize the amount of refactoring needed to migrate to AWS. It's important that this workload is elastic and can support varying demand. What compute option would you choose? 5 seconds on the clock.
Time's up. Now I'll go over the answer. Considering the fact that minimizing refactoring is an important aspect of this workload, I would architect a solution using Amazon EC2 as the compute service. EC2 instances can be launched from Linux-based AMIs, and the application could be hosted on the EC2 instance the same way it would be hosted on a Linux server on premises. Amazon EC2 also has the ability to scale in or out based on demand, so I think EC2 is the best service for this one.
That's correct. So if you answered EC2 at home, good work. Before we move on to the final question, let's dive into this answer a little more. Morgan, can you explain the thought process behind eliminating the other compute services we covered in the answers to this question?
Sure thing. So, AWS Lambda could work, but you can't just upload the same code you would run on Amazon EC2 into a Lambda function. There would have to be a decent amount of refactoring in order to take advantage of that service. Same idea with any of the AWS container services like ECS or EKS. Again, you'd have some amount of rework required to migrate to containers. Therefore, Amazon EC2 is the best option for this migration. Now, time for one final use case, and this one is for all the marbles. Imagine a scenario where you are planning to write a brand new application using a microservices or service-oriented design, and you want to architect the application where it can scale up or down quickly, and you want to lower the risk of deploying new changes to production. Which AWS compute service would you use? 5 seconds.
Okay, time's up. The answer for this use case is one of the AWS container services like Amazon ECS or Amazon EKS.
Correct. The answer is either ECS or EKS for this one, because using containers makes it easier to support microservice or service-oriented designs. Containers boot up quickly, so scaling is quicker than EC2 instances, and the use of containers helps with code portability. Meaning, if I write the code on my laptop and run it in a container, test it in QA in a container, I can then expect the same container to behave the same way once deployed to production, thus reducing the risk of deployments causing errors because of environmental issues.
All right, there you have it. Different use cases for a few of the AWS compute services. Make sure you read up on AWS's other compute offerings and make informed decisions when architecting your solutions. You'll find there are a lot of options.
Remembering that these services exist to best suit different use cases helps. Don't try to use the same compute service for all of your use cases. Instead, pick the right one for the job and consider re-evaluating choices for existing workloads as AWS continues to release and improve offerings.
Looking back at the architecture diagram for our application, the part we want to focus on for this section of the course is this part, the network, or VPC, and its many components. But before we dive into networking on AWS, let's first put this into context. In a lesson you saw earlier, we launched an instance and connected to that instance over the internet. But to launch this instance, we needed to select a network. How you configure this network, or VPC, is actually what helps enable internet traffic to flow into your application. You might be asking, Seth, how did we select a VPC when we haven't even built a VPC yet? You're right, we haven't built a VPC. But fortunately, AWS creates VPCs for us in every region by default. When we launched our EC2 instances earlier in the course, we simply chose the default VPC. These default VPCs are meant to provide an easy way for you to get started with EC2 instances quickly and view your applications over the internet. However, you have to be careful with what you put inside of these default VPCs, as those resources will be subject to, well, the internet. And with internet access comes potential dangers. If we didn't select this default VPC, we would have needed to select a VPC that we custom built. In this section of the course, we'll focus on doing just that, building a custom VPC for our application that is more secure and provides more granular access to the internet than the default option we originally chose. While viewing this section, keep in mind that this information is geared towards EC2 related services. If you are using a different kind of compute, such as a Lambda function, you might not need a network at all. However, that doesn't mean this isn't important. Networking on AWS is the basis of most architectures, so consider this information highly valuable. Coming up, we'll dive into some key VPC concepts. But for now, take some time to review the upcoming notes, which will cover some important networking basics that you should know before jumping into networking on AWS. In this video, you'll be learning how to create a VPC with Morgan's help. We'll both be conceptualizing and building a VPC throughout the next few videos. The idea of a VPC is similar to how you think of walls around a data center. In a data center, walls act as a boundary between the outside world and all of your infrastructure. A VPC in AWS acts the same way. It creates a boundary where your applications and resources are isolated from any outside movement. So nothing comes into the VPC and nothing comes out of the VPC without your explicit permission. When you create a VPC, you have to declare two specific settings: the region you're selecting and the IP range for the VPC in the form of CIDR notation. For our VPC, we'll be locating it in the region where the rest of our infrastructure will be, the Oregon region, and our IP range we'll say is 10.1.0.0/16. All right, so currently our VPC looks just like a box. Time to build the VPC. Okay, Morgan, let's build out a VPC for the employee directory app. I was hoping you could build us a VPC that matches this diagram.
Sure, let's do it. If you're looking at the console, you'll first check to make sure that you're in the correct region by clicking on the upper right-hand corner. Seth mentioned we're going to run out of the Oregon region, so we'll go ahead and make sure that this says Oregon. Once we choose the right region, we can now build our network. You'll type in VPC in the service search bar, and that'll bring up your VPC dashboard for this region. From there, you'll click your VPCs and then create VPC. Now we'll have a few settings to configure. We'll put in the CIDR block, which is 10.1.0.0/16, and the VPC name, which we'll say is app VPC. We'll leave the rest as default, and then we'll click Create VPC. Easy as that. Okay, Seth, what's next?
Nice, that was fast. After you create your VPC, you then divide the space inside the VPC into smaller segments called subnets. You put your resources, such as your EC2 instances, inside of these subnets. The goal of these subnets is to provide more granular control over access to your resources. So if I have public resources, like our employee directory app, that we want to be accessed over the internet, I could put these resources inside a subnet with internet connectivity. If I have more private resources, like a database, I could create another subnet and have different controls to keep those resources private. To create a subnet, you need three main things: the VPC you want your subnet to live in, which is this one, the AZ you want your subnet to live in this case, we'll choose AZA, or in other words, US West 2A, and then the CIDR range for your subnet, which must be a subset of the VPC CIDR range. For this, we'll choose the CIDR range 10.1.1.0/24. We'll call this our public subnet for public-facing resources. Then we'll create another subnet for our private resources. We'll place it in the same AZ, specify a different non-overlapping CIDR range, say 10.1.3.0/24, and then name it our private subnet. All right, now that we've got two subnets added to our VPC, it's time to put Morgan to the test again and have her build these out. And this time, I'm timing her.
All right, we're on a time limit here, so let's create these subnets. Let's go ahead and start creating the public subnet. Back in the console, we'll click on Subnets in the side panel and then select Create Subnet. Then we'll select the VPC we're working with. In this case is App VPC. Once you do that, you'll be prompted to provide a name. We'll say this one is Public Subnet 1. Then we'll choose the AZ, which Seth mentioned was US West 2A, and then the CIDR range will be 10.1.1.0/24. We'll leave the rest as defaults, scroll down to the bottom, and click Add New Subnet. We'll now repeat the same steps for our private subnet. Give it a name, such as Private Subnet 1, put it in the same availability zone, US West 2A, and then type in the CIDR range, which is 10.1.3.0/24. Now we can click Create Subnet, and both subnets will be created. All right, Seth, what was my time?
That was so fast that my watch didn't even register it. Okay, moving on. As we mentioned earlier, when you create a new VPC, all the resources you put in it are isolated and only have access to other resources in that VPC by default. For websites like our corporate directory application, we want users to access our site over the internet. To enable internet connectivity, we need a component called an internet gateway. Think of this gateway as similar to a modem. Just as a modem connects your computer to the internet gateway connects your VPC to the internet. When you create an internet gateway, you then need to attach it to your VPC. If you create an internet gateway and don't attach it, it won't do anything except sit there. Okay, Morgan, show us how it's done. Create an internet gateway and attach it to our VPC.
Okay. Back in the VPC dashboard, you'll click on Internet Gateways on the side panel, then Create Internet Gateway. You'll give the Internet Gateway a name, and then click Create. On the Details page, you'll then select the Actions drop-down box and select Attach to VPC. Choose the App VPC we've been working with, and then click Attach. Okay, Seth, what's next?
Sorry. I thought I'd have more time to drink my tea. So we have an internet gateway that we can use to allow access from the internet. But what if we had a VPC with all internal private resources that we want to reach only from our on-premises data center? If we only want traffic to flow between AWS and our data center, and we don't want to allow direct access from the internet, what do we do? Luckily, there's another gateway designed for this very purpose, called a Virtual Private Gateway, or VGW. It allows you to create a VPN connection between a private network, like an on-premises data center or internal corporate network, to your VPC. With the help of a VGW, you can establish an encrypted VPN connection to your private internal AWS resources. We won't be using a VGW for our application, but it's good to know. We'll talk more about that in an upcoming lesson. All right, so we have one VPC, two subnets, and an internet gateway. Now, every time you look at an architecture, you should begin to think, how do I make this better? You're not going to have all of the answers right away, but I do want you to take 10 seconds and think about some solutions. Okay, well, one option to make this better is the idea of having high availability. What that means is if this AZ goes down for whatever reason, what happens to our resources in that AZ? They go down too. So ideally, we would have resources in another AZ to take on the traffic coming to our application. To do this, we'd need to duplicate the resources in the first AZ to the second AZ. So that means we'd need to create 2 additional subnets, each within another AZ, say AZB. As a best practice, you should always be using at least 2 AZs and hosting your resources redundantly. Morgan is going to build out some subnets in another AZ in the background for the rest of our demos. She's also going to launch an EC2 instance hosting our application in one of the public subnets. Sound good, Morgan?
Sounds good. Okay, we'll see you in an upcoming video, this time with 1 VPC, 4 subnets across 2 AZs, and 1 running EC2 instance.
Let's take a look at our current VPC state. In the last video, we left off with a VPC with an internet gateway attached to it, and 2 subnets, 1 public, 1 private, and 1 availability zone. However, Morgan was kind enough to build additional resources in the background to make sure our application was highly available. So now we have 2 additional subnets, 1 public, 1 private, in a different AZ for a total of 4 subnets. She also created an EC2 instance hosting our employee directory inside of the public subnet in AZ-A. But we're missing one large component here. Say we have a user and that user wants to access our employee directory. Eventually, that internet traffic would flow through the internet gateway, but then where would it go? Just because the traffic entered through the door of the VPC, it doesn't mean it ever made it to the right room. What we need to do is to provide a path for the internet traffic, not only to enter the door, but also make sure traffic reaches the right room. Or in other words, enter the internet gateway and then find the right subnet. The way we provide that path is through route tables. A route table contains a set of rules called routes that are used to determine where the network traffic is directed. These route tables can be applied at either the subnet level or at the VPC level. When you create a brand new VPC, AWS creates a route table called the main route table and applies it to the entire VPC. AWS assumes that when you create a new VPC with subnets, you want traffic to flow between those subnets. In the last video, when we talked about VPCs being isolated, this is what we meant. The default configuration of the main route table is to allow traffic between all subnets local to the VPC. Let's get a quick look at the main route table of the VPC we just built out in the last video. For that, let's get Morgan out here.
Hey, I understand that you want to take a look at the main route table for the VPC.
That's right. Can you walk us through that?
Yeah, let's go ahead and take a look. In the VPC console, we'll click on Route Tables on the side panel, and it will bring up all of the route tables that exist in this region. If we scroll to the side, we can see the main column and the VPC column. We're going to look for the main route table for the app VPC, which is this one. When we click on it, we can bring up the bottom panel and then click on Routes. Here we can see the local route that has the destination of the VPC IP range. This means that all of the components inside of our VPC can communicate with one another locally by default. This local route will be present in every route table that you create. All right, that's the main route table.
While the main route table controls the routing for your entire VPC, you may want to be more granular about how you route your traffic to specific subnets. Remember when we mentioned that subnets can be used to group your resources together based on whether they are publicly or privately accessible? Well, the subnet itself doesn't provide that access. Whether a subnet has access to the public internet or not depends on its associated route table. If a route from the internet gateway to the subnet exists, it has public access. If the route table doesn't have a route between the subnet and the internet gateway, then it doesn't have public access. So we call subnets public or private, but it's really the route table that provides that access. So for your subnets, you'll create custom route tables. Inside these custom route tables, you'll have that default local route inside of it that allows traffic to flow freely within the VPC, but then you'll need to create additional routes. So the subnet with the internet-facing resource, in this case our EC2 instance with the employee directory website on it, will need a route to the internet gateway. So that means, Morgan, we need your help again. Do you mind creating a custom route table and associating it to our public subnet?
Sure can. Let's get started. Let's create the route table for our public subnet. Back in the VPC console, once again, we'll click on Route Tables on the side panel and then Create Route Table. We'll give it a name, such as app-routetable-public, choose the app-VPC, and then click Create. Our route table has been created, but we're not done yet. We still have to edit the routes to allow traffic to flow from the Internet Gateway. To do this, we'll click on the ID of the route table and then go to the route section in the bottom of the summary table. We'll click Edit Routes, Add Route, put 0.0.0.0/0 for the destination, meaning it can take and deliver traffic from anywhere, and then specify the target as an Internet Gateway. This will bring up available Internet gateways to attach it to, and from here we'll select the App IGW. We're done with the routes, so we'll click Save. But how do you know which subnet this route table applies to? Well, we have to configure that. If we only want this route table to apply to our public subnets, we'll need to associate it with our 2 public subnets only. To do this, we'll click on the Subnet Associations tab, select Edit Subnet Associations, and choose the public subnets we created earlier. Then click Save. All right, we've hooked up our public subnets to a route table that allows internet traffic from the IGW to our employee directory application. If we wanted to create a route table for the private subnets, we would follow the same steps. Create the route table, make sure there's no route to the internet gateway this time, and then associate it to the private subnets. Okay, now we've configured a route to the internet gateway, and we'll configure additional firewall rules later on.
Nice. So this is our final state of the diagram. 1 VPC, 4 subnets, 1 public, 1 private in both availability zones. Our 2 public subnets are associated with a route table that allows traffic from the internet gateway. Our private subnets don't have a route table associated to them yet, so they follow the rules of the main route table, local traffic only. Now we have a complete network that enables internet traffic flow to our public subnet. But how do we know it's secure? Well, at the base level, we know that any new VPC is isolated from internet traffic, so that prevents risk. But when you start allowing internet traffic by opening up routes, you need other options to keep your network secure. In AWS, you have 2 options to secure your VPC resources: network access control lists, often referred to as network ACLs, and security groups. We'll start with network ACLs. You can think of a network ACL as a firewall at the subnet level. With network ACLs, you can control what kind of traffic is allowed to enter and leave your subnet. So, if I were to draw network ACLs in our diagram, they are placed around each of our subnets by default. The default network ACL allows traffic in and out of your subnet. Using this default configuration is a good starting place, but if needed, you can change the configurations of your network ACLs to further lock down your subnets. For example, if I only wanted to allow HTTPS traffic into my subnet, I can do that. I can create a rule in my ACL that allows HTTPS traffic from anywhere on port 443 and denies everything else. However, just because I allow inbound HTTPS traffic does not mean my job is done. If I don't open up the corresponding outbound port used for the protocol, then that means the traffic is allowed in, but the web server's response will never leave the subnet. This is because network ACLs are considered to be stateless. I need to include both the inbound and the outbound ports used for the protocols. What that means for our HTTPS example is that I need to allow outbound HTTPS traffic from the subnet to the internet by creating an outbound rule. The other security feature is security groups. These are firewalls that exist at the EC2 instance level. Security groups are not optional, so anytime you create an EC2 instance, you need to place that EC2 instance inside of a security group that allows the appropriate kinds of traffic to flow to your application. In our diagram, if I were to draw security groups, I would draw them around every EC2 instance in the VPC. In our case, we simply just have one EC2 instance, so we would need a security group around that instance. You know what? I think it's time for a demo. Let's get Morgan back in here.
Hey, Seth, what should I demonstrate next?
Do you have some time to build out a security group for our employee directory application? I think we need an example.
Sure, let's get started. The default configuration of a security group blocks all inbound traffic and allows all outbound traffic. If you want your EC2 instance to accept traffic from the internet, you'll need to open up inbound ports. If you have a web server, you may need to accept HTTP and HTTPS requests to allow that type of traffic through your security group. You can create an inbound rule that will allow port 80, HTTP, and port 443, HTTPS, as shown here. The beauty of security groups is that I don't have to open up an outbound port for traffic to be able to leave the instance. Security groups are considered to be stateful resources. They will remember if a connection is originally initiated by the EC2 instance or from outside and temporarily allow traffic to respond without having to modify the inbound rules. All right, is that everything?
That's it for this one. Thanks. Remember that security groups and network ACLs are powerful tools to filter network-wide traffic for a single instance or subnets traffic. With security groups, everything is blocked by default, so you can only use allow rules, whereas with network ACLs, everything is allowed by default, but you can use both allow and deny rules. These configurations are largely up to you. For example, if you want ultimate convenience, you can leave the network ACLs in the default configuration and use mainly security groups to restrict access. We'll be doing just that with our employee directory application, and it will still be secure. But if you want an added layer of security, you can configure your network ACLs further for more fine-grained control. The solution we are building out with the employee directory application is an all-in cloud, meaning that the components needed to run and operate the application will be in AWS. However, many solutions require a hybrid model to be followed, where some components are in AWS and others are hosted in an on-premises data center. Let's take some time to talk about connectivity to AWS for hybrid deployments. For hosting your resources in AWS, you would use a VPC, which you learned about in the previous lessons. For hosting resources on-premises, you'd have your own solutions in an on-premises data center. So for connectivity to AWS, how will you connect the remote data center to AWS? Let's talk about a few choices you can pick from where you're looking at connectivity between AWS and a remote site like a data center. First, let's talk about AWS Virtual Private Network, or AWS VPN. VPNs are a really common and popular way to securely connect your remote network to AWS. AWS VPN consists of two different services, AWS Site-to-Site VPN and AWS Client VPN. AWS Site-to-Site VPN is used to connect a remote network like a data center to a VPC. This would allow resources living in a customer-managed data center to connect to AWS. Then there is AWS Client VPN, which is more for connecting your administrators to AWS or to your data center. So this is more like when you need to log into a VPN on your laptop to access corporate resources. Using AWS VPN, you can connect to your VPC through the Virtual Private Gateway, which we covered in an earlier video. Just like the Internet Gateway is the doorway to the Internet, the Virtual Private Gateway is the doorway to your private data center through a VPN connection or through another service called AWS Direct Connect. AWS Direct Connect is a service that provides a hosted private connection to AWS through a Direct Connect delivery partner or through AWS. Direct Connect provides a private, dedicated connection. This isn't using the regular open internet to send data between point A and point B. While the data sent over Direct Connect is in transit, the network traffic remains on the AWS global network and never touches the public internet. This reduces the chance of hitting bottlenecks or unexpected increases in latency when compared to a VPN connection. AWS Direct Connect supports a larger and more reliable throughput. If you plan to send a high volume of traffic to AWS and you do need reliability in throughput for this connection, AWS Direct Connect would be a good choice. It really depends on your use case which one you would use. Or in some cases, you may use both where VPN is a failover for Direct Connect. Now, let's get back to building the employee directory application. To round out this week, it's time for an exercise. In this exercise, you'll be building out a custom VPC for your application. You'll then spin up an EC2 instance, place it in the network, and then connect to it to see your app. So, you'll first create the VPC, and then you'll create 4 subnets, 2 public and 2 private. You'll then want to provide internet connectivity to your public subnets. To do this, you'll create an internet gateway and attach it to your VPC. You'll then need to create 2 custom route tables. The first will be a public route table where you will add a route to the internet gateway. You'll then associate it with your 2 public subnets. The second route table will be a private route table, which will only have the local route, and you'll associate it with your 2 private subnets. Next, you'll launch an instance hosting your application. When selecting the network for that instance, you'll choose the VPC you just created and one of the public subnets to place it in. From there, you'll access your application through the browser. Note that because the application isn't hooked up to a database, you won't be able to actually interact with it yet. That's coming soon. All right, have fun, and if you get stuck, a good rule of thumb is to go back 5 steps and make sure you've done the previous steps correctly. See you soon.
Hello everyone, in this video we are going to create a VPC, create 4 subnets, create a route table for the public subnets, and then we will attach an internet gateway to the VPC and then relaunch the employee directory application in the new VPC. So you can first see that I am in the VPC dashboard here, and I'm going to click on Create VPC. Now I want to select, this is a wizard that's going to help you create your VPCs, your subnets, things like that. I'm going to create just the VPC for now. So I'm going to select VPC only, and then I'm going to give this VPC a name. Let's call it App VPC. And then I want to enter in the CIDR range for this VPC. So to do that, I'm going to give the CIDR range to be 10.1.0.0/16. And then I'm going to scroll down and click Create VPC. Now we have our VPC. The next thing that I want to do is to create the subnets. So now I'm going to select the subnets on the left-hand navigation, and then I'm going to click Create Subnet, and then we'll select a VPC for this, and we will select the VPC we just created, App VPC. And now for our first subnet, we'll give this a name, Public Subnet 1, and then we'll select the availability zone, which will be US West 2A. And then we'll give this a CIDR range, which is going to be 10.1.1.0/24. And then we can go ahead and add our next subnet. So we're going to have a public and a private subnet in each availability zone. So we'll create our private one next. So private subnet 1, availability zone, same one, US West 2A. And then providing the CIDR range, we'll say this is 10.1.2.0/24. And now we can add our subnets into the other availability zone. So this one is going to be public subnet 2. And let's say this time we want to put it in US West 2B. And then for the subnet range, we can say 10.1.3.0/24. And then finally, we'll create one more subnet, which will be our private subnet 2, and then selecting the availability zone, we'll say is US West 2B, and we'll give this the CIDR range of 10.1.4.0/24. So you can see that we have, if I scroll back up to the top, you can see we have 4 different subnets being created with non-overlapping CIDR ranges. All of those CIDR ranges being a subset of the CIDR range that we created for our VPC. So we have 10.1.1.0, 10.1.2.0, 10.1.3.0, and 10.1.4.0. All right, now we can go ahead and click Create Subnet, and that will create all 4. All right, so now we have 4 subnets, public subnet 1 and 2 and private subnet 1 and 2. Next, what I want to do is create an internet gateway. So I will select Internet Gateways in the left-hand navigation and then click Create Internet Gateway. We'll give this a name. Let's say it's App IGW, and then click Create Internet Gateway. Then we can go back to the Internet Gateways page where we can view all of our Internet Gateways. We currently have one Internet Gateway attached to our default VPC. What we want to do is select the new Internet Gateway that we just created, and we want to attach this to a VPC, and then we'll select our app VPC, and then click Attach to Internet Gateway. For Internet Gateways, and one Internet Gateway can only ever be attached to one VPC. So it's a one-to-one relationship there. All right, next what we need to do is configure our route tables. So to do that, I'm going to click Route Tables in the left-hand navigation. You can see that we have 2 route tables already. We have the main route tables for both of our VPCs, our default VPC and our app VPC, which we can scroll to the right and expand this and read that VPC there for our app VPC. So now scrolling back over, I'm going to click Create Route Table. And then we'll give this route table a name. We'll say Public Route Table. And then I want to associate this with our app VPC and then click Create Route Table. So now we have a route table that's been created, but we want to now add a route that will allow any subnet that has this route table associated with it. We want to add a route that will allow traffic from the internet 0.0.0.0/0 to where? The internet gateway. And the internet gateway, we want to choose the one that we just created, and then we'll click Save Changes. Now scrolling back down, we are not done yet. Now what we have to do is associate these subnets with this route table. So I'll click Subnet Associations, and then scrolling down, we can see we currently have this associated with no subnets. I'm going to click Edit Subnet Associations, and then I'm going to select our first 2 public subnets only. So there's nothing inherently about a subnet that makes it public or private. The only thing that makes it public or private is whether or not it has a route table association that includes a route from that subnet to the internet gateway. All right, so we'll go ahead and click Save Associations here. And then we can scroll back down, click on the Subnet Associations tab, and we can now see that we have our 2 public subnets associated with this route table. And then again, reviewing the routes, clicking back on the Routes tab, we can see we have our local route and we have our route to the internet through the internet gateway. So now the last step here is let's go ahead and relaunch our employee directory application. So I'm going to navigate over to the EC2 console. And then from here, I'm going to click on the Instances link, which we can see that we have our employee directory application still running. And if I select this, I can scroll down and I can see where this is running, which is our default VPC. So what I'm going to do is I'm going to keep this checked, and then I'm going to select Actions, and then Image and Templates, and then I want to select Launch More Like This. And what this does is it brings you to a page that has a lot of the configurations for that original instance pre-populated over here, so you don't have to go through and reselect all of the configurations. So we can see that we have Employee Directory App pre-populated. I'm just going to go ahead and call this Employee Directory App 2. We can see we have the Linux 2 AMI selected here, and we also have our T2 micro selected. For the key pair, we do have to select that we want to proceed without a key pair again. And then here under network settings, this is where we're going to make most of our changes. We're going to select the new app VPC that we just created, and then we're going to select what public subnet we want to launch into. public subnet 1 or public subnet 2. We're going to go ahead and select public subnet 1. And then we're also ensuring that this auto-assign public IP is set to enable, which it is. Now, scrolling down, you can see that we can select our security group. Currently, we have the security group that was created previously associated with this instance, and it's giving us an error saying that we can't use the security group with this subnet. That's because the security group is tied to the VPC. So we need to create a new security group that will be associated with this new VPC, not the default VPC. So what we want to do here is click Create Security Group, and then we will leave the default for the name, and we'll do the same thing that we did when we created our original security group, which is we want to allow both HTTP traffic on port 80 from the internet, and adding a second rule, we want to allow HTTPS traffic on port 443 from anywhere. Now scrolling down, we can scroll down to the advanced details and expand this here. We can see that the role has been pre-populated, so that's great. And then if we scroll down some more, let's take a look at that user data. We can see that this also is pre-populated. So now we can click Launch Instance. We can click on the instance ID, see that this is in the pending state. And so now we'll wait a few minutes and come back and try to access it through this public IP address. And if we can access it, that means that all of our network configurations were configured correctly. Okay, so now we are back and we can see that the instance is in the running state. If we copy this IP address, and then I'm going to paste it into a new tab off screen, drag this tab over, we can see that we can now access the employee directory application at the IP address of the new instance that was launched into our new app VPC. Hello again. I'm so happy to see that you've made it to this next batch of lessons in our course. So far, you've learned about compute and networking on AWS. Time to move on to two other major categories, storage and databases. The employee directory application we are building out currently has a solid network in place using Amazon VPC and is being hosted on Amazon EC2. The only issue is the app doesn't really work yet because we haven't set up anywhere for it to store the employee information or the employee photos. We are going to go ahead and fix that. We will start off by learning about the different storage offerings AWS has and compare and contrast them. Then we will create an Amazon S3 bucket in our account that the employee directory app will use to store employee images. Then we will explore the different database services AWS has, and there are a lot. Not to worry though, we are focusing on two, Amazon Relational Database Service, or RDS, and Amazon DynamoDB. As always, take the quizzes and please take a good look at the readings that we have placed between the video lessons. There's a lot of extra information there that could be useful to you as you continue your journey with AWS. Great work so far, keep it up, and we'll see you in a bit.
The next thing we need to configure for our employee directory app is the storage. Our application requires several types of storage for its data. For one, we need to store the operating system, software, and system files of our app. We also need to store static assets like photos for the employee headshots, and then we have more structured data such as the name, title, and location of each employee as well. All of that needs a home. The structured data usually requires a database, which we'll talk about later this week. So for now, we'll focus on storing the application files as well as the static content. There are two main types of storage that we can use to store this data, block and object. Here's the difference. Let's say that I have a 1 GB file with text in it. If I'm storing this in block storage, what happens is that this file is split into fixed size chunks of data and then stored. Object storage, on the other hand, treats each file like a single unit of data. This might seem like a small difference, but it can change how you access and work with your data. Let's say I want to change one character out of that 1 GB file. If my file is stored in block storage, changing that one character is simple, mainly because we can change the block, or the piece of the file that the character is in, and leave the rest of the file alone. In object storage, if I want to change that one character, I instead have to update the entire file. Let's take these two types of storage and access patterns and try to apply them to the data we want to store. For example, our static data, like the employee photos, will most likely be accessed often, but modified rarely. Therefore, storing in object storage is fine. For more frequently updated data, or data that has high transaction rates, like our application or system files, block storage will perform better. In this section of the course, we'll discuss both block and object AWS storage services and how they'll interact with our employee directory application. Before we do that, take a look at the notes to get a refresher of the different types of storage. That way you can easily match the storage type to the AWS storage service that we talk about. When you launch an EC2 instance, you're going to need some kind of block storage to go with it. This block storage can be used as a boot volume for your operating system, or a separate data volume. For example, think about your laptop. With a laptop, you store your data in drives, and those drives are either built in internally to your laptop or connected externally. EC2 instances have the same options as far as block storage goes. The internal storage is called Instant Store, and the external connected storage is called Amazon Elastic Block Store, or Amazon EBS. Let's talk about Instant Store first. Instant Store is a form of directly attached storage, which means the underlying physical server has at least one storage unit directly attached to it. This direct attachment is also the main advantage of using this form of storage. Because it's so close to the physical server, it can be very fast and respond very quickly. But while it can be very fast, there is also one big downside. With Instant Store being directly attached to an EC2 instance, its lifecycle is tied to that of the instance. That means if you stop or terminate an instance, all data in the Instant Store is gone. It can no longer be used or accessed. Naturally, there are many use cases where you want the ability to keep data even if you shut an EC2 instance down. This is where EBS volumes come in. These volumes, as the name implies, are drives of a user-configured size that are separate from an EC2 instance. The drives are simply network-attached storage for your instances. You can think of it as similar to how you might attach an external drive to your laptop. You can attach multiple EBS volumes to one EC2 instance, and then you can configure how to use that storage on the OS of the EC2 instance. When I connect that EBS volume to my instance now has a direct communication line to the data in that volume. Nobody else can directly talk to that volume so that it maintains secure communication. You need an EC2 instance to access data on an EBS volume. If I decided I want to use that EBS volume with a different instance, that's no problem. We can stop the instance, detach the volume, and then attach it to another instance in the same AZ, much like you can unplug your drive from a laptop and plug it into another one. Or, depending on the instance type and EBS volume we're using, we may be able to attach it to multiple instances at the same time, which is called EBS multi-attach. And perhaps the most important similarity is that an EBS volume is separate from your instance, just like an external drive is separate from your laptop. That means if an accident happens and the instance goes down, you still have your data on your EBS volume. This is what we refer to as persistent storage. You can stop or terminate your instance, and your EBS volume can still exist with your data on it. EBS is often the right storage type for workloads that require persistence of data. However, the question typically comes down to which EBS volume type do I use? That's right, there are many different types of volumes, but they've divided into two main volume types: SSD-backed volumes and HDD-backed volumes. In the readings, you'll learn more about these two options. The last thing we'll need to talk about here is backing up data. Things fail, errors happen, so you need to back up your data, even in AWS. The way you back up EBS volumes is by taking what we call snapshots. EBS snapshots are incremental backups that are stored redundantly. The idea here is that if something goes wrong, you can create new volumes from your snapshots and restore your data to a safe state. So we've figured out block storage for our application. Now we need to figure out where to store our employee photos. A natural question is, why can't we just store these photos in Amazon EBS? Well, there's a few reasons. Number one, most EBS volumes are only connected to one EC2 instance at a time. Multi-attach is not supported by all volume and instance types. Eventually, as my app scales, I'll need to figure out how to access those photos from all of my instances. That's an issue. The second consideration is that an EBS volume has size limitations. That means that eventually there will be a limit to how many HD 4K photos I store of my employees in one drive. Ideally, I'd store these photos in a more scalable solution. So, EBS probably isn't the right choice. Fortunately, AWS has a service called Amazon Simple Storage Service, or Amazon S3, that was designed to be a standalone storage solution that isn't tied to compute, meaning you don't mount this type of storage onto your EC2 instances. Instead, you can access your data through URLs from anywhere on the web, which gives this service its nickname, Storage for the Internet. S3 also allows you to store as many objects as you'd like with an individual object size limit of 5 terabytes. This makes it ideal for our employee photos. Now, let's talk about how we store things in S3. The underlying storage type for S3 is object storage. That means that all of the same characteristics of object storage are also characteristics of S3. So S3 uses a flat structure, it uses unique identifiers to look up objects when requested. You get the idea. S3 is also considered distributed storage, meaning that we store your data across multiple different facilities within one AWS region. This is what makes S3 designed for 99.99% availability and gives it 11 nines of durability. All right, let's learn about some S3 concepts. The first concept is a bucket. In S3, you store your objects in a bucket. You can't upload any object, not even a single photo, to S3 without creating a bucket first. You then place your objects inside of these buckets. And if you want to organize and arrange those objects, you can also have folders inside of the buckets. Let's create a bucket in the console. When you log in, you'll type S3 in the service search bar. Once you click on it, you'll see the S3 dashboard showing you all the available buckets for every region. I'll then select Create Bucket. What I want to point out here is that buckets are region specific, so we can choose where we want to place our bucket. In this case, we want to place our bucket close to our infrastructure for our application, which is in the Oregon region, so we'll choose Oregon. Next, we have the name of our bucket. Even though our bucket is specific to one region, our bucket name has to be globally unique across all AWS accounts and must be DNS compliant. Once you create your bucket, AWS will construct a URL using this name, so it has to be something that is reachable over HTTP or HTTPS, meaning there can be no special characters, no spaces, etc. So, for this bucket's name, let's choose employee-photo-bucket-sr-001, which is DNS compliant. Now we can leave the rest as defaults. Scroll down and click Create. To work with this bucket, I'll need to find it in the list and click on its name. Here we can start uploading our objects. To do this, I'll click Upload and then Add Files. Now I can choose any file I want and then I'll click Upload. So, as you can see, the object upload was successful. If I click on the name of my object, I'll be able to see quite a bit of detail. I can see the owner, region, and size. But most importantly, we can see the URL of my object. The first part of this URL is simply my bucket URL that AWS created using the bucket name. Then AWS appended the name of my object, also referred to as the object key, to the bucket URL. Now, what happens if I click on this URL? Access denied. That's weird, right? Well, not really. That access denied message leads us to a bigger question that most people have when they start out on AWS, and that's, who can access my data? Earlier I mentioned that you can retrieve your data from anywhere on the web. And people often think that means that anyone can retrieve that data. By default, it's actually the opposite. Everything in S3 is private by default. This means that all S3 resources such as buckets, folders, and objects can only be viewed by the user or AWS account that created that resource. That's why I got an access denied message, because I was acting as an anonymous user on the internet trying to access an S3 object that's private. Now, that's not to say no object or bucket can be open to the world. They absolutely can be, if you explicitly choose that option. And it's actually kind of a process to make something public. The reason it's difficult to make your objects public is to prevent accidental exposure of your data. Let's try it. Okay, so if we want to make the object we created public, we need to do a few things. Normally, from the object detail page, we would be able to click on the Object Actions dropdown and then select Make Public using ACL. But it is currently not available for us to select. Going to the Bucket Details page, I can select the Permissions tab and see that there is a default setting that blocks all public access. From there, I can verify that Block Public Access bucket setting is set to block all public access. I'll click Edit, then uncheck the top box that blocks all public access, and then save the changes. I'll type Confirm to make the change, and then click Confirm to finalize it. From there, I'll go back to the Bucket Permissions tab and scroll down to the Object Ownership section and click Edit for this pane. Instead of the default setting to disable access control lists or ACLs, I'll select ACLs enabled, then acknowledge, and then save the changes. Now I can go back to the Object Details page and select Make Public using ACL from the Object Actions dropdown. This will allow me to make the object public. To view the object, all I need to do is go back to the Object Details, find the URL, and click on it to view the photo. That's how you make an object public. That being said, most of the time you don't want your permissions to be all or nothing to where either nobody can see it or everybody can see it. Typically, you want to be more granular about the way you provide access to resources. As far as access control, you can use IAM policies attached to users, groups, and roles to access your S3 content, and you can also use a feature called S3 bucket policies. S3 bucket policies are similar to IAM policies in that they are both defined using the same policy language in a JSON format. The difference is IAM policies are attached to users, groups, and roles, whereas S3 bucket policies are only attached to buckets. S3 bucket policies specify what actions you're allowed or denied on the bucket. For example, you might want to attach an S3 bucket policy to it that allows another AWS account to put objects in that bucket. Or you might want to create a bucket policy that allows read-only permissions to anonymous viewers. S3 bucket policies can be placed on buckets and cannot be used for folders or objects. However, the policy that is placed on the bucket can apply to every object in that bucket. All right, to recap, S3 uses containers called buckets to store your objects, and you have several options to control access to those objects through the use of IAM policies and bucket policies. Thank you, and welcome back to everyone's favorite game show, which AWS storage service do I use for my use case? Today we have one contestant during the final round of our show, and that's you.
In order to win the grand prize, you must answer the next 3 questions correctly. There will also be a bonus question, so there's an opportunity to get extra points. All right, once we read the question, you have 5 seconds to answer to get points. Let's get started.
All right, this is the first question. Let's say you're a developer and you plan to build out an application to transcode large media files like videos. You'll be using an AWS Lambda function to perform the transcoding, but you need a place to store both the original media files and the transcoded media files. Due to regulations, you need to store these files for at least a year. Which of the storage services that we've talked about in this course should you use? You have 5 seconds to answer. And the answer is Amazon S3. Why is S3 the best solution here, Morgan?
Well, first of all, the question says that they're using a Lambda function. Because of that, I'm already ruling EBS out, as EBS volumes can only be attached to EC2 instances. Even if they were using EC2, video files are typically large in size, so you may have to use multiple EBS volumes to store that data, which might not be cost-effective in the long run. So EBS is out. Instant storage is out for the same reason. We're not using EC2 here, but also because we want this data to persist for a year, and instant storage is considered ephemeral.
All right, S3 it is. Let's put some points on the board for those who got it right. Morgan, tell us the next question.
The next question is, you're an architect for an e-commerce company that wants to run their MySQL database on an EC2 instance. This database needs a storage layer to store their order and customer information. The database will frequently be accessed and updated, so the storage layer needs to respond quickly. It's important that the storage is fast and durable. Which AWS storage service should you use? You have 5 seconds. And the answer is Amazon EBS. Add 30 points to your score if you got it.
It seems like we're looking for storage attached to the compute, so why not EC2 Instant Store?
Right, that's also an option, but it's not ideal. Since it's an e-commerce company, their order and customer data is what drives the business, which means the persistence and durability of that data is really important. Using EC2 Instant Store would definitely give us the speed we're looking for, but it wouldn't give us the durability needed to store this data long-term. So EBS is the right option.
That makes sense. All right, moving on. 2 more questions. The next one is, you have a web application that needs to write to disk in order to perform certain calculations. The application will store temporary data during the calculation. The most important aspects of this architecture are speed and cost. With 5 seconds on the clock, which storage solution would you choose? And the answer is EC2 Instant Store.
Seth, would you mind telling us how we chose Instant Store and not EBS?
Sure. Once again, we're looking for storage attached to compute in this case. The first thing I want to point out is that this is temporary data we're talking about. We're not looking at a huge amount of data, and we also don't necessarily care about the durability of that data. If the instance fails mid-calculation and you want to plan for failure, you can just restart the calculation from scratch. So durability doesn't matter, but cost does. By not using EBS and instead using Instant Store, you may save yourself some cost. That is because Instant Store is included in the overall EC2 instance price, so Instant Store is the best option for this use case.
Okay, 30 more points on the board for those of you who got it. Now, the final bonus question for an extra 10 points is next. This is a tricky one, and you might have to think outside of the storage options that we've talked about so far. The question is, let's say you're creating a WordPress site on multiple instances. By default, WordPress stores user uploads on the local file system. Since you want to use multiple instances, you'll need to move the WordPress installation and all of the user customizations into a shared storage platform. Which storage option would you use? 5 seconds to go. And the answer is Amazon Elastic File System or Amazon EFS. This service was covered in an earlier reading, so if you got points for this, great job. For those of you who didn't, no worries, but I would recommend that you go back and review the reading related to file storage on AWS.
Let's go ahead and talk about the options. Typically, when we talk about shared storage systems that multiple instances can access, we think Amazon S3. Why wouldn't we use that in this case?
Well, S3 isn't a file system. It's actually a flat structure for storing objects instead of a hierarchy, and you can't mount it onto multiple instances. Because S3 has a different underlying type of storage, it's not right for this use case. So by moving the entire WordPress installation directory onto an EFS file system and mounting it onto each of your EC2 instances when they boot, your WordPress site and all of its data is automatically stored on a distributed file system that isn't dependent on any one EC2 instance.
Nice. Well, you answered all 4 questions and you win the grand prize of the satisfaction of getting them all right. Congratulations, and that's it for today's show. Now that you have a better understanding of storage on AWS, it's time for a hands-on exercise. In this exercise, you'll be working with Amazon S3. You'll have the opportunity to create an S3 bucket, upload an object, and create a bucket policy. Let's quickly go through what you'll be doing in the console. The first thing you'll need to do is create an S3 bucket. To do this, you'll find Amazon S3 in the search bar, and then in the S3 dashboard, you'll click Create Bucket. We'll name this bucket Employee Photo Bucket, and then at the end of the bucket name, we'll append your initials and also a random number. This is to ensure the bucket name is unique across all AWS accounts. We'll also locate this bucket in the Oregon region. Once you create a bucket, you can then upload your photos. I'll do this by clicking on my bucket name and then click Upload. From here, I'll click Add Files, find the object I want to upload, and then upload once more. From there, you should get a message saying you successfully uploaded your photo. Now, just because you uploaded a photo in S3 doesn't mean your application can read it by default. You'll need to give it permission to do so by creating a bucket policy that allows access from your application. The next step is we'll click Exit, which will take us back to our bucket. Then we'll click on the Permissions tab. From there, we'll scroll down and click Edit Bucket Policy. We'll supply you with the correct bucket policy, so you'll just need to copy and paste and then click Save. The next thing you'll need to do is modify your application so that it knows which S3 bucket to access. To do this, we'll launch a new EC2 instance hosting your application and change the user data. So we'll first find the EC2 service, click on Instances, find the instance you launched earlier, and then click on Actions, Images and Templates, and then click Launch More like this. This will use the exact configuration of your instance that you had before. However, you'll need to modify the user data. Scroll down to the bottom where it shows your user data, and then where it shows photos_bucket, you'll type in the name of your bucket. All right, once you're done with that, review and launch. Your application will now use the S3 bucket you created and has access through the bucket policy to your objects. That's it for this one. Have fun. Hey everyone. Welcome to our exercise walkthrough on creating an S3 bucket and then modifying the EC2 instance holding the application to utilize this S3 bucket. As you can see, I'm already in the AWS Management Console and I'm logged in as the admin user that was created before. So the first thing that I need to do is to create the S3 bucket that will be utilized by the application. To do that, I'm going to go up to this search bar here and type in S3 and then click on the S3 service to be taken to the S3 console. Now that I'm in the S3 console, I'm going to go ahead and click Create Bucket. And for my bucket name, I am going to use Employee Photo Bucket dash SR as my initials, and then dash and just 3 random digits. So I'm going to go with 963. I do want to make sure that my bucket is in the same region as the rest of my infrastructure, so I'm going to keep this as the Oregon region or US West 2. And then I'm going to keep all of the other defaults as they are. From there, I'll go ahead and click Create Bucket. And as you can see, my bucket has been successfully created. Now that the bucket has been successfully created, I want to test uploading an object just to make sure that it all works. So I'll click on the name of the bucket, which will take me to the bucket details page. And to upload a file, I can click this upload that's in the center of the page here, but more often I'm going to use the one in the upper right. So I'll click that upload button and then I'll click add files, and I'll go ahead and upload this employee to a photo. After I add that file, I can click upload, and as you can see, the upload of that file was successful. So I'll go ahead and click close there. And in a previous demo, you might have seen a way to make this object publicly accessible, but for this bucket and for the exercises moving on, we don't want this bucket to be just completely open to the world. We want this bucket and these objects to specifically be accessed by the application. And so in order to do that, we need to adjust the permissions for this bucket, specifically the bucket policy. So since I'm already in the bucket details page, I'm going to go ahead and click on this permissions tab, and I want to adjust the bucket policy for this bucket. So I'm going to scroll down to bucket policy and click the edit button, which will take me to a spot where I can create a bucket policy. So to create this bucket policy, I'm going to take the policy that is in the exercise instructions and paste it here. But before I move forward, before I save this policy, I need to edit a few things. The first thing that I need to edit is the account number so that I am utilizing the correct account. And that will be done here where it says insert account number, and I will paste my account number there. And then from there, I will also scroll down and change this area where it says insert bucket name and put my bucket name there. And I need to make sure to do that in both locations, and make sure that I'm also removing the caret brackets when I do so. So now that I've done that, I can go ahead and save these changes, and my bucket policy will be created. And now my account with this specific role will have access to this bucket and the objects within this bucket. So now that I have tested uploading an object and created the bucket, as well as providing access to the bucket by that role, I need to modify the application to utilize this bucket. So to do that, I'm going to go over to EC2 and click on Instances. And as you can see, my stopped instance from previous exercise is there. And there's a cool little shortcut that can be used in order to clone this instance so that I'm launching basically the exact same thing and making sure that I maintain those settings. So to do that, what I'll do is I'll select this stopped instance, and then I'll go over to Actions and down to Image and Templates, and then I can click Launch More like this. What that's going to do is open up my instance launching page, but already have certain things filled out so that my instance is going to be a clone of the stopped instance that I've already launched. So what I want to do is make sure that I know that this is my updated application instance. So to do that, I'm going to append -S3 to the end of the instance name. So it'll be employee directory app S3. and my image and instance type are going to remain the same. So what I can do is just make sure that I'm using the same key pair that I'm using with my other instances. And then I want to scroll down and make sure that this is going to be accessible. So I want to change my auto assign public IP to enable. And that's just going to make sure that I have a public IP address to access for this instance. From there, I'm going to continue to scroll down as all of the other settings are still correct. And then I'm going to expand advanced details. With the expanded advanced details, I can see that the role is already associated to this instance. And I'm going to scroll all the way down to the user data. And what I need to do is put my bucket name in here so that now my application knows what bucket to utilize. And so with my bucket name there, I can now launch my instance. And that will just take a little bit of time. So I'll go over to my instances and I'll wait for that to be launched, just occasionally refreshing it to make sure that everything launches correctly. And I want to wait until the status check is showing 2 of 2 checks passed. So now that I've given it some time, I'm going to go ahead and click refresh again. And as we can see, there are 2 of 2 checks passed. So I just want to make sure that this application is up and running. I will select this instance and copy its public IP address. And then in a new tab, I will go ahead and paste that IP address. And as we can see, the application is up and running. We still can't interact with this application yet because the database hasn't been associated. So that is just to make sure that the application is up and running, and we'll be able to interact with it in just a bit. So now that that's been done, just want to do a couple of the closeout tasks for this. And so just make sure that if you're following along or if you've already done this, that you go ahead and stop this instance as well as delete the object that was uploaded to the S3 bucket. And that'll just make sure that you don't accidentally accrue any charges outside of running this exercise. All right, that's it for this one, and I will see you in the next exercise.
The employee directory application that we've been building out lets you keep track of employee data like their name, location, job title, and badges. The app supports adding new employees, viewing existing employees, as well as editing and deleting employees. All of this data will be stored in a database, which we haven't created yet. According to the architecture diagram, we have chosen Amazon Relational Database or Amazon RDS to store this data. So let's talk about databases for a moment. Relational databases are widely used across all industries, and it's likely your company has many databases supporting a variety of applications and solutions. Relational Database Management Systems, or RDBMS, let you create, manage, and use a relational database. You can install and operate database applications on Amazon EC2 instances, and this is a good option for migrating existing databases to AWS. By running databases on EC2, you are already simplifying things from an operational perspective when it comes to on-premises, and it's a common use case for EC2. When migrating a database from on-premises to EC2, you are no longer responsible for the physical infrastructure or OS installation, but you are still responsible for the installation of the database engine, setting up across multiple AZs with data replication in place, as well as taking on any database server management tasks like installing security patches and updating database software when necessary. So EC2 makes it easier, but there is a way to lift even more of the operational burden of running relational databases on AWS. What if instead of managing a database on EC2, you could use one of the managed AWS database offerings like Amazon RDS? The big difference between these two options is instead of taking care of the instances, the patching, the upgrades, and the install of the database, AWS takes care of all of that undifferentiated heavy lifting for you. The task that you are then responsible for is the creation, maintenance, and optimization of the database itself. So you are still in charge of creating the right schema, indexing the data, creating stored procedures, enabling encryption, managing access control, and more. But all of the rest of the undifferentiated heavy lifting that goes into operating a relational database, AWS takes care of. To start off this section of lessons on databases, we will first cover RDS. The upcoming reading after the video will dive into the history of enterprise relational databases and explain what relational databases are and how they were used. If you aren't familiar with databases, the readings coming up will give you some useful background information. Amazon RDS is a service that makes it easier for you to set up, operate, and scale a relational database. Instead of telling you about RDS, I am going to show you. As you can see, I'm already in the Amazon RDS dashboard. We are going to create the relational database our employee directory application can use to store employee data. First, we will click Create Database. And then we are going to select the Easy Create option, which gives us the ability to accept the standard best practices for backups and high availability. You could select Standard Create if you wanted more granular control to pick and choose the different features of your database setup. Next, you choose the database engine. You can see what is currently supported at the time of this filming for database engines on RDS. And the common engines out there are MySQL, PostgreSQL, MariaDB, Microsoft SQL Server, and then there's this one, Amazon Aurora. Amazon Aurora is an AWS-specific database that was built to take advantage of the scalability and durability of the AWS cloud. Aurora is designed to be drop-in compatible with MySQL or PostgreSQL. It can be up to 5 times faster than the standard MySQL databases and 3 times faster than standard PostgreSQL databases. So if you have some use cases that require large amounts of data to be stored with high availability, durability, and low latency for data retrieval time, consider using Amazon Aurora over a standard MySQL or PostgreSQL RDS instance. In our case, we really only need a simple database without any high performance or large storage requirements. So I'm going to select a standard MySQL instance. Next up, we will choose the database instance size and type. This database instance is similar to how we choose an EC2 instance size and type. Since this is just a demo, I'm going to select a free tier eligible instance. Now we'll give this database a name and assign the database an admin user and password that would be used to connect to the database. Then we will accept the rest of the Easy Create defaults and we are done with this instance creation. You can see that the instance is in the process of booting up, and that will take a few minutes to complete. So in the meantime, let's talk about high availability and RDS. When you create an RDS DB instance, it gets placed inside of a subnet inside of a VPC very similar to an EC2 instance. As you learned already in a previous lesson, subnets are bound to one AZ. And as a best practice for production workloads, we recommend that you always replicate your solutions across at least 2 AZs for high availability. With RDS, one DB instance belongs to one subnet inside of one AZ. So that isn't meeting the criteria for best practices. Now, before you get worried about managing this all on your own, just know that you can easily configure RDS to launch a secondary DB instance in another subnet in another AZ using RDS multi-AZ deployment. And RDS will manage all of the data replication between the 2 instances so that they stay in sync. The other cool thing about RDS multi-AZ deployments is that RDS also manages the failover for the instances. One instance is the primary, and the other is the secondary database. Your app connects to one endpoint. If the primary instance goes down, the secondary instance gets promoted. The endpoint doesn't change, so no code change is needed. All of the failover happens behind the scenes and is handled by RDS. All you do need to do is to make sure that your app can reconnect to the database if it experiences a momentary outage by updating any cache DNS lookups and reconnecting to the endpoint, which now connects to the secondary instance. Pretty cool if you ask me. All right, and we're back in the console and we can see that our instance is up and running. At this point, you can connect to the database instance and load your database schema onto it, ready to go, and much simpler than trying to install and manage this all on your own. Using services like RDS make operating databases significantly more accessible and lowers the operational overhead that comes along with relational database management. Before we move on to learning about Amazon DynamoDB, I want to touch on an idea that's important when you're making architecture decisions for your AWS solutions. Choosing the right database to fit your business requirements rather than forcing your data to fit a certain database choice. There is no one-size-fits-all database for all purposes. You should pick a database that fits your specific use case. And with AWS, you have multiple choices for databases. We covered Amazon RDS and relational databases, and that was the default option for businesses for a long time. But relational databases aren't the best choice for all business needs. AWS creates services to support purpose-built databases, meaning that there are many database services that AWS offers, and they each were built with a certain use case in mind and therefore are optimized for those use cases. Let's think about the employee directory app. We had originally decided that we would use RDS for the database, but now, after thinking about it some more, RDS might not be the best fit for our needs. All we are really doing is storing one record in a table for each employee. There are no complex relationships that need to be managed, and it's essentially just a lookup table. Relational databases offer all sorts of features that are great for complex schemas and relationships, but those features add overhead that is unnecessarily complex for simple things like a lookup table. On top of that, the RDS option we chose charges per hour of instance runtime, so we will get charged for the running instances regardless of whether we're using it or not. Our employee directory application will have much higher usage during the week and no usage on the weekends. Is there an AWS database offering that better fits our needs? Introducing Amazon DynamoDB. Amazon DynamoDB is a NoSQL database that is great for storing key value pairs or document data. This service works great at a massive scale and provides millisecond latency. It also charges based on the usage of the table and the amount of data that you are reading from the table, not by the hour or by the second. This is a better option for our simple employee lookup table. Now, besides the employee directory app, there are other use cases that require databases of varying types. What if you are writing an application that needs a full content management system? Neither RDS nor DynamoDB would be the best solution. Luckily, AWS has quite a number of other database offerings. For this use case, you might look into Amazon DocumentDB. It's great for content management, catalogs, or user profiles. Let's think of another use case. What if you had a social network that you wanted to track? Keeping track of those kind of social webs, figuring out who is connected to who, can be difficult to manage in a traditional relational database. So you could use Amazon Neptune, a graph database engineered for social networking and recommendation engines, but is also good for use cases like fraud detection. Or perhaps you have a supply chain that you have to track with assurances that nothing is lost, or you have a banking system or financial records that require 100% immutability. What you really need is an immutable ledger. So perhaps Amazon QLDB or Quantum Ledger Database is a better fit for this use case. It's an immutable system of record where any entry can never be removed and therefore is great for industries that need to be audited for regulatory and compliance reasons. It can take a lot of experience and expertise to operate databases at scale, and that's why it's so beneficial to utilize one of the AWS database offerings. You don't need to be an expert on running all of these different types of databases. Instead, you can just use the database service that is best for your use case and focus on your application and providing value to your end users. You don't need to build up a ton of in-house expertise to operate a highly scalable, immutable ledger database. You can just use AWS QLDB instead. The key thing to understand is AWS wants to make sure that you are using the best tool for the job. Coming up next, we will explore Amazon DynamoDB and get a look at more of the details. Let's talk some more about Amazon DynamoDB. At the most basic level, DynamoDB is a database. It's a serverless database, meaning that you don't need to manage the underlying instances or infrastructure powering it. With DynamoDB, you don't create a database with tables that relate to each other like a relational database. Instead, you create standalone tables. A DynamoDB table is just a place where you can store and query your data. Data is organized into items, and items have attributes. If you have one item in your table or 2 million items in your table, DynamoDB manages the underlying storage for you, and you don't need to worry about scaling the system up or down for storage. DynamoDB stores data redundantly across AZs and mirrors the data across multiple drives for you under the hood. This lessens the burden of operating a highly available database. DynamoDB, beyond being massively scalable, is also highly performant. DynamoDB has a millisecond response time, and when you have applications with potentially millions of users, having scalability and reliable lightning-fast response times is important. Now, DynamoDB isn't a normal database in the sense that DynamoDB doesn't require a rigid schema or manage complex relationships or constraints. Relational databases, like the MySQL database we created in an earlier lesson, require that you have a well-defined schema in place that might consist of one or many tables that may or may not relate to each other. Relational databases work great for a lot of use cases and have been the standard type of database historically. However, these types of rigid SQL databases can have performance and scaling issues when under stress. The rigid schema also makes it so that you cannot have variation in the types of data that you store in a single table. So it might not be the best fit for a data set that is a little bit less rigid and is being accessed at a high rate. This is where NoSQL databases like DynamoDB are handy. NoSQL databases have flexible schemas. With DynamoDB, you can add or remove attributes from items in the table at any time. Not every item in the table has to have the same attributes. This is great for datasets that do have some variation from item to item. The types of queries you can run on NoSQL databases tend to be simpler and focus on a collection of items from one table, not queries that span multiple tables. This, along with other factors, including the way the underlying system is designed, allowed DynamoDB to be very quick in response time and highly scalable. So, things to remember. DynamoDB is NoSQL. It is purpose-built, meaning it has specific use cases and isn't the best fit for every workload out there. Taking a look at our architecture, we modified it to use DynamoDB. We're going to need to create an employee table for the app to write and read from. We will create this DynamoDB table using the console. And you know what? Let's get Seth out here to help us out.
Hello!
We changed our minds about using RDS and decided to change it over to DynamoDB. It's only one table, and it's essentially a lookup table for our employees. How hard do you think this change is going to be to make?
Well, our app is actually designed to use either RDS or DynamoDB as the backend database, so this won't take long at all. Here, I'll show you how. I'm in the console and will navigate to the DynamoDB service. From here, all you need to do is create a new table. Tables in DynamoDB require you to designate certain attributes as keys that will make an item unique. We will select employee ID as the unique identifier for the items in this table. Then we will just accept the defaults and create the table. Our app was coded to look for a table specifically called employees, so this actually should all work now that the table is created. To test it out, let's head over to the website hosted on EC2 and try to add a new employee. See, that was nice and easy. Now let's go back into DynamoDB and refresh the page and scan all the items in the table, and boom, there it is. It's really that simple for a lookup table like this one.
All right, well, that was easy. Nice. Now, not every use case is this simple. In the reading after this video, there will be more information about how DynamoDB works, so make sure to check that out. Let's put your new database knowledge to use. So far, the employee directory application is operating on EC2, and you have already created the Amazon S3 bucket from which the application will read from and write to for the employee photos. But you aren't really able to test that out without the database also being in place, since adding a new employee needs to store both employee photos and employee data. So let's fix that. In this upcoming exercise, you will create a DynamoDB table called employees, and you will configure the table to store the employee ID, first and last name, location, title, and badges. You will then open the application from the browser and attempt to add a new employee, edit the employee, and delete the employee. After each step, you will verify that the data is being updated in DynamoDB using the AWS console. After you're done creating the table and populating it, you'll have a working app. The DynamoDB table you will use will be automatically scalable and highly available, so there really isn't much to do for this exercise. Have fun.
Welcome to our exercise on setting up the database for our application. So we've already created and modified the application and have created and tested the uploading to the S3 bucket. So to get the application fully functional or at a fully functional stage, the next thing to do is to launch a database. But before I launch the database, I want to launch an instance that's ready to use that database so that we can test it as soon as it's done. So to launch that instance, I'm going to go over to EC2 and go over to the instances. And just like with the last time, I'm going to use the shortcut where I launch a clone of an instance that I've already launched. So to do that, I'm going to select my employee directory app-s3 because that's the most updated version of this application. And then I'm going to go over to Actions, Image and Templates, and then I'm going to launch more like this. Now that I'm in that launch page, what I want to do, just so that I know that I am on the correct instance and that I'm using the correct instance, instead of appending -s3 to this, I'm going to append -DynamoDB so that I know that this is the application instance that is testing with the database and not just connecting to the bucket. So now that I've adjusted that, I can scroll down. I see that most of my settings are still there. I want to make sure that I'm still using the same key in case I do need to access the instance. And I also want to just verify, even though I know that this works, I just want to verify that I am still using the role. One other thing that I want to make sure to do is to ensure that the instance launches with a public IP, and I scrolled just right over this. And so scrolling back, I go to the network settings and auto assign public IP, and just make sure that I click enable on that. And that way the instance will have a public IP and I can access it and test it once the instance and the database are all fully launched. So now that I've done that, I can see that my user data is exactly where I left it after adding the bucket. And now I can click Launch Instance. As always, give that some time to launch. And I can just go over to the instances and occasionally refresh this in order to make sure that my instance has launched. So I'm going to give this a few minutes while waiting for the instance to launch and making sure that where it currently says initializing, it will say 2 of 2 checks passed. Now that it's been a few minutes, I'll go ahead and refresh the page again. And I can see that 2 of 2 checks have passed. So I'll go ahead and select my DynamoDB labeled instance and copy its public IP address, just because I want to make sure that the application is up and running before I proceed. If this weren't running, as we can see it is, if it wasn't, then I would go back and see where I made a mistake in launching the instance. And once the application was successfully running, then I would move forward with creating the database. And so since I can see that the base employee directory application is up and running, I can go ahead and proceed with creating the DynamoDB table. In order to do that, I'm going to go up to the search bar and type in Dynamo and click on the DynamoDB service. And once I'm here, I'm just going to go ahead and click Create Table. Since I don't have any tables currently running, it's just the easiest way to get to this table creation screen. For the table name, I'm going to put employees because the application is set up to work with a database named employees. So this will make it very easy for it to just utilize this. And then for my partition key, I'm going to put ID. And this is because, again, the application is set up to utilize this for organization within the table. And then I'm going to keep this type as a string. After I've done that, all of the default settings can remain, and I'll just go ahead and click Create Table. And that takes just a little bit of time, and the table will be created in just a bit. So I'll just give it a couple of seconds here. So that took almost no time at all, and the table has successfully been created. So now that the table is created, instead of adding items directly to this table, what I want to do is test the application again. So I will make sure I copy my instance's public IP address. So I'll go over to my instances and select the instance that was launched for this and copy its IP address. And then in a new tab, I will paste that address, and I can see that the employee directory app is still running, and it is currently an empty directory. But I can go ahead and add an employee to this directory just to make sure that everything is connected. So what I'll do is I'll click Add, and I'll go ahead and put my name here, and then my location, and my job title. I'll also just select a couple of these options here, just so that we can see what it looks like as everything is added to this table and added to this directory. So since I am a Seattle resident, I am also very much a Seattle fan. And I'm very definitely a coffee snob. I will also not just put this information into the table, but I will add a file. I'll add my employee photo and open that up. And then once that has all been added, I can go ahead and click Save. And as we can see, I now have an entry in the employee directory. So it looks good here, and we can see that I am now in the directory, but I want to show that this isn't just something that was added to this location. So what I will do is show that these items were added in the table and in the S3 bucket. So starting with S3, I'll go over to S3. And then I will open up the bucket that I had created. And as we can see, my employee pick has been added, and it's the employee picture that I uploaded. Even though it has its own designated name here, this is the object that was uploaded through that application. And then I can also go over to DynamoDB and can view my table and view my employee table and explore the table items. And I can also see that my employee items that were added through the directory are here. And so it shows which badges I associated with myself, my name, my job title, my location. It shows the name of the object that was uploaded through the directory, and it shows the ID specifically for this table and the partition key that we established. So now that all of that has been done, what I want to do is just go ahead and keep the table running, but I want to go back to EC2 and stop the instance so that I'm not accruing any additional charges as I prepare to move on to the next stage of this application infrastructure development. So I'll go ahead and stop that instance, and that's where I'll go ahead and close this walkthrough out, and I'll see you in the next one.
Hello everyone, good to see you're here and ready to learn. You're almost done with the course. Now that we've added a storage and database layer, the employee directory application is fully functional, but we still have two more issues. The first issue is that we have no insight into how our application is performing and how it utilizes resources. So to fix this, we will start off the next lesson with a discussion of a monitoring tool called Amazon CloudWatch. After we understand what the demand for your application looks like, we'll address the second problem, scalability. You may find that your application demand isn't always constant, so in the last section of the course, you'll learn how to automate the process of adding resources as demand increases and reducing capacity as demand declines to reduce cost. You'll also learn how to deliver traffic and load balance across a changing amount of resources. Let's get started. When you have a solution built out of many different pieces, like how we build solutions on AWS, it's important to be able to see how different services are operating over time and react to operational events as they are happening. Let's consider the employee directory application. It's Monday morning and the users are seeing latency on page loads. It's probably not good enough to wait until a user sees the slowdown, calls, or enters a ticket saying, "Hello, your application is running slow." If you receive a call or a ticket from your users, you can then react and troubleshoot the issue. Waiting for users to notice and report issues to investigate will generally lead to unhappy end users. Ideally, you'd be able to respond to operational issues before your end users notice. On top of that, the end user can only provide information about their experience, and they cannot give insight into the inner workings of your solution. So they can report the issue to you, but where is that issue coming from? Is it an EC2 problem? Is it a database problem? Is it a code change that has recently been deployed? Without monitoring, you have to do some digging to figure all of that out. So what do we need to do? The first step is to put proper monitoring in place. Monitoring is a verb. It's something we do. We collect metrics, we collect logs, we watch network traffic. The data needed to help you pinpoint problems comes from the different services and infrastructure hosting the application, and monitoring tools help you collect the data being generated by these systems. In a cloud environment that is ever-changing and ever-scaling, it's even more important to collect various types of information about the systems as they scale up and down and change over time. The different services that make up your solution generate data points that we call metrics. Metrics that are monitored over time are called statistics. A metric is a data point like the current CPU utilization of an EC2 instance, where other data you monitor could come from different forms like log files. For example, your network will generate data like flow logs so you can see how network traffic is coming into and out of your VPC. The servers will be generating metrics such as how much CPU is currently being used or how much network traffic the instance is accepting at any given moment. Then finally, one more example is your database layer, which will generate metrics such as the number of simultaneous connections to your database. So you need a way to collect all of this information. Once it's collected, it can be used to establish a baseline, and this baseline can be used to determine if things are operating smoothly or not. If the information collected deviates too far from the baseline, you would then trigger automatic alerts to go out to someone or something to try to remediate the issue. A good monitoring solution gathers data in one centralized location, so you can proactively monitor and operate your system to keep your end users happy, as well as allows for automated tasks to be triggered based on the data coming in. This is where Amazon CloudWatch comes in. CloudWatch allows you to monitor your solutions all in one place. Data will be collected from your cloud-based infrastructure, so you can see things like database metrics coming from RDS or DynamoDB, alongside EC2 metrics, as well as metrics coming from other services making up your AWS solution. Coming up next, we'll dive into some CloudWatch features and use cases. In this video, I'm going to run through some of the features that Amazon CloudWatch has to offer. We've already deployed resources into our AWS account with the employee directory application. So to get a handle on what CloudWatch is and how it works, let's dive into the AWS console and see what we can see. The end goal of this demo is to set up a dashboard that shows us the CPU utilization of the EC2 instance over time and set an alert that will be sent out if the CPU utilization of the instance goes over 60% for a period of time. I'm already in the console and I will navigate to Amazon CloudWatch. A lot of the AWS services begin reporting metrics to CloudWatch automatically when you create resources. Let's explore what types of metrics are available from the resources that we have already created in a previous lesson. To do that, let's first create a dashboard. A dashboard in CloudWatch is a customizable page in the console that you can use to monitor your different types of resources in a single view. This includes resources that are spread across different AWS regions. I want to create a dashboard that shows me the CPU utilization over time for the EC2 instance hosting the employee directory application. So now I'm going to click Dashboards in the left-hand navigation, and then click Create a Dashboard, and we can then name this dashboard My Dashboard. AWS resources automatically send metrics to CloudWatch, and it's built into the service. I'm going to select which widget we can add to the dashboard, and I will select a line graph here. Next, we can take a look at what the data source will be for this widget, and I will select Metric for this. Now we can browse through all of the available metrics. This is organized by service, so I will find EC2. I will select EC2, and then I want to view per instance metrics. From here, I can scroll through the different EC2 specific metrics that are being reported to CloudWatch, and I want to select CPU utilization. Click Save, and now we are brought back to the dashboard with one line graph for one specific instance's CPU utilization. This gives us visibility into one aspect of the health of our EC2 instance. You can explore in your own account what other metrics are available for you through CloudWatch by default, but you can also report some custom metrics to CloudWatch programmatically. This is good to know because with EC2 and CloudWatch, you only get visibility into the health of the instance by default, which doesn't really give you a holistic picture of the health of your application. The application running on the instance might not be operating correctly, but the CPU utilization could be fine. So keep in mind that you may choose to use custom metrics to get a more detailed and accurate view of the health in these dashboards. Once a dashboard is created, you can then share it with your team members. Now let's move on to another feature of CloudWatch called Amazon CloudWatch Alarms. CloudWatch Alarms allow you to create thresholds for the metrics you are monitoring, and these thresholds can define normal boundaries for the values of the metrics. If a metric crosses a boundary for a period of time, the alarm would be triggered, and then you can take a couple of different automated actions after an alarm is triggered. In our use case, I want to notify someone if the CPU utilization spikes over 70% for a period of time, say 5 minutes. Let's create an alarm to do that. Let's navigate to the Alarm section and click Create Alarm. Now what I want to do is create an alarm for CPU utilization, so I will select Metric, click on EC2, Per Instance Metrics, and scroll down to select CPU utilization. Now I will select the time period we are monitoring to trigger the alarm, which in this case is 5 minutes. You want to make sure you pick a reasonable time period where you don't wait too long to respond, but you also don't respond to every short-lived uptick in CPU utilization. There is a balance to strike here, and it will be highly dependent on your specific situation and your desired outcome. Okay, so now I will scroll down and type in 70 for the static threshold which we are watching for, which is representing the CPU utilization threshold. If it goes over 70% for more than 5 minutes, it's likely that there's a problem. And now we will configure the action that will be taken if the metric triggers the alarm. For CloudWatch alarms, there are 3 states an alarm can be in: either in alarm, OK, or insufficient data. An alarm can trigger an action when it transitions between these 3 states. In our case, I want to have this send out an alert to an email address when it transitions from OK to in alarm. AWS has a service called Amazon Simple Notification Service, or SNS, which allows you to create a topic and then send out messages to subscribers of the topic. You can imagine a scenario where we have systems admins or developers on call for our employee directory application. And if something goes wrong, we want to send them an email paging them, letting them know that something is going wrong with the app. So we will select Create a new SNS topic since we do not have one in place already, name it CPU Utilization Topic, and then I will put in an email address here to receive the alert. Notice as I scroll down here that there are other actions you can take for a CloudWatch alarm. We will talk more about some of these options in upcoming lessons. So then click Next and give this a name and a description. And finally, click Create Alarm. It will take some time for the alarm to begin collecting enough information to leave the insufficient data state and transition into the OK state. That is it for now. We will continue to use CloudWatch in upcoming lessons to make our solution elastic through EC2 autoscaling.
At this point, you know how to set up alarms to notify you when your infrastructure is having capacity, performance, or availability issues. But we need to go one step further. We don't just want to know about these issues, we want to either prevent them or respond to them automatically. In this section of the course, you'll learn how to do just that. Currently, our infrastructure looks like this. We have one EC2 instance hosting our employee directory application in a single availability zone with DynamoDB as its database and S3 for storage of static assets. If I wanted to evaluate the availability of our infrastructure, I have to look at each individual component. I know that both DynamoDB and Amazon S3 are highly available by design, so that leaves one issue, this singular instance of our application. If that instance goes down, employees have no way to connect to our application. How do we solve this? Well, as you already know, to increase availability, we need redundancy. We can achieve this by adding one more server, but the location of that server is important. If instance A goes down, we don't want instance B to go down for the same reasons. So to avoid the unlikely event of, say, an AZ experiencing issues, we should ensure that instance B is put in another AZ. So now we have two instances that we've manually launched, but let's say our company grows rapidly and the employee directory application is constantly being accessed by thousands of employees around the world. To meet this demand, we could scale our instances vertically, meaning we could increase the size of the instances we have, or we could scale our instances horizontally, meaning we could add more instances to create a fleet of instances. If we scale vertically, eventually we'll reach the upper limit of scalability for that instance. But if we scale horizontally, we don't have those same limitations. I can add as many instances to my fleet as I'd like. But if I need, say, 15 more instances to meet demand, that means I'd have to manually launch those 15 instances and manually shut them down, right? Well, you could do it that way, or you could automate this process with Amazon EC2 autoscaling. This service will allow you to add and remove EC2 instances based off of conditions that you define. With this service, you can also maintain the health of your fleet of instances. But with more EC2 instances comes a bigger issue. How do we access those servers? Before, we were simply using the instance public DNS name or public IP address. But when you have multiple instances, you have multiple of IPs to route to. Instead of maintaining the logic to send requests to your various servers, you would use a load balancer to distribute those requests across a set of resources for you. And since you can connect from your load balancer to access the application, you no longer need to use the public IPs of your EC2 instances. Before the next video, I'll spin up two instances hosting our employee directory application. See you soon. Now that we have multiple EC2 instances hosting our application in private subnets, it's time to distribute our requests across our servers using the Elastic Load Balancing, or ELB service. Conceptually, how this would work is a typical request for the application would start from the browser of the client and is then sent to the load balancer. From there, the load balancer determines which EC2 instance to send the request to. After it sends the request, the return traffic would go back through the load balancer and back to the client browser, meaning your load balancer is directly in the path of traffic. Now, if we're looking at the architecture, the ELB looks like one thing. It looks like a single point of failure. But ELB is actually, by design, a highly available and automatically scalable service, much like S3 is. What that means is that A, the ELB is a regional service, so you don't have to worry about maintaining nodes in each availability zone or having to configure high availability yourself. AWS maintains that for you. And B, The ELB is designed to handle additional throughput and will automatically scale up to handle the traffic coming in without you having to configure that feature. Now, there are several types of load balancers that you can choose. There's the application load balancer. That load balances HTTP and HTTPS traffic. There's the network load balancer that routes TCP, UDP, and TLS traffic. And there's the gateway load balancer that is mainly used to load balance requests to third-party applications. For our employee directory application, we'll be load balancing web traffic, so we'll be using the application load balancer, or the ALB. When you create an ALB, you'll need to configure three main components. The first component is a listener. The goal of the listener is to check for requests. To define a listener, a port must be provided as well as the protocol. For example, since we're routing web traffic and we set our application to use port 80, we'd want our load balancer to listen to port 80 using the HTTP protocol. Additionally, we could set up a listener port for 443 using the HTTPS protocol. The second component is a target group. A target is the type of backend you want to direct traffic to, such as an EC2 instance, AWS Lambda functions, or IP addresses. A target group is simply just a group of these backend resources. Each target group needs to have a health check, which is how the load balancer can check that the target is healthy so that it can start accepting traffic. The ALB operates on the application layer, which is layer 7 of the OSI model. This gives the load balancer a lot of cool features, and one of those is the third component, which is a rule. A rule defines how your requests are routed to your targets. Each listener has a default rule, and you can optionally define additional rules. So if we had two target groups, A and B, we can set up an additional rule that says if traffic is coming to our /info page, we can deliver that traffic to target group B. So because of the fact ALB operates on layer 7, you can customize paths for your traffic. Okay, now it's time to put this in practice. Let's create an application load balancer in the console. If you want to find the ELB service, you'll need to go to the EC2 console. So we'll type in EC2 to the service search bar, and then on the side panel, we'll select load balancers. Once we bring up our load balancers dashboard that shows all of the load balancers for this region, we'll then click Create Load Balancer. Here's where we choose which type of ELB we want, and you see the three main types. We'll be using the ALB. From here, we'll choose a name and call it app-ELB. The next setting asks if we want an internet-facing or an internal-facing load balancer. An internet-facing load balancer does what you might expect, which is route requests from clients over the internet to your backend servers or targets. An internal load balancer, on the other hand, will route requests from clients with a private IP to targets with a private IP. For example, if you had a 3-tier application with a web, app, and database tier, you could use an internal-facing load balancer to route traffic from your web tier to your app tier. For this app, we'll be routing internet traffic, so you can leave it as internet-facing. After that, we choose which availability zones we want to route traffic to. First, we'll choose the VPC, select both availability zones, and then choose the two public subnets. Now you choose your security group for your load balancer. This is where you decide which traffic you want to allow in. Here, we'll choose a security group that will allow traffic on port 80 from anywhere. Then, we configure the listeners and routing. Currently, the default setting is to allow HTTP traffic on port 80. If we want to allow or limit to HTTPS traffic, we can click Add Listener and choose HTTPS, but for this demo, we'll stick with the default. Next, we'll configure routing. And for this, we need to click on Create a Target Group. This will open a new page where we can configure the target group. First, we will select the target type, which will be instances. Then we can scroll down and we'll give it a name, such as app-target-group, and leave all of the defaults selected. Then we'll click Next to choose which instances we want to live in the target group. For here, I'll choose the 2 instances I've created in private subnets and click Include as Pending below. And click Create Target Group. Now, coming back to the load balancer creation page, if we refresh the dropdown for target groups, we'll see the target group that was just created. We will select this and then scroll down, accepting the rest of the defaults and clicking on Create Load Balancer. After the load balancer has been created, we can then select it and find the DNS URL in the description box. We can then pull that DNS URL, copy and paste it into a new tab, and from here you can see our app. If I go to the /info page of our app, you can see which availability zone we're currently in. If I refresh the page a few times, you should see eventually that I'm being directed to both my EC2 instances in both AZs.
As more people visit our application, the demand on our 2 web servers is going to increase. At some point, our 2 instances aren't going to be able to handle that demand, and we're going to need to add more EC2 instances. Instead of launching these instances manually, we want to do it automatically with EC2 autoscaling. Autoscaling is what allows us to provision more capacity on demand, depending on different thresholds that we set, and we can set those in CloudWatch. Okay, so we're going to draw a high-level example of how this works, and then Ceph is going to build it for us. So, looking at our application, traffic coming in from the outside can come down to either EC2 instance. In this video, these EC2 instances will be part of an auto-scaling group. Each of the EC2 instances that we launch will be completely identical. Then we're going to run code to simulate stress on our employee directory application that will make the instances think that they're overloaded. When this happens, the instances will report to CloudWatch and say that their CPUs are overloaded. CloudWatch will then go into an alarm state and tell autoscaling, give me more EC2 instances. As each instance comes online, they will pass ALB health checks, they'll start to receive traffic and give us the horizontal scalability that we need. Ceph will be helping us build out the scalability. Let's have him join us. You got all that, right?
Yes, it's time to make this app scale. Let's make it happen. So to get this built out, the first thing we need to do is create a launch template. This is going to define what to launch. So it's all about setting the configurations for the instances we want to launch. Morgan said we want our instances to be identical, and that's what we'll be configuring here. First thing we're going to do in the EC2 dashboard is find launch templates on the side panel and click Create Launch Template. We'll first provide a name and description. I'll call this app-launch-template and give it a description of a web server for the employee directory app. Then you'll notice this handy checkbox that asks if we are going to use this launch template with EC2 autoscaling. We are, so we'll check it and scroll down. We'll then choose the AMI. Again, the launch template is all about what we launch. So what we want to do is create mirrors of the web servers hosting our app that we already have running. That way, whenever we scale out, we just have more instances with the exact same configuration. When we launched the instance hosting our app earlier, we used the Amazon Linux AMI and a T2 Micro instance type. So we'll select both of those options. Next, we choose the security group for our new instances. We'll use the same security group you created earlier in the course, the web security group. Then we scroll down and expand the advanced details selection. Here we'll choose our instance role, the same role we used previously in the instance profile dropdown. Once we do that, we'll scroll all the way down and paste our user data. This is what grabs our source code and unzips it so that our application runs on EC2. Now we're done and we can click Create. Now that we've configured our launch template, which again defines what we launch, we now have to define an autoscaling group which tells us where, when, and how many instances to launch. To create an autoscaling group, we'll select Autoscaling Groups on the side panel and then create an autoscaling group. Here, we'll enter a name such as app-asg, and then select the launch template we just created, app launch template, and then click Next. Then we'll select our network. We'll choose the same VPC we created earlier in the course, app-vpc, and select both the private subnets we created, private A and private B, and then click Next. We then need to select Attach to an existing load balancer to receive traffic from the load balancer we created earlier, and then choose our target group, App Target Group. Click Enable ELB Health Checks so that the load balancer will check if your instances are healthy, and then click Next. Now we'll choose the maximum, minimum, and desired capacity. The minimum we'll say is 2. This means that our auto-scaling group will always have at least 2 instances, 1 in each availability zone. The maximum we'll say is 4, which means that our fleet can scale up to 4 instances. And the desired capacity, which is the number of instances you want to be running, we'll say is 2. Next, we can configure the auto-scaling policies. With scaling policies, you define how to scale the capacity of your auto-scaling group in response to changing demand. For example, you could set up a scaling policy with CloudWatch that whenever your instance CPU utilization or any other metric that you'd like reaches a certain limit, you can deploy more EC2 instances to your auto-scaling group. So, what we want to do is use target scaling policies to adjust the capacity of this group. Earlier, Morgan created a CloudWatch alarm that resulted in the action of sending out an email. Here, we're going to create a target tracking policy, much like Morgan created the alarm, but this time it will result in the action of triggering an auto-scaling event. So we'll name this CPU utilization, and then we'll say that we want to add a new instance to our fleet whenever the target value is 60%. We'll also keep the instance's need setting at 300 seconds to warm up before scaling. Then we'll click Next to configure notifications when a scaling event happens. This is optional, so for now we're going to skip past it. All right, here we can review and click Create Auto-Scaling Group. Now, all that's left is to stress our application and make sure that it actually scales up to meet the demand. To do that, I'll open up a new tab and paste the endpoint for our Elastic Load Balancer. Here's our application. I'm going to go to the info page by appending /info on the URL. You'll notice here that we built in a stress CPU feature. This is going to mimic the load coming into our servers. In the real world, you would probably use a load testing tool, but instead we built a stress CPU button as a quick and easy way to test this out. Then we can watch our servers scale with that auto-scaling policy. So, as the CPU utilization goes up, our auto-scaling policy will be triggered and our server groups will grow in size. I'm going to select 10 minutes for our stress test. All right, some time has passed. We've stressed our application, and if we take a look at CloudWatch, we can see what happened. So let's click on CloudWatch. If you look here, we can see our alarm summary. We went over 60% CPU utilization across instances. That was our threshold, so we launched new instances. We launched 2 new instances into our auto-scaling group. Then you can see the loads start to come down. Because we've launched more instances into our auto-scaling group, there were more hosts to accept traffic for our Elastic Load Balancer, and the average CPU utilization went down across servers. All right, let's go look at the EC2 instances that were launched into the auto-scaling group. I'm going to go to the EC2 dashboard. From here, I'm going to scroll down to Target Groups and select the App Target Group. I'm going to select Targets, and we can now see that we have 4 healthy target instances in our auto-scaling group. So now we have an environment with an auto-scaling group and our launch template. We've set up an alarm in CloudWatch that whenever our CPU utilization goes over 60%, we're going to launch more instances into that group. All right, and this app should be able to scale now using EC2 autoscaling.
Great. Thank you, Steph. All right, now, if we wait around long enough, what we would see is as the CPU load dropped off, then one by one, they would each get terminated because we no longer need them, bringing our state all the way back down to the basic 2 we need, the minimum number for this particular group. All of that done without any human interaction. If for some reason you are doing this in your AWS account, don't forget to delete the autoscaling group instead of the instances. Otherwise, guess what will happen? The autoscaling group will spin up more instances to replace the ones that were deleted. So ensure you are deleting the autoscaling group as well.
Welcome to the final exercise of this course. In this exercise, we'll be optimizing our employee directory application by using Amazon CloudWatch, ELB, and EC2 autoscaling. The first thing you'll do is create an application load balancer. You'll use this load balancer to distribute requests to your EC2 instances that host your application. Next, you'll use autoscaling to launch the instances. To do this, you'll first create a launch template to specify your instance configuration. You'll then use this launch template to create an autoscaling group. You'll specify a minimum of 2, maximum of 4, and desired capacity of 2 instances. You'll also configure your autoscaling group to use the application load balancer you created. You'll configure your autoscaling group to scale based off of CloudWatch alarms and trigger autoscaling to add a new instance when CPU utilization reaches 60%. Finally, you'll be able to go into your application and test this by going to the info page of the employee directory app. You can trigger an increase in CPU load and see your application horizontally scale in real time. Enjoy, and since this is your final exercise, remember to tear down all the infrastructure you created for this course if you have been following along. That way, you can minimize future costs.
Hey y'all, and welcome to our final exercise walkthrough where we handle the load balancing and auto-scaling for our application. As you can see, I am already logged into the AWS Management Console, and I'm using the admin user that I created earlier in order to handle these tasks. So in order to set up our load balancing and auto-scaling, the first thing I'm going to do is launch the application instance. So I'm going to go over to EC2, and then go over to my instances and work with the last instance that I created. In this case, it's the employee directory app DynamoDB. So I will select that, and I will go ahead and use the shortcut that we've been using where I click Actions, Image and Templates, and then Launch More like this. In this case, instead of appending DynamoDB, I am going to append LB for load balancing for this instance. And then I'm just going to scroll and make sure that everything is where I want it to be. So I want to make sure I continue using the same key pair. And then I also want to make sure that I enable the public IP so that I can access and test this instance. From there, I'm going to scroll down to the advanced details, again, just to double check that my instance role is still selected and that my user data is where I left it. And from there, I'll go ahead and click Launch Instance. And now that that instance is launching, I can go over to View My Instances, and I will just give this some time to go ahead and be fully launched so that we can make sure that the instance is up and running and that the application is ready to go. All right, now that it has been a few minutes, I'll go ahead and click refresh again. And it looks like 2 of 2 checks have passed for this application instance. So just to verify that the application is up and running, I'll copy that IPv4 IP address and then paste that into a new tab. And it looks like our employee directory is up and running. And because it does have access to the S3 bucket and DynamoDB table that were created, the data that I had already added to the directory is still going to be visible, even though this is a new instance. So now that I've verified that that works, I can go ahead and close that. And what I want to do next is to create the application load balancer. So to do that, I do need to be in the EC2 console because the load balancers are accessed through the EC2 console. So the way that I get to the load balancing is I scroll down in this side navigation pane, and then there's this section near the bottom that says load balancing. What I want to do is click load balancers, and now that I'm in the load balancers page, I will go ahead and click create load balancer. And the type of load balancer that I want here is an application load balancer. So under that option, I will go ahead and click create. For my load balancer name, I want to go ahead and put in app-elb. And then I do want to make sure that this is an internet-facing load balancer so that I can access its endpoint from the internet. After that, I'll go ahead and scroll down. And under network mapping, I need to make sure that I select my app VPC because that is where my instances are launched. That's where my instances for this application will be launched. And then for the availability zone mappings, I want to select both US West 2A and US West 2B. Once those are selected, you can see that it pops up with the ability for me to specify which subnets I want to route within. And I will go ahead and keep that with the public subnets for those availability zones. So scrolling down, I get to security groups. And what I want to do here is just make sure that proper access is set up for my load balancer. So to do that, instead of using this default security group, I'm going to go ahead and click create new security group, and that will take me to a page where I can do just that. I can create a new security group. So for this, I'm going to name it load balancer SG, and then my description is just, this is for HTTP access. The VPC for this needs to be my app VPC. So just making sure that that's the one that is selected. And then I want to work with my rules. So currently it has no inbound rules. So I'll go ahead and add a rule and then add HTTP access from anywhere. And from there, I will go ahead and create my security group. So now that that security group has been created, I can close out that new tab and then refresh my security group list. And now I have the ability to select the security group that I just created. And that will be the security group that I use for this load balancer. Now that that's been done, I'm going to scroll down to listeners and routing. And this is going to be where I determine how my load balancer is receiving requests and how it's forwarding those requests on. So here I'm going to click create target group, and that will open up a new tab. I want to keep instances selected as the target type, and then I want to name my target group app target group. After that, I want to make sure that it's associated with the correct VPC. And then I want to scroll down to health checks. And health checks is going to be how the load balancer determines which instances are capable or which targets are capable of receiving requests. Here, I want to expand advanced health check settings. and I want to make my healthy threshold 2 and my unhealthy threshold 5. I also want to make my timeout 30 seconds, and I want to change the interval of checks to 40 seconds. So what this does is the healthy threshold is how many consecutive health checks that are successful are going to determine if the instance or if the target is available to receive requests. An unhealthy threshold is how many consecutive failed health checks determine which targets are not available to receive requests. For the timeout, this is just how long is it going to take for the health check to fail if no response is received. And then the interval is just how often are the health checks going to be sent. With all of those selected, I'm going to go ahead and scroll down and then hit next. And now I am able to register targets to my target group that I am creating. For this, I am going to go ahead and select the instance that I had just launched to include as a target, and then I'm going to select include as pending below. Now that that has been included, what's going to happen is I will create the target group, and then the load balancer will start those health checks to make sure that that instance as a target is up and running. So I'll go ahead and click Create Target Group. And that target group has been created. So since that target group has been created, I will go ahead and close this tab. And back on my load balancer creation page, I can go ahead and refresh my listeners and routing drop-down list, and I can select app target group, which I have just created in order to be utilized by the load balancer. Once I've selected that, I can scroll down and click Create Load Balancer. And now that the load balancer is being created, I can click View Load Balancer. And as you can now see, I have a load balancer that has freshly been created, and it is just currently being provisioned, and that will just take a couple of minutes. So after a couple of minutes, we can see that the state of the load balancer has changed to active. So what I want to do from here is just test to make sure that I can access my application from the load balancer. So to do that, I will select this specific load balancer, and what I want to do is copy the DNS name for this load balancer. With that copied, I will go ahead and open up a new tab, paste that load balancer endpoint in there, and as we can see, the load balancer is directing traffic to the application instance with the data that I have added. Okay, now that I can see that that works, I'm going to go back to the EC2 Management Console, and the next thing that I want to do is get everything ready for scaling. So the first thing that I need to do in order to do that is to create a launch template. So in the left-hand menu here, under Instances, there's a selection for Launch Templates. I'm going to go ahead and select that. And because I don't currently have any launch templates created, I will go ahead and click Create Launch Template. My name for this will be App Launch Template, and my description will just be a web server for the employee directory application. From there, for auto-scaling guidance, I want to select this because I am specifically going to be focusing on EC2 autoscaling. And then I want to scroll down and select the components that are necessary for me to launch my instances. What the launch template does is just it tells autoscaling what it is that I want to launch. So what instances, how to configure those instances, and all of the details that you would use if you were manually launching instances. So what I can do here is, since I do have instances already running, I can select currently in use, and that will bring up what I am currently running. And because my account only has one instance currently running, it will pull the information for that instance. For my instance type, I want to select a T2 micro because that is the instance type that I want to scale, and it's free tier eligible, so that will keep those costs down for this little exercise. For my key, I'll just keep selecting the same keys that I have been. And then for my network settings, I want to make sure that I select the security group that I created specifically for this. And so that is going to be my web security group. After I've done that, I'm going to go ahead and scroll down to my advanced details and expand that. And the two main things that I want to do here are I want to make sure that my instance profile is utilizing the role that I've set up for access to the other resources. And then I want to make sure that I add my user data in order to install and configure the application that I'm using. So to do that, I will go ahead and paste the user data in here. But then I just need to make sure that I change the necessary components so that I am working with the same resources. So I'll change my bucket to the bucket that I've created for this application, and I will change my region to US West 2 for the Oregon region. So once I've done that, I can create my launch template. And as we can see, my launch template has been successfully created. And if I go over to View Launch Templates, I can see the newly created launch template. From here, I need to create the actual autoscaling group. So to do that, I am going to scroll down in this left-hand navigation pane, and under autoscaling, I'm going to select autoscaling groups. I don't currently have any autoscaling groups, so I will click Create Autoscaling Group. The name for this group will be App ASG, and because I've created a launch template, I can go ahead and just select the launch template that was created specifically for this group. Once that has been selected, I can go ahead and click Next. And this is where I get to choose various launch options. So in this case, I want to make sure that I am launching into my app VPC, and then I want to launch these instances into my public subnets. So I will choose public subnet 1 and public subnet 2. With those selected, I can go ahead and click Next. And now I'm in my advanced options. The reason that this is important is because, for one, I've created a load balancer and I need to make sure that this autoscaling group is utilizing that load balancer. So what I can do is attach to an existing load balancer, and then I can choose my load balancer from my load balancer target groups. From here, I can just drop this down and select App Target Group. And then for my health checks, I will just have the load balancer handle the health checks since those have already been set up. After that, I will click Next. And here is where I can decide how large and how small I want my group of instances or my fleet of instances to be. So what I'm going to do here is I'm going to change my desired capacity to 2. I also want my minimum capacity to be 2, and then I want my maximum capacity to be 4. This will mean that my auto-scaling group will launch with 2 instances, and then it will never get smaller than 2 instances. So if one of those 2 instances is deemed unhealthy, it will launch an instance to replace that. If there is a load on the load balancer and a load on the instances, then the maximum size that my fleet will be is 4 instances. And so that's what this group size is establishing. After that, I want to make sure that for my scaling policies, I choose a target scaling policy. And for this target scaling policy, I can change my target value for my average CPU utilization to be 60. And I'll keep the 300 seconds of warm up as the default. And that's just going to make sure that if I scale, the scaling is going to be based on my average CPU utilization across my fleet. And if that hits or goes above 60%, then it will launch new instances, but it will give those instances 300 seconds or 5 minutes to warm up and start passing their health checks before it does another scaling action. So now that that's done, I can go ahead and click Next. And for notifications, I am not currently going to add notifications for my walkthrough, but here you could add a notification and make that notification an SNS topic and utilize your email address so that you can be notified anytime a scaling action is taken. But instead, I'm just going to go ahead and click Next, and then Next again, and just quickly review that everything is where I want it before creating my auto-scaling group. So now that my auto-scaling group has been created, I need it to get everything to that desired capacity. And once it's there, I can test and make sure that my application is still accessible, and then I can test scaling. So before I test my application, what I want to do is go back to the EC2 console, and then under load balancing near the bottom of the left-hand menu, I want to hit target groups. The reason I'm doing this is that I want to make sure that before I start testing anything, that everything is running and is healthy. If I want to keep an eye on it, what I can do is click targets, and then as you can see, the auto-scaling group has launched 2 additional instances, one in each availability zone, and they are currently healthy. So that means that my application is up and running, and I have multiple instances now that will be utilized whenever requests are made. And so if one were to become unhealthy or go down for any reason, I have the other instances there to still answer those requests. So to test my application and the scaling of the application, what I'm going to do is go back to the application page that I have open, and there's a stress test built into this application just to make it easier for this exercise. So what I'll do is append /info to the end of my URL, and that will take me to the page that allows me to handle some tooling. One of the things I can do is I can refresh this page, and it, as you'll see, it will go between the various instances that I have running and the availability zones that those instances are running in. So refreshing this will show that it's changing the instances and changing the availability zones that are being hit. But what I want to do to test this is utilize this stress CPU built-in test here, and I'm going to go ahead and stress the CPU for 10 minutes. So this is going to allow me to stress my CPU to get it above that 60% threshold and launch new instances. And so while I'm waiting for that to happen, I'm going to go back over to the target group and view my targets, and then I'm just going to periodically refresh this to see when new instances are being added and when they're healthy. So I'm just going to give that some minutes as I wait for those to launch. So now that I've given it some time, I'm going to just see if some new instances have been launched. So I'm going to go over to instances, and as I can see, 2 more instances have been launched in response to the scaling action that is happening because of the CPU stress that we initiated. So these instances will be launched, and then they will be added to the group of instances that are part of the entire fleet. I hope you enjoyed the course and that the exercises were helpful to you, and I'll see you in another course.
Nice work getting through this course. Let's take a look at how this architecture we built turned out. The employee directory application is currently being hosted across multiple EC2 instances inside of a VPC in a private subnet. These EC2 instances are part of an EC2 auto-scaling group, and traffic is being distributed across them using an application load balancer. The database is being hosted on Amazon DynamoDB, and the images are stored in S3. Beautiful. Looking at this from a maintenance perspective, you would need to ensure that your auto-scaling policies are working well with your expectations, and it would likely take some tweaking over time. You also would need to install security patches and updates for EC2, as well as keep an eye out for new instance sizes or types that might help you further optimize your solution. Now, this is really great, but as with everything built on AWS, there are multiple ways you can architect a solution and have success. It really depends on what you are optimizing for and what you are trying to do that will determine how you architect an application. That being said, what I want to do now is present to you an architecture that could be a wonderful serverless redesign of the employee directory application, taking full advantage of cloud-native services like AWS Lambda. I'm going to touch on some services we haven't covered yet in this course to give you ideas of alternative architectures. So, this employee directory application is a great example of a standard 3-tier application where you have the presentation layer, the application layer, and the data layer. The presentation layer is the user interface, the application layer is the business logic, and the data layer is the database. As things are right now, the Amazon EC2 instances are hosting both the presentation layer as well as the application layer. This is true because the EC2 instances have a web server running that is serving the content for the website, like the HTML, CSS, and JavaScript, which is the presentation layer. Then the same instances are also handling requests for the backend logic for viewing, adding, updating, and deleting employees, which is the application layer. What I want to do now is separate those two pieces entirely, having the front end of the website hosted separately from the backend application logic. It's important to separate the presentation layer from the application layer so that the instances are not overloaded by handling different types of requests at the same time. We're going to move the presentation layer to be hosted out of Amazon S3. S3 supports static website hosting, and therefore this is a great place for us to host the HTML, CSS, and JavaScript for our website. When you're hosting a static website with S3, you may think, well, my website isn't static, it's dynamic. It's pulling data from a database, so this isn't a static website, and therefore S3 would not work for this use case. This is where JavaScript comes in. JavaScript files have the ability to make HTTP requests and load dynamic content, modifying the static page to display results that come back from requests. So this should work well. The presentation layer is taken care of. Now I want to tackle the application layer. It used to be hosted on Amazon EC2, but let's go ahead and change this to AWS Lambda. This means that our employee directory application code would only be run in response to events being triggered by the front-end presentation layer. Now, you don't want your front end talking directly to your back-end code, so you would instead expose your back-end using an API. We would use the service Amazon API Gateway to host this API. Each action you could take on an employee would have its own method on the API. This API hosted on API Gateway would act as a front door to trigger the backend code, which we would host on AWS Lambda instead of EC2 as discussed. We could have one Lambda function handle all of the requests for employee data, or we could have one Lambda function for each action. We would keep DynamoDB for the database or the data layer, and we would also keep S3 for the employee photo storage. All of the access between these services would be handled via role-based access using IAM roles. One nice thing about this is notice how, because we built this solution in a modular way, we were able to swap out how we were handling the presentation and application layer while leaving the data layer totally intact with no modifications. That is the type of flexibility that can help you innovate and adapt quickly to changes. So now, for completeness and clarity, let's focus on the new architecture and fill it out a bit more. I will add some other AWS services to this diagram that you can explore on your own. First, I'm going to add Amazon Route 53 for domain name management and Amazon CloudFront here as well, which will allow us to cache those static assets like the HTML, CSS, and JavaScript closer to the end users by taking advantage of AWS Edge locations. If a user wants to visit the employee directory application website and view all of its employees, here's the flow. The user would first type in the domain for the website, which would get sent to Amazon Route 53. Route 53 would send back to the client the address of the static website being hosted on S3, and then the website would be rendered in the browser. This website has JavaScript making the API calls to the backend to load the dynamic content. So the API call to load all of the employees would be made, and it would hit API Gateway first. API Gateway would validate the request and then trigger the backend Lambda function. The Lambda function would then send an API call to DynamoDB to query the employees in the table, and it would return that data to API Gateway, which would then be returned to the JavaScript, which would finally be rendered on the page. All right, and that's that. With this architecture we just laid out, we have optimized for scalability, operational overhead, and depending on your usage, it could also be optimized for cost. The serverless aspects of this make the operations for support much less than compared with Amazon EC2-based workloads. There is no patching or AMI management when you use serverless solutions like AWS Lambda. Also, notice how it was not required that I create a VPC, subnets, security groups, or network access control lists for this solution. The networking aspect of this is managed for you, though you can integrate serverless services with your VPC if you need to for compliance reasons, but it's not required to get a solution up and running. You have many options to choose from when designing your application. You can imagine a scenario where you redesign the same application to be hosted using AWS container services, and then this entire diagram would change again. There are a lot of ways you can build on AWS, and that's the beauty of it. You can swap certain pieces of your solutions out as AWS services are released or gain new features. And because everything in AWS is an API call, you can automate the process along the way. That's it for this course. From me, Seth, Meowsy, and Fluffy, thank you so much for learning with us. One more reminder to please remember to delete any resources that you've created in your own AWS account for this class to avoid incurring any costs if you've been following along. Thanks again, and see you next time.
All right, and here we are on the instructor's office hours for the AWS Cloud Technical Essentials on digital training platforms. My name is Rafael Lopez, and I work with Morgan Willis, which is muted right now that I can see the little icon there. So here we go. Hi, Morgan. Good morning.
Hi, good morning. Thank you so much. Hi, my name is Morgan Willis. I'm also a senior cloud technologist on the DTP team, making digital courses for you all to learn more about AWS on websites like edX, Coursera, and Udemy. Today we're here for the instructor office hours for a specific course called the AWS Cloud Technical Essentials course. And this is essentially going to be just a place where we can talk and learn, and we can hopefully answer some of your questions. So we have some questions that we pulled out of the discussion forums that we would love to go over, but this is supposed to be an interactive session. So don't think of this like a webinar. We want you to utilize the Twitch chat, and we'll be keeping an eye on that chat. And so, Raf, why don't you go ahead and introduce our moderators as well?
Yeah, we have moderators here in the chat room. So please, moderators, say hi to our guests. We have Alan, Alana, Morgan, and John moderating the chat, so they will keep an eye on. They will keep posting links from things we show here, and we also have ASL interpreters, American Sign Language interpreters. So we have Whitney here on the screen doing the sign languages as well, and he is going to alternate with Danny, the other ASL interpreter. That's very welcoming, and thank you a lot. So let's see, where are you talking from? You can post on the chat. So hashtag not a webinar. This is supposed to be interactive, so we are looking to see your interaction back in the chat to talk with us. So I see that there is people from Texas in the chat. Sunrise east of Seattle. That's very good. Dallas, Texas. That's.
I'm joining from the state of Massachusetts here in the U.S. We have someone from India as well, Virginia also.
Bangladesh, super cool. New York, hello. So,
Awesome.
Greetings from Colombia. Where are you from Colombia? Are you in Medellin, Bogota? That's the only two cities I know. Western New York. Thank you very much. So, John probably is in Canada eating maple syrup. At this point, I think he drinks maple syrup.
Yeah, I was going to say, I don't think he eats it. He drinks maple syrup. So, it's a little bit of a difference there.
Cool. Very nice. All right.
All right. So I just kind of wanted to talk really quickly about, again, why we're here today. We're here for Instructor Office Hours. So this course that we've put out, the Cloud Technical Essentials course, this is for people that are enrolled in the course or maybe interested in the course, but especially people who are enrolled in the course. So to kind of get everybody warmed up and used to using the chat, I'm going to go ahead and share my screen, and let's do a quick poll. And I want to see how many people that are joined are currently enrolled in the AWS Cloud Technical Essentials course. So the way that you can interact with this is you can just type a 1 for yes, you are enrolled, or 2 for no. And don't worry about it. If you're not enrolled, you can still hang around and learn. We're going to cover all sorts of different topics today. So we're mostly going to be hopefully answering your questions. So I'm thinking of this as like your questions in the chat are like the first come, first serve. And then we also have some questions that we've pulled out of the discussion forums to answer some common issues. So the cloud, sorry, I have to turn on the percentages here so we can see it. There we go. So the Cloud Technical Essentials course covers the basics of AWS, starting with like, what is AWS, the global infrastructure, then we go through EC2 and networking, then storage and databases, and then finally we end with scalability using EC2 auto-scaling and elastic load balancing and CloudWatch. And throughout this course, there are labs, and we've seen a good amount of people getting hung up on the labs, on not being able to reach their EC2 instance, or maybe they don't quite understand a certain concept. So what we're planning on doing here is answering some of these questions. So we actually can see we have 42% right now that are enrolled in the course and 57% that aren't. So for those of you that are in the course, well, you probably recognize me because I'm one of the instructors for that course. Raf is not one of the instructors for that course, but he's on our team. And then Alana, who's the other instructor for that course, is in the chat right now as Leighton Lamb. So if you see that in the chat, that is Alana. So yeah, what we want to do now is just kind of start going through and answering your questions. So again, if you're not enrolled in the course, maybe go check it out. You can enroll on Coursera or edX. So if the moderators, if you can, I can see that Molly already posted in the chat the links to the courses. So if you are interested in learning more about AWS and you want to start from a beginner but geared towards technical audience, you can do that by joining and enrolling in the Cloud Technical Essentials course.
Yeah, and this course has 7 labs. So the first lab talks about creating an AWS account to follow the instructions. The second one creates an IAM role. The third one creates an EC2 instance. The fourth one does all the networking scaffolding. The fifth lab talks about storage. This sixth exercise talks about databases. We may call them exercises or labs. It's just the step-by-step instructions that we give you for providing some hands-on experience. The last lab, the seventh lab, talks about elastic load balancing. So it builds the architecture that Morgan is showing on her screen. And the thing is, on all those labs, they are independent, because we designed the labs in a way that you can stop everything after doing the lab, because you can do the lab on your own time. So you can do one lab today and another next week. So we don't want the resources being charged in your account. And that EC2 instance is something that you tier up and tier down for every lab. So if you get stuck on the creation of that instance, it may make the whole lab experience a little bit harder. So we found the most frequently asked questions. You like that, Morgan? The most frequent, like they are very frequent.
Very frequent.
The most FAQs on the forums, and by far the biggest one is, I cannot connect to my EC2 instance. Why? So we prepared, and I'm going to show you some troubleshooting tips for those specific steps on the lab, and some things that may be ongoing to prevent you from connecting on the instance, to preventing that from happening. So once you tackle that, you can successfully launch the EC2 instance and proceed with all the labs. And also, do not let any exercise step, any lab stop you from doing the course, because you can complete watching all the videos, reading all the readings, and doing all the quizzes, and leaving the labs to the end, right? So don't let the lab, if you get stuck in a step in the lab or so, you can continue in the course. So the first question, very common question, is, I cannot connect to my EC2 instance. Why? And let me share my screen here to show the exercise instructions, how they look like. This is the first exercise that you will have contact with the EC2 instance. It is the exercise that you will deploy a compute resource, in this case an EC2 instance. So the previous lab will ask you to create an IAM role, and this IAM role is the S3 DynamoDB full access role, right? So that role will already be created. Pretty easy. Go to IAM, create role, and everything. Then you will launch an EC2 instance, and you will put this user data in this instance. I am going to tell what this command does, and some things. Let me increase the font size here a little bit, and some things that you may get stuck if you don't do it properly. So the first instructions on the lab asks you to create an EC2 instance using Amazon Linux AMI, Amazon Linux 2, with the T2 micro size instance type, right, which will have one virtual CPU and 1 GB of memory. Then network, choose the default subnet. Every AWS account comes with default subnets that has an internet gateway attached to the VPC it belongs to. Auto-assign public IP enabled. Then you're going to choose the role you had created on the previous lab. So if you go to your AWS Management Console and click here in Launch Instance, in this button here, Launch Instances, you will see this instance creation wizard, where the first thing you will need to specify is the AMI, the Amazon Machine Image. Do not confuse with IAM, Identity Access Management. Here we are specifying the AMI. Same letters, different order. AMI, Amazon Machine Image, you are going to choose Amazon Linux, right? So this is what the lab asks you to do. Then you are going to choose T2 Micro. It's already pre-selected for me. So I just click in Configure Instance Details here. Configure Instance Details. And here is where I will specify what is the subnet, which I can leave untouched because it already chooses the default one for me. The IAM role, I will choose the IAM role that was created, which is this one here, right? So for this specific...
Raf, can I interrupt you real quick? Can you explain the default VPC? Because I think what I've been seeing in the discussion forums and hearing from students is they aren't able to connect to their instance after they launch it. So if you aren't selecting the default VPC, then you might not be getting some of the initial setup that makes it easy to have an instance publicly accessible. So can you kind of just quickly describe what the default VPC is?
Yeah. Every new AWS account or every account comes with a default VPC, virtual private cloud. So this VPC is what makes the network arrangements and the network locations for your EC2 instances. Every VPC comes with, not every VPC, the VPC that comes with your account come with default subnets, right? And an internet gateway attached to it. And those subnets, like subnet, those subnets, they are public because they have a route to this internet gateway. So if you place an EC2 instance within that EC2 instance will know how to reach the gateway in order to reach the internet. So if you have your users and your users connect to the public IP address of your instances, you will be using that connectivity. So the default VPC, which is the one that is indicated here, the default network and the default, which makes part of the default VPC, already comes with that routing configuration pre-built, right? So you choose the default one, and then if you enable auto-assign public IP, which is something that the instructions ask you to do here on the step 6, you will have that access. You will have that route already built. So you choose the IAM role. We will talk about IAM roles, users, and groups in a moment. This role should be previously created by the previous lab. And here is the user data. Here is where you put these commands here. So you should copy them and paste here. Now, some important aspects here. When you paste it here, the instructions will ask you to replace and to insert the AWS region you were using right here. Let me see if I can zoom in to make this bigger. Right, so it will ask you to insert the AWS region here. What you should do is this, right? You should type the API name of the region you are referring. You should not type something like that, right? You should type this, which is the API name for the given region. So if you're in California and you want to use US West 2 or US West 1 region, if you are in Asia Pacific, you can use AP Northeast 1. So if you see on the AWS documentation, there is a list of the region API names and their corresponding physical location. So it is also important to have no spaces here between this equal and this equal, right? So you should just replace this by the region API name. Okay.
And then I'm going to enter for a second here as well. So this is, really important whenever you're going through the lab. So just to kind of give some context, I realized I didn't give that for anybody who wasn't in the course. We have this application called the Employee Directory application, and it's essentially just a sample application that's written in Python using Flask. And so this user data script is a bash script that whenever the EC2 instance boots up for the first time, this will run, and it will download the public code. Like Raf is highlighting right now the line that's downloading the code from a public repository, and then it unzips it, and then it installs some different dependencies that code is going to have to run. And then it goes ahead and sets some environment variables like the name of the DynamoDB table, the bucket for S3, things like that, and the region. And then it goes ahead and it starts that code. So this is a bash script, which it's essentially code. So you want to make sure you're really careful about having extra characters. If it's just like any coding language, right? If you have one extra character somewhere, it can break the whole thing. So whenever you're working with EC2, if your user data script doesn't run correctly, it might not be entirely obvious right away. Like you'll go to try to access the EC2 instance and it just won't load. That's because the web server Flask isn't running because this script didn't run properly. So that's something that you want to make sure that you're aware of, is that this needs to be, essentially quote unquote perfect as far as not having any extra characters that would break the execution of the script.
Exactly. And sometimes it's harder to notice because the instance will boot up normally. It is just something that is running inside the instance that is not working properly, right? So the EC2 instance will show up as running, but whatever is running on that EC2 instance potentially could be broken because of a missing character here. And there is one interesting thing here, that is this stress application, the package that is installed. Yum is the Linux package manager, and we are installing an application called Stress on this EC2 instance. So Morgan, let me actually load your screen with the diagram, and can you tell a little bit more why that Stress, what that Stress package is doing inside that EC2 instance?
Sure. Sure. So this is a screenshot of the architecture that we built out throughout the course. So right now, Raf is showing you launching one EC2 instance, and he's launching it in the default VPC. But in the course, we build out a custom VPC, and then we launch our EC2 instance into it, add the database in the backend, which in the course, we end up using DynamoDB. But then after that, we say, okay, this is great, right? I have one EC2 instance, but what if I have, too many users that would overwhelm this one instance, right? Because one EC2 instance doesn't just automatically scale up and down. You have to put scaling mechanisms in place. So what we did is we built into the app we use this stress package that has a web page under the employee directory application where you can click a button that will stress the application. And then you can kind of simulate having a lot of users kind of flooding your app, or maybe the popularity of your app is going up. So what that allows you to do is then watch the CPU utilization on that instance go up over a certain amount of time. So whenever you have one instance, right, you don't want that to go down. We want to be scalable. So instead, what we do is we launch instances across multiple availability zones. So in this case here, we have 2 across availability zones. And then in order to do auto scaling, you put an elastic load balancer. And in this case, we end up using an ALB. So I'll just kind of write over that, an application load balancer. And then you also are using CloudWatch alarms. So the load balancer is forwarding traffic to the backend EC2 instances. And then we can simulate the stress using that stress package. And then we can watch the CloudWatch alarm go off, and it will then launch a brand new EC2 instance. And then we can watch that boot, and then you'll watch the CPU utilization come down after a certain amount of time. So that's what that stress package is.
Exactly. So that's why we have this package installed on the instance. You will launch this instance as part of this lab, and after the lab, you will terminate the instance. In the next lab, you will launch again, and the user data will mostly remain the same, with the difference that in the next lab, you will create an S3 bucket and put the bucket name here. So let's continue and add storage to our instance. An 8 GB root volume is okay. We can add tags to that instance, and the instruction asks you to ask a tag with the key name and the value. Let's see here. This is the value, employee directory app. So let me copy this from here, right? So employee directory app will be the name of my EC2 instance. And in the security group, it asks you to use a security group that has the port 80 opened. So I will click here, choose anywhere, and allow the port 80, which is the HTTP port, because this will be a public web server with the employee directory application running in the Flask application. You want to serve port 80. We are not connecting SSL certificates. We're not installing SSL certificates for now. If we would, then we would be opening the port 443, right? But for now, we are only working with the port 80 for this application. And the security group is a firewall layer that surrounds the instance. So you need to open the port for the security group to allow the traffic to allow inbound traffic. Once everything is ready here, according to the instructions, you are going to click in Review and Launch. Then you scroll down to this page, you review everything, ports open, write AMI, write user data. Then you click in Launch, and you have the option of choose a key pair to connect to the instance in case you need to troubleshoot something. It is not required for this specific lab because everything should run out of the box, and you should not need to connect on the EC2 instance to troubleshoot anything if everything goes right. In my case, I will add a key pair because I will want to log on this instance to show you something when talking about IAM roles. So you're clicking Launch Instance. And then after clicking Launch Instance, the instructions ask you to check if the instance passes the status check. And as soon as it passes the status check, you catch the public IPv4 address of the instance, and you try accessing that. So let's do it, right? Let's click in View Instances. Our instance is being created. Let me just make more space here. Employee directory app, which is this instance here. The instructions will ask you to go on this lower pane here and copy the public IPv4 address, right? And open a new tab and paste. And then it may not work. Why it may not work? It may not work because let's see if they come with something in the chat. to suggest that why this instance is not working, why my Google Chrome couldn't reach this page yet.
Right.
The biggest, yeah, go ahead.
I was going to say, pay close attention to the address bar, right? So does anybody have any idea why this won't connect? This is
Morgan,
where the troubleshooting part comes in.
I think that I chose a T2 micro instance that only has 1 CPU and 1 GB in memory, and I gave a bunch of instructions to that instance, right? So perhaps the instance is still doing that. So, right?
Yeah,
Perhaps the
right.
instance is still getting the zip file, uncompressing the application, installing MySQL, installing Python 3, installing all the requirements for the application, installing the things. So it's still cooking, right? And that's why when you go here, it's not ready yet. But then there is a catch here. Your browser may locally cache that failure, right? And you may try refreshing this page and you may still see the error because you had it cached. And actually, that happened with me yesterday when I was doing the lab for preparing this demo for you. It was cached, so I couldn't connect. So a trick that I give you is to copy the address bar and open an incognito window or in private window in your browser, or choose another browser, or open from your cell phone connected to a different network, and then you should see this. This is a result that shows that you correctly followed the instructions to create and launch the EC2 instance.
Right. So we have a couple people tuning into the chat here as well. So there's a few different things. So one of the things that could have happened is the security group not allowing it, right? So in this particular case, the answer was that it wasn't done bootstrapping. So it wasn't done downloading everything. But another answer might be maybe you didn't configure the security group correctly. That could be a potential answer. Another one is if you forgot to auto assign a public IP address. Whenever an EC2 instance launches, unless you auto assign a public IP address, it will only have a private IP, in which case you can't access it. So that could be another one. But then we also have a couple of other ideas here posted in the chat as well. So could be bootstrapping still. That was the problem in this case. And then a secondary problem is if you try to access it while it's bootstrapping and then you keep refreshing the page, like Rafa just mentioned, it could be caching that. So make sure you clear your cache. And then also you might have a network ACL. So we have security groups, which are instance level firewalls, but then we also have network ACLs, which are subnet level firewalls. So both of those things need to be in place in order for you to connect and get that connection established with your EC2 instance. Another thing as well is maybe it's your route table. So in this case, we're using the default VPC, but if you were using your own VPC, there's a chance maybe you didn't attach the internet gateway properly. There's a chance that the route table isn't configured properly. So I would make sure that you kind of check all of those networking things before you give up, right? And then the other thing too is this idea of HTTP versus HTTPS. So that's what Rafa is pointing to right now. So I'll go ahead and let you talk about that.
Yeah. So for convenience, the AWS Management Console allows you to click in Open Address, and then it gets that IP address and goes to your browser and opens it in a new tab for convenience. But the thing is that it opens HTTPS. So if you click here in Open Address, it will try to load HTTPS : and then the IP address. And we do not have SSL certificates in the instance, right? So the instructions are clear with that. Like, do not click, copy the IP address and go on a new tab and open it, because that's what happens. When you click here, it loads HTTPS, right? The link for that where this link points to is an HTTPS, right? So you may not also be able to connect because of that. And also, if you are using a corporate laptop, if you are on a corporate VPN network, sometimes HTTP requests to unknown IP addresses may be blocked by your firewall. So make sure you're not logged on any VPN when doing that, right? That mostly happens when you try to log over SSH to the instances or remote desktop. HTTP is less common, right? But it may happen. We've seen that happening sometimes. Me and Morgan, we were technical instructors delivering instructor-led training. So we had lots of close access with students doing labs and observing those labs. And in most corporate networks like HTTP, SSH and remote desktop access was not happening.
Yeah, they don't like it. So with this lab as well, you want to just make sure like that you're going through all the things that we just talked about for troubleshooting. But then also remember that if you, let's say you did mess up your user data and then you stopped the instance and then restarted it, something that a lot of people don't think about is the fact that user data by default is configured to only run on launch. So not start, but on the initial boot. So that means if I restart my instance, the user data is not going to run again. So if you had had an issue in your user data, and then you went in and you tried to fix it, it might not run again. So you can either change your, oh geez, sorry, I had a meeting pop up there. You can either change your user data to run on every boot, or you can always terminate the instance and start over with a new one. And for this particular lab, this is just a proof of concept. So notice we're not using HTTPS. We're using the default VPC. The database isn't set up. Our permissions are probably a little bit overly loose. And all of that is to try to make it easier for you to get it up and running. So you wouldn't want to do this the exact same way in production, because you would want to make sure that you have things like certificates in place for HTTPS and things like that.
Yeah, there is a question here from the chat asking, are Lightsail instances also part of the default VPC? Thanks for your question, by the way. Or that's just for EC2 instances. I use Lightsail because it's cheaper. So Lightsail, they are not part of a VPC you choose. It is because it is a fully managed service. It's part of another VPC, but it is a VPC. And there is a feature that called VPC peering, where once you have one VPC and another VPC, guess what VPC peering does? It helps you connecting those two VPCs. So if you already have some other VPC with private subnets, with databases, with other VPC resources like a Redshift cluster, an EMR cluster, and you want your Lightsail instance to access that, the way you do it is, according to this FAQ page, is by doing VPC peering, right? So I hope that answers your question about Lightsail and default VPCs. It is not part of a default VPC in your account. It's part of the Lightsail VPC, but you can do a VPC peering to connect to your VPCs. And it's pretty easy to configure a VPC peering. You just need the two VPC IDs. You go on the VPC console, create peering. You specify the ID of the VPC1. You specify the ID of the VPC2, and it creates a peering request. You accept that peering request, and then you adjust routing tables. So why don't we bring up a poll, Molly, Morgan? Go ahead.
Right before we do that, I do have one more question about certifications. So this was somebody, they already finished the foundational course, so great job on that. And they're wondering if we could talk about the difference between Solutions Architect and SysOps. So I just wanted to quickly pull up the certification page. And so the Solutions Architect course, or Solutions Architect certification, is going to be able to validate your ability to design and implement distributed systems. So it's definitely like on a larger scale. Like, let's say you have a particular use case that you need to design a system for. Maybe you're troubleshooting a system or redesigning a system to be more optimized. It's more about that aspect of things, whereas the SysOps administrator side of things is going to be more detailed down actually like doing the work, meaning like, can you deploy, manage, and operate on AWS, right? So it's a little bit more detailed. There's a difference between the two of these certifications. So I personally, you would say that the Cloud Technical Essentials course is more aligned with Solutions Architect. However, it also could be a baseline for you to begin to dive deeper to study for SysOps Administrator. So this Cloud Technical Essentials course is really designed specifically to be a little bit vague in the sense of application. You could take this course and then go on to dive deeper into developer, SysOps, or Solutions Architect. So I just wanted to cover this question here.
Yes, and let me show where they can find the other online courses we have. So this page here contains the courses that we offer and the platforms, and you can link here. You can click here on the platforms, and you are directed to that course on that platform. So we have data analytics course, cloud fundamentals course, developer course, machine learning, migration and transfer. So this is what we are talking about. The course that we are talking about here, the Cloud Technical Essentials, is one of those, right? So why don't we bring up a poll? Let me put your screen here. And there is a poll where our audience can interact back with us.
All
A
right.
network ACL
Oh,
filter.
actually, sorry, I wanted to show a different one. This one. Okay, let's do this question. All right, sorry about that. So what does an Amazon EC2 instance type indicate? And so again, you could just type in the chat 1, 2, 3, or 4. Is an Amazon EC2 instance type indicate the instance AMI and networking speed, the instance tenancy and instance billing, instance placement and instance size, or instance family and instance size?
Pretty good.
Looking
Look at
good.
that. Yeah. The good thing about those polls, and that's why it is interesting for you to participate, is that if we see that most people are doing the wrong answer, then we double click and then we explore more of that, right? So that's a good measurement on how deep we should dive on each topic that we are presenting here. I think we are ready to move forward to the next
Yeah,
question.
I agree. This is great. So this is the correct answer, is the instance family and instance size. So good job, everybody who answered this one. So the next one that I want to do is this one here. So which of the following pieces of information do you need to create a virtual private cloud or VPC? Is it the availability zone it will reside in, the subnet it will reside in, the group of subnets it will reside in, or the AWS region it will reside in?
You can type on the chat. Let's give some time for everybody to think. Which of the following pieces of information do you need to create a virtual private cloud?
Yep, so there's a few things that you need to know to create a VPC. We'll give a few more seconds here, let everybody get their answers in, especially because this one is a little bit split, right? So we'll let everybody get their guesses in. I'll go until 60 seconds and then I'll end the question. All right, 3, 2, 1, ending the question here. Okay, so the correct answer with 50% of the votes is the AWS region it will reside in. So I'm going to go ahead and just do a little bit of a drawing here. So whenever you create a VPC, say you have a VPC here, VPCs live inside of an AWS region. So I'm going to go ahead and draw my region here. So VPCs live inside of a region, and they also can span across as many AZs that exist inside of that region. So let's just say this is AZ 1, 2, and 3. So whenever you create a VPC, it's going to give you access, quote unquote, to all of the availability zones inside of a region. So in order to create your VPC, you have to know what region are you creating this VPC in. So the regions don't span across, the VPCs don't span across regions. They only span across availability zones. So you have to know what region you want to place this VPC in. And then you also have to know the CIDR range, which is the what chunk of IP addresses, how big of a chunk, and what numbers do you want for your private IP space. So those are the two things that you need to know here whenever you're creating a VPC. And this is something that's really important to understand as you're working and operating within AWS, because VPCs do not automatically span regions, you have to be able to devise solutions to allow for communications between AWS regions, between VPCs. So that's like Raf was talking about peering earlier. That's one of the ways that you can create connectivity between regions. Whereas connectivity between availability zones is a lot easier to facilitate because it's a VPC is already spanning all of the availability zones within that region. And then one of the other answers that was there was the subnets. Subnets are placed inside of availability zones. So those are kind of bound to a specific AZ. So you don't need to know the subnets before you create the VPC, because a subnet is actually a subset of the IP addresses that you create for that VPC. Right. So do we want to do any more polls here, or should we move on to the next question? What do we think?
Let's do one more poll.
Okay, awesome. All right, let's go ahead and do the network ACL one, since that's something we just went over. So network ACL filters traffic at the EC2 instance level, true or false?
I think the biggest ask of this question is network ECL versus security group. Which service operates on which scope, right? So
All right.
It's
This
good that
is
we
looking
have
good.
10 answers false. We can move forward. Pretty
Yeah,
good.
this is
Security
looking good.
groups operates on the EC2 level. Network ACLs operates on the VPC level, which is everything.
All right, so
network.
since everybody got that one correct, let's go ahead and do one more on this topic. So what must you do to allow resources in a public subnet to communicate with the internet? And select two. And whenever you're going through and selecting two, you have to type them in as two separate entries in the chat. So type like one number, hit enter, and then type the second number and hit enter. And that's how you can get them both to count.
I think you are giving them the correct answer.
Oh, did I? I ended the question instead of starting it. That's my bad. All right, so I'll just tell you the answer for this one. Yeah, that's funny. So it's the two that have the green check marks next to it is the answer. But you need to attach a internet gateway to your VPC. So that's the first thing, right? The internet gateway is your doorway to the internet. To allow traffic to flow into your VPC. So without the internet gateway, you can't allow traffic, which means that there can be no connectivity to your EC2 instance in a public subnet. Even if you say it's a public subnet, you need that internet gateway. And then the second thing you need to do is you need to create a route to the internet gateway from that subnet, and that allows that traffic to flow.
Yep.
All right.
So let's bring a question that was pretty common on the forum, which is which was not a question, but I assume it is a question. I cannot distinguish among the IAM users and IAM roles and IAM groups and their functionalities. So let me load my screen here now and show you this diagram and get my pen. So an IAM user is an IAM entity, identity access management entity, that will allow you to have a permanent connection to your AWS management console or to the AWS command line interface. If you're using the management console, you're going to use a username and password. If you're going to interact programmatically with AWS from within the command line or from within your source code, you will need access key ID and secret. And a user allow you to have a permanent one, right? The thing is, when you write a piece of code, when you have a Flask application, for example, doing things on Amazon DB or getting objects from Amazon S3, you will need a credential to configure that application, an IAM credential to configure on that application, right? And it is not very elegant and also not very safe to get your personal credentials and put in there. You should not do this, right? You should avoid getting your personal credentials and putting in your code. So what should we do? Some people create a separate user and call this user app and get the credentials from that user to put in the code. Well, although that's a little better than getting your personal credentials and putting there, it is also not recommended because you are also putting credentials into code. So if someone has access to your source code, it will also have access to the credentials that are used by this code to make API calls to your AWS services. The best practice in this is to create what we call an IAM role. So once you create an IAM role, you can associate that role with an AWS service, such as, for example, Amazon EC2. And when you do that, you declare what are the permissions of that role, right? And who can assume that role. This who can assume that role is also called trust relationship. And relationship. And the big difference between a role and a permanent IAM user is that the role is a mechanism that gives the ability of providing a temporary credential to whoever is authorized to assume this role. So when you create an IAM role, you can have the EC2 instance going on behalf of this role, right, to access the AWS resources. And let me give you an example. The employee directory app EC2 instance that we just created, it has a role because when we created the instance, we attached the IAM role there. It's called S3 DynamoDB full access role. So let's connect on this instance using EC2 Instance Connect, which is a very convenient way of having SSH straight out of your browser.
Yeah, if anybody is not familiar with EC2 Instance Connect, this is like one of the coolest things to come out of AWS in my experience, like in the last few years, as far as making things easier to use for, especially for a beginner. Definitely check out EC2 Instance Connect if you're like troubleshooting something on an EC2 instance. This is like a super easy way to get true SSH to your EC2 instances.
Yeah. So if I go here and type AWS configure, which is the command that I use to configure the command line with permanent credentials, you will see that I have none. In other words, you will see that my command line is not configured, right? It does not have credentials. But if I do AWS S3LS, it will work, right? And it does work because this instance is associated with a role that has permission to go to Amazon S3, as well as DynamoDB, right? And this is the role. IAM. If I go to my IAM console and click in roles right here on the sidebar, you will search for that S3 DynamoDB full access role. The instructions ask you to create a full access role just for educational purposes, just to have that POC, that server up and running quickly, right, for you to get started with AWS. We don't recommend overly permissive roles for production environments. So if you only need to access one specific DynamoDB table and one specific S3 bucket, you can restrict that on the role permissions, right? And you can see that this role permission has S3 full access and DynamoDB full access. So if you try to go on the instance and do AWS EC2 describe instances, -- region US East 1, this will fail because this role is not authorized to perform this action, right? So unless whatever is explicitly allowed here on IAM, it is denied. Kind of like a security group. Unless you go there and open the port, it is closed, right? So now one role can be assumed by an EC2 instance, as you just saw, right? EC2. But roles can also be assumed by IAM users. And what would be the reason of allowing a user to assume a role? Well, if you have multiple accounts, let's say you have 3 AWS accounts, one for dev, one for staging, where you and your QA analysts do the tests, and another account for prod. If you want to have access to those 3 AWS accounts, option 1, you can create one IAM user for yourself on each one of those accounts, which for obvious reasons is not recommended, because if you need to change the password, you would need to change the password on 3 accounts. What if now you want to have one account per application that you have, right? So you see that doesn't scale well. So a good practice here is to create one separate AWS account just for the users, just for all the users in your organization, and all the subsequent AWS accounts, you have roles on those accounts. And on those roles, trust relationship, then you specify which users can assume the roles. So instead of having permanent credentials on the other AWS accounts, you can just do an assume role, right?
Something else that's good to note here with this too is that the roles are they're shared. So it's not like you have to create like, oh, this
one
is
role
Raf.
per user.
Yeah, right. It's not one role per user. You can, me and Raf, if we were both developers on the same team and we had the same permissions, then we would likely be assuming the same role.
Yeah, and it gets pretty interesting because that AWS account, instead of having lots of users here, sometimes you are on a corporate domain controller, Microsoft Active Directory, and all your users are already belonging to a Microsoft Active Directory locally on your workspace. So what you can do is, instead of creating all the users in this account, you can create roles in this account, right? And the sub-accounts will also have the roles, and a role can be in another roles trust relationship. And you can do this, right? So that's the advantage of having roles assuming other roles. If you were working with governance and compliance and you want to concentrate all your users on the current user directory that you have as part of your organization, you can do that with some tools like ID connector and even single sign-on to jump from one account to another. And that's how enterprises do. That's how big companies running big workloads on AWS with complex architectures, multiple accounts, that's how they do securely, right? They did not create multiple IAM. They should not, at least, create multiple IAM users around multiple AWS accounts, right?
All right. So I do have another question on the chat, and I know it was answered in the chat, but I just want to answer it live so that anybody else.
I like
if
that.
Anybody else has a question?
A walk in the clouds. I like your.
Yeah.
I like your.
That is a great username.
Yeah.
Good. So a walk in the clouds asks, can a VPC peering be done with a region, or VPC peering is always cross-regional? And the answer is that you can do it within a region. So you can have many VPCs in one account in one region, and you might be using VPCs as like network separation between applications. But you might, like, let's say you have 3 VPCs in an AWS account, and you have applications that need to access shared services in the third VPC. You can still do peering even within a region. So I just wanted to answer that one as
Yeah.
well.
One interesting thing is that you can do peering within the region, cross-region, and cross-account. So if I am running, let's say, a machine learning cluster in my account, and I want to allow Morgan's private EC2 instances to connect to my cluster to do something, then I can do that cross VPC peering as well. I could also use a service called AWS Private Link for that, but it's cross-region, intra-region, and even cross-account, right? The
Yep.
VPC
And
peering.
so, and that's really important too, as if you're, especially if you're looking to be in an architect position for AWS, is that it's very unlikely that you'll just have one singular AWS account. It's overwhelmingly likely that you will have many AWS accounts for one organization, or even maybe even one team, depending on what you're doing. So being able to understand like where the boundaries of the services exist and how to reach across accounts or across regions is something that can be really very, very helpful. And so then I wanted to cover a couple of other things that I saw in the discussion forums, and this one relates to what Raf was just talking about. How is the EC2 instance in DynamoDB connected? So we're talking about, let me exit this EC2 instance. How is this EC2 instance connected to DynamoDB? Well, like Raf was just mentioning, that's IAM roles. But then on top of that, I also saw this question about the DynamoDB table that we're using for the employee directory app that I thought was really interesting. So we have in the DynamoDB table, there is this object key column for the item. And this is essentially pointing you to the S3 image. So let me go ahead and do some whiteboarding here. So we have, the way that the architecture works is we have our EC2 instance. We have an S3 bucket. And this has our images of our employees. So let's just say that's an employee image there. And then we also have our DynamoDB table. And with this DynamoDB table, this has an item for each employee. So the EC2 instance has this app here. And we had to allow full access to both DynamoDB and S3. So the reason for that is because we are not actually storing the images in DynamoDB. So we have no images here. But instead, all of the images are stored in S3. So one of the questions here is, are we storing the image in DynamoDB, or is this a reference to the S3 bucket? And the answer is that we store the image in S3, but then we store a reference to it in DynamoDB. So that reference ties the item, the entry for the employee in DynamoDB to their image in S3. And the reason for this is DynamoDB has a 400 KB limit per item. So you really don't want to store large items or large objects in DynamoDB. Instead, you would more likely use DynamoDB as an index.
Database.
Yeah, as a database and an index referencing your objects. So this DynamoDB is not object store, right? If you have an object associated with data, you would store it as a reference, and then your code can say this reference over here is related to this image. So I just wanted to bring that up there. And something else that you can do, just to talk about another architecture here, is if you have an EC2 instance, like with our employee directory app, right? We have our app here. And then you want to store some information in DynamoDB. And then you also have some images in S3 like we just did. Let's say you wanted to delete an image out of S3, right? Maybe you're deleting an employee. So if you wanted to delete an employee here, you could have the app go ahead and call DynamoDB, delete, and then you could also have it call delete over to S3. And if you have the app do this, then you are essentially relying on the code to keep these two things in sync, right? So you're relying on the developer writing the code to know and understand the data model that you have. So that way they know where to delete things from. So that's one way you could do it. Or if you wanted things to be a little bit more automatic, like on update or delete, or mostly delete, what you could do is you could have them submit the delete here, and then you could set up DynamoDB streams. So DDB streams. And then you could have this trigger a Lambda function, which then would delete the item out of S3. So this architecture does the same thing, except instead of having the developer be responsible for it here, you're instead kind of creating an architecture to do it automatically. So the benefit of this is essentially like, let's say your code had an error in the delete, like let's say you tried to delete the item in DynamoDB and then it threw some sort of exception and then your code crashed. You might have the entry in DynamoDB is no longer there, but the image is. That might be a problem for you. So with this solution here, you're submitting one delete and then it kicks off a series of transactions that then will delete it from S3. So this is a little bit more fault tolerant in that way, where you're not necessarily relying on the code to do it, but it really depends on what you're doing on which type of direction you would take. Like, would you bake these instructions into the code, or would you create an architecture that kind of does these sorts of things automatically? It's also important to note you would have to have some code here as well. It's just the code would be really simple and really small.
Yeah, on that matter where you have a Lambda function connecting to Amazon S3, there is a question here that Code with Sean brought. Let me bring the question on screen here. I have two Lambdas connecting to DynamoDB. One only needs read only, the other needs read and write. And that's the thing. I created two user accounts with key secret for the Lambdas to connect. Is this okay? Is there a better way? And
All right.
yes, there is a better way.
There is a better way. Yeah. So you want to look at roles. So let me go ahead and delete this. And let's say you have two Lambda functions, 1, 2, and you have an S3 bucket here. And this one needs read, and this one needs read write. You don't want to create IAM users for this, right? So IAM users have credentials that you can use for programmatic access to call these APIs using the SDKs. However, those keys are not temporary. You can rotate them, but they are permanent in the sense that, like, once you create them, until you deactivate them, you can use them. And you would have to bake those into the code in the Lambda function or the environment variables or something like that, which is not secure. So we recommend to not use IAM users, but instead you would want to use IAM roles, right? So this kind of comes back to that roles discussion. So this Lambda function that needs the read access, this would have role 1, and then the IAM or the Lambda function that needs the read write would have role 2. So you would have two separate IAM roles, and in the IAM role you would attach a policy to this first one that says specifically what bucket, what actions you would need. So you can get really granular, and we would suggest that if this is for anything beyond experimentation in your own personal account, that you are very specific about the types of permissions that you give to code and people. And so we say following the principle of least privilege, where you give people and entities exactly what they need and nothing else. So you would include the S3 bucket here, and you would also include that API call, whereas this role would be a separate role that has a totally separate set of permissions.
Yeah, and this is where you configure all that Morgan just showed. So on a Lambda function like this one I have here, my second function, if you click in configuration right here, click in configuration, then you click in permissions, you can specify what is the role name that you want for that function. So you would create two roles, right? And each function you associate with a different role that would match Morgan's diagram right there.
All right. So all right, so we have another question here. Is DynamoDB a good option for an online shopping cart? What are other storage options for a shopping cart? So I would say that DynamoDB is a great option for this. So DynamoDB is a key value pair. So the nice thing about that is, like, if you have a shopping cart, you would have your user session. So DynamoDB is a great database for storing user sessions in a place that is not necessarily ephemeral. So you can put it somewhere where it's going to be stored, and then you can set like a time to live where it expires after a certain amount of time, but you know it's safe for that amount of time. Whereas comparing that to like instance storage, if the instance went down, then your user session would as well. So we recommend storing things like this shopping cart information, session information off of the instance in a database or a cache of some sort. So DynamoDB is a great option for this because you can have items that don't necessarily all have the same data. So like one person's session in shopping cart might not look the same as another person's session in shopping cart as far as schema. And you can do that with DynamoDB fairly easily. But another option you could use here is maybe Elasticache. So you could have an Elasticache cluster as well. It's really up to you on like how often are you using this? How much usage do you have? And then you can do a cost analysis. So like I personally prefer DynamoDB because it's serverless, it's super easy to use, and you can scale it up and down with usage fairly easily, meaning that you only pay for what you consume. Whereas with Elasticache, I'm pretty sure it's an hourly rate. So I personally prefer DynamoDB for this one.
Yeah. Oops. Alan just said on the chat, like, we have a class both on edX and Coursera that focuses on DynamoDB. So if you're looking for more information,
yeah, I'm actually one of the instructors for that course too. So there's a DynamoDB course on both Coursera and edX, and that one starts off with the basics of like, what is a table, what are items, what is NoSQL, and then it progresses from there, getting into indexes and local secondary, global secondary indexes, how to provision throughput, things like that. And then in the last week, it goes deep diving into single table design. So that's a really great course for a deep dive on DynamoDB, especially if you're a developer type. We use mostly the command line in that course, but it's a great one.
Yeah, this is the one we are talking about on Coursera and also on edX, right? So you can find information right there.
All right, I think we are coming up here at the end, but let's see if we have any more questions. All right, I don't know if we have time to answer any more here. Raf, do you have anything else you want to finish up with?
No, that's there is one here. Is there a tutorial to use AWS SNS to send HTML email? We can try finding some references on that, but I'm
The
pretty sure.
moderators might be able to find some stuff here.
Yeah.
All right, so I think the last thing here is just kind of if you are currently enrolled in the Technical Essentials course, please hop back in, check it out, go through. Hopefully the things we talked about today give you a bit of a deeper understanding. And if you're blocked on the labs, hopefully some of the things and the tips we talked about will unblock you on those labs. And also remember that the labs themselves are not a blocker to learning the information, right? So you can, if you get stuck on a lab, you can keep going past that lab, and then you can come back to it later. So keep that in mind. And if you are not enrolled in the course, please go check it out. It's a great fundamental course. It's geared towards people with a technical background. So yeah, thank you all so much for attending. I really appreciate all the questions and the engagement that we were able to have during this last hour.
Yeah, thank you everybody